Oh, that's cool. Oh.
Our T0 for our launch today is at 1:04 a.m. Eastern Time.
All right. Guys, I'll be back in a second.
We have a special launch broadcast that will start at 10:30 p.m. Eastern Time. And that will happen right here on NASA's main channel. Operational commentary, which you're watching right now, will continue on NASA's media channel. You can find both of them on YouTube. We have a 2-hour launch window tonight, which the launch team likes having a long launch window just in case they run into some weather. But the launch weather officer has reported that we're 80% go for launch weather. It's not expecting to run into that tonight, and hopefully that holds. Throughout the night, we've been sharing the various stages of the Artemis 1 mission with you. And with just about 7 hours and 12 minutes left in the countdown, we want to take a look at the big moment, liftoff, and what you can expect to see on the Space Launch System and Orion.
During liftoff and ascent, SLS produces 8.8 million pounds of thrust to accelerate the rocket that weighs nearly 6 million pounds towards orbit. Approximately 2 minutes into the mission, the boosters will have consumed all of their solid propellant and are safely released. The rocket continues to propel toward orbit. After 3 minutes, Orion's service module fairings are jettisoned to lighten the load and expose its solar arrays, having completed their job protecting the arrays from aerodynamic forces. 40 seconds later, the launch abort system is jettisoned. Orion could safely abort at any time. About 8 minutes after launch, the SLS core stage engines shut down, and the stage separates. The interim cryogenic propulsion stage, or ICPS, will give Orion the big push it needs to leave Earth's orbit and head toward the Moon. Orion's 4 solar arrays deploy to convert the sun's energy into electricity to power the spacecraft, charging its batteries for power when it moves out of direct sunlight. The upper stage engine ignites to elevate the spacecraft and fully enter Earth orbit, targeting conditions for the maneuver that will send Orion to the Moon. Engineers at Mission Control in Houston will perform one last check on Orion systems prior to committing to the Translunar Injection, or TLI. The TLI maneuver breaks the bonds of Earth's gravity and sets the spacecraft on a course for the Moon. The interim cryogenic propulsion stage fires the RL-10 engine to complete the TLI burn that lasts about 20 minutes and increases the spacecraft's speed to more than 9,000 feet per second. Following TLI, Orion is committed to a lunar trajectory just 90 minutes after launch. The Orion stage adapter that connected Orion to the upper stage of the rocket will remain with the interim cryogenic propulsion stage as Orion separates from the stage about 2 hours after launch. Then 10 small satellites known as CubeSats will leave the Orion stage adapter and use their own propulsion systems to go to destinations including the Moon to perform experiments and technology demonstrations.
And now we want to put up our countdown clock for you. This is the T clock that you see in the upper left-hand corner of your screen. This reflects the time that the launch team is counting down, but does not include a half-hour hold that we have coming up. So the actual time until launch is 7 hours and 8 minutes.
Discovery, go and throttle
But we are 6 hours and 38 minutes away from going into a half-hour hold. And then once that half-hour hold is finished, they'll go into terminal count and the final T minus 10 minutes. To learn more about Artemis 1 and our mission around the moon, go to our website at nasa.gov/Artemis-1. nasa.gov/Artemis-1. It's nighttime here on the east coast of Florida, and we continue counting down to liftoff. Currently in fast fill for both the core stage liquid oxygen and liquid hydrogen tank. We've got another couple hours of that for the core stage. So far, the launch team not working any major issues. The range is go. Our weather is good, 80% go. Liquid hydrogen will finish in about an hour, and we'll be able to get started working the upper stage tanking. For now, this is Artemis Launch Control.
All right, dudes. I'm back. Got to take care of business and make food. Pizza, man. Nice, MC. What'd you get? Pizza Hut. While you were away. Oh, 24-month resub. Thank you very much. This rocket got hit by a hurricane. Remember that. It is cheap. Yep. NASA just announced that SpaceX will, provide a second crew landing demo on the moon as part of the Artemis 4 mission. With multiple planned lunar landers from SpaceX and future partners, NASA will be better positioned to accomplish our goals. Oh, that's actually a really, really big deal. Bunch of good stuff today, man. I have no idea, Helpish. I don't know. Precisely, Amanda. Mm-hmm. It gets better. We have 4 Falcon 9s after this. After what? After SLS? Wait a minute. Oh my goodness. Starlink on Thursday. Eutelsat 10 on Sunday. CRS 26 on Monday. I guess I didn't need that far night. That's crazy. Doesn't matter. I did say I wanted this to be absolutely sure. Should I drive to Titusville? I want to see it go up. Is it likely to be less crowded tonight? I don't think it will be less crowded, Faulty. Which panel should we replace? Probably that one. Mr. Popsicle, how are you? Have they said if Starship HLS is disposable? I don't think they're going to reuse it, Lewis. Yeah. What are you having for food? I got pizza right now, dudes. Zizep, could you make it in time if you drive? Well, no. Maybe if you got on a plane right now, maybe. Yeah, it's very interesting, Lewis. Yeah. Let's meet on Satellite Beach by Patrick Air Force Base. There you go. Yeah, we are go 104 p.m. or a.m. Eastern. It takes 12 hours for you by plane? 12 hours? Oh, no, yeah, that's not happening for you. There you go, Faulty. The checkerboard is for tracking. Yep, that's right, Tech.
Discovery, go at throttle up.
Hey, Mab. 42-month resub. Lunch it. You want me to eat lunch? All right, that's what I'm doing. There you go, Gujar. I was actually working on the truck, King. I'm just taking a break right now. Eat some food. Then we got to find an oil leak on the truck. We got to figure out what's wrong. Yeah, we'll be keeping updates on this. I will pick up the commentary for this probably about 3 hours out. There you go, Joe. Right on, dude. Nope, no issues with the rocket. They bled the engine, guys. They're in LOX LH2 fast fill right now. The rocket is pretty tanked, actually. I noticed in your boat you forgot the fire suppression system, Bush League. Well, you gonna sit there like a pansy and point the problem out, or you actually gonna fix something? Gonna play some KSP? I might, Cody, maybe. Fixing the fuel system right now, I got a long list. Well, why are you talking then? Fix it. Nope, no issues loading hydrogen. Check NSF, they're tapped into the pad camera, zoomed in on an aft SRB strut. That's cool too, I guess. Now that's a strut. Now that's how you strut. Have you seen that NASA Spaceflight partnered with Northrop Grumman? No, I haven't seen it. How thick is that strut? Grapefruit. And it's not steel, it's aluminum. Nice, Forge. All that hardware is going to look good burning up in the atmosphere, I guess. Are these SRBs packed differently than the shuttle? Probably. Slightly different ascent trajectory. SLS is going to launch on an extremely lofted trajectory compared to the shuttle. Meaning she's not going to tilt over like the shuttle does. The final insertion altitude, or the insertion orbit parameters for that NASA's really looking for is 1,000 nautical miles by 20 nautical miles. So, yeah, that's really high up. So 1,000 nautical miles is about 1,100 statute miles, or probably, what is it, like 1,700 kilometer apogee? 17, somewhere around there. Yeah, it's a really high orbit, and yeah, so it's gonna be a lot steeper of a trajectory.
And we are now half full of liquid oxygen. You're looking there at a shot of the liquid oxygen tank venting.
It's an aft SRB strut.
That's super cold.
It holds the SRB to the core stage.
Gas
it's not a shock
meeting
absorber.
The humid Florida air and turning into vapor. And there's a look at the numbers. On your left, you can see the core stage liquid oxygen is more than 50% full.
WD-40, NASA does not use load and go like SpaceX. They'll tank the rocket fully, and then the astronauts would approach the rocket like an hour before launch. This one is uncrewed. There's nobody on this one. NASA fills up the tanks first. The thing about rockets is that when you're tanking a liquid fuel rocket, that's the most dangerous point. It's pretty dang safe when the rocket's fully fueled. You can get near it, no problem. It's not as safe as the rocket with no fuel in it, but it's still pretty dang safe. It's filling the rocket with fuel. When you put the rocket through a lot of transients, especially with a rocket like this, hydrogen and oxygen, you're cooling everything down. Everything expands and, well, nothing expands. Everything contracts, I should say. I was about to say everything is expanding and contracting. No. You're replacing gas purge tanks with liquid fuel. And on top of that, that liquid fuel is extremely freaking cold. And it's also a liquid. Liquid's not gas. You're changing a lot of variables on your rocket all at once when you go to fuel. Temperature, pressure, state of matter. So fueling rockets is the dangerous part. And that's why, well, like when SpaceX goes to launch with Falcon 9, the launch escape system is armed when they go to fuel the rocket. Because the fueling is dangerous. But being next to a fully topped off rocket, not very bad. Please remind me what Artemis will do. It's shooting an Orion capsule to a orbit around the moon, and the Orion capsule is going to stay there for a week. Yep. Hey, man, that was Jim's idea. Pretty smart. Jim's smart, dude. He's a smart dude. No moon landing. This is a test flight. 1:04, Hydra. 1:04 p.m. Eastern Time. Did I say p.m.? I meant a.m. Bear with me. Yeah, 1:04 a.m. Excuse me. We have about 6 hour 45. I really hope this is a successful moon landing. Deniers will have a field day if this goes pop. Why even thinking about them, dude? Why you let them live in your head rent free? Screw them. What do they know? Don't put someone that's that stupid on equal footing with you. Why would you do that? Screw them. Who cares? I know where it's going. You know where it's going. I can prove with math where the frickin' thing is going. You know? Frick that, dude. I'm going to the moon today. Hell with those people. They found yeah, of course, Isaac. NASA has press conferences almost every week telling with updates, dude. And I listened to pretty much every single one of them. Yeah, the hydrogen leak from last month was a seal that got pinched when they were torquing the TSMU, tail surface mass carrier umbilical plate down. It pinched it. It pinched the gasket. It happens. That happens. Dude, that happens. That definitely happens all the time. Happens with cars all the freaking time. You pinch a gasket if you over torque. Why were they torquing it down so much? Well, they needed to retorque it because hydrogen. You want to hear another freaking thing? You want to hear another reason why hydrogen's tricky to use? They have the plates attached, right? Think about this for a second. What happens when you flow hydrogen through the plate? It's going to get freaking cold. The whole thing will contract. And guess what? The bolts contract. They will contract and they will actually back themselves out. The bolts will back themselves out because they get so freaking cold. They will actually unscrew. The torque spec will be wrong. Isn't that nuts? Hydrogen, man, it's tough, dude. It's really tough to work with. Oh, what's Daryl saying? Oh, they got all the kinks worked out, ARJ. That's all. Dude, I said it once, I'll say it again. Said it once, I'll say it again. Look, all those launch attempts, all those wet dress rehearsals, everything, all the freaking problems that they had, the hurricane, the rollback, dude, this is great freaking data. It's great data. And everybody called me weird at the time. No, this is excellent data. How often are you going to be in a scenario where your rocket can get hit by a hurricane? Now, I know you don't want your rocket to get destroyed by a hurricane, right? Like, that would be bad. But, dude, they have data. Like, you can't replicate data like that. You can't do tests for your rocket getting hit by a hurricane. Oh, it's great data. This is perfect. Dude, this thing, oh, man. And now you're learning about all these unknown unknowns. All this stuff gets done, and it's better if it happens now. You don't want this happening to Core Stage 2. Core Stage 2 get hit by Artemis 2 gets hit by a hurricane, and I don't know if it's going to be fine. No, now they know. Now they have proven their analysis. They've proven the analytical work for the wind speed stuff. Dude, you proved it. You didn't even have to test for it. It's great. The data is fantastic. You're getting data on rollbacks. You're getting data on FTS battery life. Dude, you're getting data on SRB fuel longevity. Oh, it's perfect, man. This is great. I want all the problems to happen now. They should be happening now. This is when you should find this stuff out. This is great. It's great. It's free data for you, Jim. It's free data.
Discovery, go at throttle up.
Jim Free, come get your damn data. Don't get better than this. It's free data. True facts. Laboratory hurricanes are expensive. It's free real estate. Dude, you can't get... Dude, this thing has been through the damn ringer. Seriously. Not static fire. They did 2 green runs with it. They did 2 wet dress rehearsals with it. 3 launch attempts. Numerous rollbacks. It got hit by a hurricane, and it's still standing. This will be a testament for all future SLS cores of how strong they actually are. You proved it. Oh, this is great, man. It's gonna make this thing super reliable. They just have to, launch the thing. You do have to get to that. In terms of ground operations, it's plenty of great data. It's really good. Really good stuff. Rocket Guy said this is a shorter duration mission. Will there be any mission differences compared to a full duration mission? With a longer duration mission, Sirius, your Orion spends 2 weeks at the moon instead of 1 week. Now, why did they choose for a short duration mission for this? Long story short, the moon has to be in the right place for a long duration mission. Yeah, Zion, here's the thing. As I get older and I learn more about rocket science, dude, there are unknowns, there are unknown unknowns, and unknown unknowns happen. Like, you don't know. I don't know if it's going to work. I have no idea. But there are people that get paid way more than me that are here and tasked to making sure that this thing does work. I trust those people. I've listened to those people. I've listened to those press conferences, man. I listen to every single one of them. They know what they're doing. I know they know what they're doing. You can just tell by the way they're running the show. They really know what they're doing. There's some really, really talented personnel behind this. Is the ETA on the NASA stream... Is the ETA on the NASA stream till launch or possible launch window? They will go into a planned hold, Quack. In a little bit. They'll go into a planned hold. So... Why do they have planned holds? Planned holds are there in case there is an operation that you have to do on the rocket that takes a little bit more time. There are certain tasks that might take indeterminate amounts of time. For instance, on the last launch attempt, it took a lot longer of time to fuel the damn thing, right? That's why they have planned holds. Make sense? What are they giving up that second week? More data. They're giving up more data, guys. Yeah, they're giving up more data on the mission. The reason why they're giving up more data on the mission is because we're getting awfully close till Artemis. We're getting awfully close to Artemis 2's launch campaign. Yeah. Launch campaigns take months, years, depending on the mission. Like, you know, President Kennedy didn't say, "Oh, we choose to go to the moon," and then NASA's like, "Hey, we're at the moon the next day. We just called for pizza. Now we're here. Hey." No, it takes time. It takes years. Especially with these Artemis missions. These are complicated missions, man. This is big league stuff. I mean, you'll see SpaceX. And Elon will tell you the same thing. It's difficult to go beyond low Earth orbit. Heck, it's difficult to go to low Earth orbit. That's no easy task, man. But this, dude, get ready. This is some big league stuff. It's a totally different vibe to Falcon 9 launches, guys. And I'm so happy that I could, you guys came here and I could share it with you. It is hardcore. So freaking cool. That's right, Joe. Yeah, absolutely, man. Dude, long lead stuff for Artemis 2 is already in the pipe. And they're already starting the launch campaign. And guess what, guys? Artemis 1 is going to use parts from that Orion capsule in Artemis 2. They're going to reuse components. So, yeah, it's going to be sweet, dude. It's going to be sweet. Joe, where's my banana for scale? Here, it's the Chromana. Here. Where's my banana for scale, bro? SLS cost? The cost? I mean, chillin', here's the thing. It's expensive. It's very expensive. I mean, conservative estimates put this launch at $1 billion for the whole Artemis 1 mission. $1 billion. And I'd say that's probably right. It's people have said it could get up to $3 billion a launch. But there's something important to understand here. So one, NASA has to be transparent about their costs. They have to. By law, they have to tell us how much it costs. As a taxpayer, I have a right to know. Second part of that. The way NASA does their economics, all right, they rope the entire cost of putting that vehicle on the pad and sending it to the moon and bringing it back. You have your total cost involved. So think about this for a second. TCI, total cost involved, is what it means. How much money is it going to cost to go from literally an empty field to a fully built rocket sitting on a pad, getting ready to go and executing its mission? How much is that going to cost? That is why you carry such a heavy price tag here. It is the entire thing. $1 billion for launch is the amount of money it takes to get the factory set up, all the tooling, all the engineers, all the technicians that you need. You're getting Michoud figured out, getting Stennis figured out, getting Kennedy figured out, all the infrastructure that you need to get Kennedy up to snuff to launch a rocket like this. Retooling the VAB, refurbishing the crawler, keeping the lights on in the VAB, keeping the crawler way intact so you can move rockets back and
Discovery,
forth,
go at throttle up.
turning basin maintenance costs, Pegasus, the barge that moves the core around, all of that is roped into your launch cost with how NASA budgets stuff out. That's really, really important to understand. I don't know why they don't say this. Because they just say, oh yeah, it's going to cost about $1 billion to launch it. And everyone goes, what? What? What do you mean?
Discovery, go at throttle up.
Hey, Jack, what's going on? Is there a launch tonight? Neeper, we're going to the moon tonight, baby. In an uncrewed
Discovery,
capacity.
go at throttle up.
But we going to the moon. Age of Smart, 23-month resub. Thank you. So, think about that, dude. You're going from nothing to this. I'd say for $2 billion, going from nothing to this is not, dude, that's a bargain. You'd be hard pressed to find a better price. And I know what people are thinking. Oh, what about SpaceX? What about space? You think Boca Chica is built for less than $2 billion? You think Starbase has less than a multi-billion-dollar investment? I highly doubt that. Now, if you're still not sold on SLS, I don't get it. I don't blame you. I get it. I get it. I was about to say I don't get it. Well, first of all, I want more rockets. The only thing better than one way of going to the moon is two ways to get to the moon. Second of all, Starship and SLS are by law have to work with each other, so that's pretty cool. Third thing is, and this is the key. Now, here's my beef with SLS. Here's the beef. Where's the beef? Ah, that's an old reference. I just dated myself. The big thing is that they're not launching it enough. Because right now, you're at $1 billion price point per launch, which is horrible. 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 But you're roping R&D into it. So the more you launch SLS, the more the price goes down. If you buy it in bulk, like they did during the Apollo program, price goes down even more. That's how they did it during the Apollo program. That's what they did to make sure the cost of the Apollo program didn't spiral out of control. They bought in bulk. They bought 20 Saturn Vs and said, all right, we're good till all the way out to the late Apollo missions. We're good. And then they didn't even use some of them, which is messed up, but whatever. Also beef. It predates you, EJ. You're good. Where's the beef? Yeah, that's true. It kind of does, doesn't it? I came in on the tail end of that. But anyway. So, if you think about it, all told, $1 billion a launch, $2 billion a launch, that ain't that bad. That ain't that bad considering what you're getting here. Think about it, dudes. Noodle on it a little bit. Seriously, you think Starship, the first Starship launch, if we use NASA's metric for budgeting cost, the first Starship orbital test flight, which I'm just equally as gung-ho about, might I add. We're going to watch that and it's going to be freaking sweet. I want to see those 33 Raptors go off just as much as the next guy, right? Am I right? Yeah, baby, that's going to be awesome. Now, I'll bet you if they were using total cost involved, I'll bet you that the first OFT would cost probably more than SLS. Why do I think that? Well, first of all, it's going to cost more because it's reusable. Yeah, it's reusable. Reusable. A lot more engines, too. SLS doesn't have that many engines. 8 propulsion engines, 4 RS-25s, 2 5-segment SRBs, 1 RL-10B2, and 1 AJ-10-190. How many engines Super Heavy and Starship have? 33 plus 9?
Discovery, go at throttle up.
It's probably more expensive. But here's the thing. Here's the difference between SLS and Starship. You know that SpaceX wants to make that thing fly a lot. That's the key. That's the difference. Total cost involved will go down over time the more you fly. The more you fly, the more the price goes down. Doesn't matter how big of a launch vehicle you make. Think about it. It's pretty smart, dude. Nuclear 35-month resub. Thank you. It's pretty smart. Which one has more power, though? Oh, dude. Super Heavy has like double the power of SLS. 72 meganewtons at liftoff. That's 15 million pounds of thrust, meaning that Starship Super Heavy's first stage pushes up with the same amount of force that 15 million pounds of concrete would push down on the ground. Yeah, that's a lot. Yeah. Yeah, can you imagine if you had a 15 million pound block of concrete and you let it go? Anything underneath it is going to get squished. I hope nobody you knew was under that. We are at 100% hydrogen topping off on SLS here. They also developed those engines for the program while SLS used existing technology. Yeah, Aqualex, bingo. That's right, dude. I'll bet you if you manage total cost involved, Starship is more expensive per launch if they were using TCI, but SpaceX doesn't use TCI because they don't have a fiduciary responsibility to disclose costs to us because they are a private company. NASA, on the other hand, is beholden to the taxpayers. They have to tell us how much it costs, which is why NASA stuff seems to carry an amazing price tag. But it's dude, I'm telling you, for what you're getting, it's really not too bad. Like, take it from your boy. I spend a lot of time reading about this stuff, man. Y'all got any more of those rocket stats? Y'all got any more of those? No, I spend a lot of time reading about this. Economics kind of, it lines up. It makes sense. The economics of it all lines up pretty dang well. LH2 at 100%, 20 minutes early. I told you, man. All those wet dress rehearsals, banana time, all those launch attempts, that's just more data. They're hitting it out of the park. They're batting 1,000 thus far. And I'm damn proud of NASA right now. They're doing real good. Real good. Up on the timeline with a rocket this damn complicated. Yeah, okay. Real good stuff. Did it launch? No, not yet. No, not yet. Soon though. No, actually not soon. We're still about 6 hours out, or no, 6.5 hours out from the launch. I'm still surprised it didn't get that much damage during Nicole. Sneaky is because SLS is a Chad tier rocket and does not care about your hurricane. Okay, we don't care about your hurricane. We don't care about your hurricane, boy. Was Orion during the Constellation program? Was it supposed to use the AJ-10-190 or some other engine? It was supposed to use the 190, Cody. Yep. Yeah, more shots. Once again, I'm not hating on SpaceX, and I ain't hating on SLS. I'm not hating on Starship. I'm not hating on anything. I want more rockets. I'll cheer them all on equally. I don't care. This thing is sweet. This thing is sweet. Oh, you know how many people it took to freaking build this? This is great. It's going to the moon, man. 6 hours. We're going to the moon. Oh, I've been waiting for this since I was a kid. Ah! The Chad tier rocket. It's orange, man. Orange rocket, good. A rocket's pressurized with something while they're sitting on the pad before refueling. Yep. Jawohl. Jonas, nitrogen. Yeah, they inert them. They inert them first. Simmer down, you have 6 hours to go. Yeah, I know, man, but the moon. The moon, that stupid thing that's up in the sky. We're going there. This is the first time NASA's going to send a human-rated spacecraft beyond low Earth orbit since December of 1972. It's been 50 years, bro. It's been 50 years. Why? It's been 50 years. Oh, great. We're going to visit a rock. No, it is a basaltic rock. Okay. Differences. We're topped on hydrogen. They're slow filling locks. I wonder why they're in slow fill. Wait, it's not made of cheese? You know what, zombie? It's not made of cheese. No. It's not made of cheese. But, you know, we're talking about the moon and stuff. Did you guys know that Apollo 17 was that was the only Apollo mission that had a actual scientist on it? Jack Schmitt. So Harrison Schmitt, he's a geologist. So that means during Apollo 17, him and Gene Cernan went digging around. You know what they figured out? The moon ain't made out of cheese. No. It's made out of cinnamon. That picture is not color corrected. They found orange soil up there. Ah. So it might be, I'm not saying it's not made out of cheese. It could be made, we know it's made out of cinnamon. There's some cinnamon in the ground right there. That's what I see. But it could be made out of cheese. Could be. Could be. It's like Cinnamon Toast Crunch. What in the Cinnamon Toast frick is this? It's cumin. Yep. True story. Yeah, you guys got to go listen to that. Go listen to that, Apollo 17. They're digging. And they went, what the frick? It's orange. It's orange soil. What the hell?
Go at throttle up.
Go to throttle up, Tannerin. So I once told my wife to embrace her mistakes. She went and hugged me. Ooh. Ooh. Oh. Well then. Yeah, orange! Yeah, it's orange. Yep. Great footage. Damn you, spinning circle of death. It's corn! It's moon! It has the moon rocks. Is that still a thing? Didn't Apollo 17 have the longest EVA time? Yeah, dude. Zombie. Okay, so you guys want to hear another fun fact? Apollo 17 drove their moon rover the equivalent of the length of Manhattan away from the landing site. Think about that for a second. You're on the moon, you get in the car, and you go, and you drive till you can't see the landing site anymore. That's ridiculous. Think about how nutty that actually freaking is. That's insane. The LH2 core tank is in replenish. No GPS. Yeah, exactly. You don't got no sat nav, boy. Think about how nuts that actually is. Is that crazy or what? Been a busy week. I'm still going to wake up at 6 a.m. Please don't scrub now. No, everything's looking okay. Imagine forgetting which way you came. Well, you don't need to worry about that. You're making tracks, and to be honest, Zombie, the tracks are still up there. We've seen them with the Lunar Reconnaissance Orbiter. The tracks are still there. Yeah, I know, Porky Spot. Isn't that sweet? That's what reminded me of it. Orange. So it's still orange. Yeah, it's good stuff, man. What's stoic for hydrogen? I think it's 6 to 4. I think. I'm pulling that one out of my tail. I could be wrong. Last, please. Hadn't they had big problems with moon dust? Yeah, eventually. Moon dust is like that damn California dust. It's like talcum powder. Gets everywhere. And if you inhale it, it's not good for you. Turns out, Chief, that putting anything in your lungs that's not nitrogen and oxygen is bad for it. Yeah, bad for them. There's 2 of them. Orang soil, Orang rocket. Coincidence? I think not. No, it's not coarse and rough. It's very fine and smooth. And it gets everywhere. Yes, sneaky. Yeah. There's something people don't realize with the moon. On the surface, you have 0 reference for object size. No trees. So a small hill can in reality be a mountain miles away. Also, because the horizon line is closer, distances are even harder to guess. They drove like 5 miles. No, I think they didn't drive the length of Manhattan. I think the total mileage on the rover was the length of Manhattan. I think they drove like 4 or 5 miles away from the landing site, which is absurd. That's scary, dude. What if you puncture your suit? What are you going to do? Drive back? Scary, man. The Apollo missions were ballsy. They were real ballsy. And guess what? We're getting back to doing that. We're getting back to doing it right now. Well, in 5 hours, but you get the idea. Gaff tape. You know what, Grant? That is literally the solution. You got a punch in your suit? Duct tape it. It's what duct tape is supposed to do. It'll work. What if you pop a tire? The tires weren't inflated, Smuck. GM and I think Goodyear, I think it was, came up with the tires for the lunar rover. My stream is toast, guys. I can't load up the Artemis pre-launch stream. It's stuck at 556.09. Actually, Flex Seal might actually work, but you might Flex Seal the suit to yourself on the inside, and I don't think you'd want that. Refresh, it's good for you. Yeah, nope. Refreshing doesn't do it. It's stuck at 556 on the dot. Yeah, that's the stream I have open. Here, look. I will show you. Flex Seal's the new hotness. Try regular NASA TV. How are you 6 minutes behind? I'm trying to tell you that that's what's going on. You don't listen to me. I'm trying to tell you that my stream's super far behind. Whatever this one is, the official NTV stream is actually seems to be working well. No joke, I used Flex Seal in my dishwasher the other day and saved $400. Stuff does actually work. I Flex Sealed my roof. SKS, when I first moved into this building, the roof was leaking. I literally went up there on the roof and used the spray Flex Seal and fixed it. It does not leak anymore. Dude, it works. It works. Like, I just tuned in. Sorry. It's all right, Subtlely. All good, man. No need to apologize. Why does NASA use the spray on foam insulation, yet other companies have the clean look? Hydrogen. Hydrogen, dude. Oh, yeah. Hydrogen. So, subtly, let's think about states of matter here, right? So you have solid, liquid, gas, and plasma. Okay? 4 states, but 3. Plasma is a technicality because it doesn't occur naturally except around the sun. But just let's use solid, liquid, and gas for a second, okay? So each element, each element in the periodic table, right, has a certain point where it solidifies, a certain point where it melts, a certain point where it evaporates, right? So every element can be in certain states. So you could have solid hydrogen, for instance, and solid helium too. But that's the thing is let's take like mercury, for instance. Okay, mercury at 1 bar pressure is a metal that is in liquid form. It's not like aluminum. Aluminum is solid at 1 bar. It's solidified. Mercury is not, right? So on other planets, methane, a gas like on Titan, methane is actually liquid at surface at the surface. Titan has oceans of methane, liquid methane, because it's so freaking cold. Because that's when methane turns into a liquid, when it's really cold. Think about Starship, right? Now, going back to hydrogen and helium, all right? Where an element turns solid, where it turns to liquid, where it evaporates into gas, depending on the element, it's all in different points. There's a scenario where you could have liquid uranium. I don't know what you'd need to do that, and frankly, I don't want to know. I don't want to know. That's probably not going to end well, right? You could have liquid aluminum. Aluminum melts at like 200 degrees, something like that. It'll turn to a liquid. It'll just stay liquid. Really easy to make that into a liquid, right? That's called corium. Oh, yeah? Well, there you go. So, long story short, so hydrogen, going back to SLS, hydrogen, right, stays as a liquid on the very far left of the scale, like in terms of temperature. It turns to a liquid way over there. So it's almost at 0 Kelvin where it turns to a liquid. And here's why hydrogen is so dang hard to manage with a rocket. Hydrogen turns to a liquid at like 5 Kelvin. That's minus 493 Fahrenheit. Or what is it, minus 300 C or something? Really, really freaking cold. But if it goes 1 or 2 degrees in either direction, well, let's just say it's not going to go to the left. If you try to solidify hydrogen, you're probably going to get to absolute zero, and then weird stuff happens. Let's just say you heat it up 1 degree. You heat it up 1 degree, it turns to gas. The window for hydrogen to be solid is very, 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 very small. The window for it to be liquid is even smaller. Hydrogen mostly exists naturally in our universe as a gas. Hydrogen gas. The Hindenburg. 9. No, the Hindenburg didn't end well. Turns out when you when you fill your dirigible with rocket fuel, it doesn't work very well. So, thank you for not saying 0 degrees Kelvin. Yeah, you're welcome. So the foam is there to make sure that the hydrogen doesn't heat up. Now, the thing is that hydrogen, when it's in liquid form, it boils because you can only get it in liquid form at a certain pressure, right? Just like water. If you take water and you heat it up at 1 bar, right? At 100 degrees centigrade, it'll boil. Hydrogen, when it's in liquid form, just boils because the gap for it to be a stable liquid, as opposed to like a boiling liquid, is they're very condensed. They're very small. Condensed. Science joke. So it boils. And you really need to make sure that it stays at a certain temperature or else it's going to evaporate off or it's going to boil off. And that's why hydrogen always leaks. Because it's always going to boil no matter what. You can control the rate of evaporation by thermally conditioning things, which is why they've led the engines, right? But that orange foam is there to make sure that the hydrogen doesn't change temperature too much when it's in the rocket. It's foam insulation. Right, but why is the foam exposed on Artemis but not others? Or do others just not have the foam at all? Others don't need it. They don't need the foam. Liquid hydrogen is the big one. So Centaur has the foam on it on Atlas V. Oh yeah, it's white, but it's there. Oh yeah. Falcon 9 doesn't need it. It doesn't need it because they're using liquid oxygen in RP1. You don't need to cool RP1 to like 5 Kelvin. In fact, if you did, I'm not sure what would happen. It would probably turn to sludge. Yeah. RP1 is not a cryogenic propellant. Long story short, a lot of other rockets don't use full cryogenics. That's the reason. Now, if you think Starship, when I think about Starship doesn't have any foam. It just has tiles. Why? Why wouldn't it have foam? Anybody know? It's using methane. It uses liquid methane. And before you say, well, okay, well, EJ, methane's not hydrogen. Methane is like 4/5 hydrogen. CH4. The thing is that carbon atom is huge compared to the hydrogen. That's what keeps methane a little bit more stable. And RP1 is just chains of carbon and hydrogen. Literally hydrocarbons. It's right in the name. I'm telling you, engineers are not good at naming things, okay? They're not good at naming things. The names are always, you should just take them literally. There's no innuendo. There's no innuendo here. Hydrocarbons. They're just chains of carbon and hydrogen. Hydrocarbon. That's what RP1 is. RP1 is a hydrocarbon. It's actually diesel fuel's distant cousin, if you really want to know. It's very similar. So, they're really good because it's simple. Yeah, there you go. Liquid uranium. Yeah. Is that the elephant's foot? Yeah, I'm pretty sure. Is that like cesium or corium? Yeah, corium is what. Yeah, if you boiled uranium. Yeah, Chernobyl. Good times. Also, cesium. You get byproducts. Cesium. Yeah, they figured out that that's not good for you if you inhale that. Doesn't RP1 have kerosene in it? RP1 is kerosene, Cody. It is kerosene. It's a more refined version of kerosene, but it's kerosene. It's very similar to Jet A, so what like an airliner would use, or JP5 if you do military, you know what I'm talking about, or diesel fuel. Yeah. Believe it or not, in like if you guys, not many people do this nowadays, but if you go read about hydrocarbons, there's all different types of chains of hydrocarbons. Gasoline is very weird comparatively to all of its other hydrocarbon counterparts, like heavy oil. So that's bunker C. And then you have like diesel fuel, you have Jet A, you have RP1. Yeah, they're all, like all those other fuels are kind of over here, and then gasoline is like kind of over here. It's the redheaded stepchild of hydrocarbons. It's perfectly fine for you if your intent is a life speed run. Yeah, that's right. Uranium fever does get me down from time to time. Yeah, bunker C, G-tail fuel. Yep. The distillation, it's the distillation column. That's right, Skylance. Yep. So subtly, other rockets don't need to thermally condition their propellants as much as SLS does. If you look at Delta 4 has it. Delta 4 has the orange foam on it. Yeah, Delta 4 does. But yeah, anyway, going back to Starship, we were talking about methane and LOX. Why does Starship not have a thermal protection system? Why doesn't it have spray on foam insulation? Anybody know? I'll give you a hint. It's because of metal. Taradra, thank you for the raid. SLS 2023. Oh, yeah. Okay, yeah, that's the raid message. I found it funny. This is I'm finding this funny face. Yep, that's right, dudes. So, subtly, you want to learn a little bit more about material science, steel. Starship's made out of steel. That's why it doesn't have it, despite using something that's mostly hydrogen. It uses liquid methane, liquid oxygen. Because it's made out of steel, that steel can insulate better. Pretty cool, all right? How's the weather looking at the moment? I've heard nothing. Artemis should have used steel.
Discovery, go at throttle up.
I mean, here's the thing. If you're going to use hydrogen and steel, it doesn't really make sense.
Discovery,
that doesn't make a whole lot of sense. The reason why is because if you're using hydrogen, you want your vehicle to be super light, because that's where you get all the benefits of hydrogen. You need to make as little a rocket as possible. Most of your rocket needs to be hydrogen in order to get the benefits of hydrogen, like a Centaur stage, for instance. Thank you for all the subs, guys. Radioactive with a 92, Sky Seas with a 44. I do appreciate it. Taradra, thank you very much for the raid. Thanks, buddy. What were you up to? I think you were playing Kerbal today, if I'm remembering right. I want to thank you and the community for the past few years. I recently got a job offer from Siemens. Oh, look at you. Look at you. All right. Hell yeah. Put your damn hand up to your screen. Okay, we're going to air 5. Don't hit your screen, okay? I'm not responsible for you putting your fist through your monitor, okay? Sky Seas. 1, 2, 3. Yeah, all right. No, it wasn't my fault. I didn't break it. You broke it. Wasn't me. You broke it.
Discovery,
wasn't me.
go at throttle up.
But it put my fist through the monitor. Wasn't me. Left you hanging? Why would you do that? Why would you do that? Anyway, subtly, does that help? A little bit on material science there. It's cool stuff, man. I find it super interesting. Scrubs again. Wasn't me. Don't say that word, man. Don't say that word. Just sit and marvel. So why does NASA use hydrogen? The performance, dude. That, and this is a shuttle-derived launch vehicle. These things need hydrogen. If you put methane in that thing, it's not going to work correctly. It's like, that would be like putting gasoline in a diesel. Or putting diesel in a gasoline car. Yeah, like I said, gasoline's the stepchild, the redheaded stepchild of hydrocarbons. It really is. Ban that S word today. No, they were talking about the TLC song. J-Speed has it right. TLC, I don't want no scrubs. Okay. Chat, don't go chasing hydrogen waterfalls, okay? All out, only got diesel. Better go to the next station. Hey, why didn't you pump any gas? What'd you do? Could we take an RS-25E and run methane through it for science? It wouldn't be able to maintain stoic for methane, Hellfish. The turbo pumps wouldn't be able to move, they wouldn't move propellants in the right quantities. I'd actually like to see a world that has hydrogen waterfalls.
Discovery, go at
That
throttle
would
up.
be strange. Is hydrogen water just water or peroxide? Liquid hydrogen is is H2 in liquid form. Eddie Boo, 47 months to the moon. I suppose it would run very fuel rich, probably to the point of not being able to maintain combustion. You'd literally flood it. You would literally flood it. Yeah, you would flood the rocket motor. This doesn't mean that it just won't start, Hellfish. This kills the rocket engine. It's simple. We kill the rocket engine. EJ, off topic, but tomorrow I start my own Route 154. Sweet. Zeros and Sun Temple with 100 bits each. Thank you very much. Just look at Niagara Falls. It's 2/3 hydrogen. That's true. I mean, that... Yeah, I guess that makes sense. Can we try it anyways for the content? I want to see. Well, okay. If you want... So, Hellfish, that's the reason, interestingly enough, one of the rocket engines, there's been rocket engines where they've moved different types of propellants through the rocket engine. An LR-87, so a Titan II motor, and Titan III, and Titan AS, and Titan IV, and Titan 1. The LR-87. The LR-87 is one of the only rocket engines... Excuse me. That was from the pizza. It's one of the only rocket engines ever to be run on hydrolox, carolox, and hypergols. Why? Well, the reason is because it's got a transmission in it. I'm not kidding. There's a transmission in an LR-87. There's a gearbox. It's not a transmission like on a car where you shift gears. The LR-87 has two shafts for pumping. One of them is moving liquid fuel. The other one is moving oxidizer. And what they did is one of those pumps is driven via a gas generator, and the other one is driven via a gearbox. There's a gear on one, and it turns the gear on the other, and it gets it to spin at the correlative oxidizer rate. So it moves the right amount of oxidizer. The reason the LR-87 could run on all these different propellants is they literally swapped the gears out. They changed the gear ratio to get stoichiometric. True story. Yep. I've held those gears in my hand. Well, touched them. I didn't pick it up. But, yeah. Really cool, actually. Really cool stuff. I'm really glad that eBay cluster was literally plug and play for you today. Yeah, man. Oh, yeah, that's right. Maybe we should go check on that oil, huh? Yeah, we do need to go check that. So in theory, you could change the wheels in the turbo pumps and maybe have it work. Well, see, the RS-25 does not have a geared turbo pump. No, because of stage combustion, it's not geared. No. Not a geared system. That's the reason why the LR-87 could do it, because one was geared off of the other. You can't do that with RS-25s. No. That would be as silly as trying to drive a supercharger, like a belt-driven supercharger, off of exhaust gases from a turbocharger. I know it's possible. I know you could do it, and somebody's probably done it in some instance, and I'm sure they're very talented. But that doesn't make a whole lot of sense. Because if you take a supercharger and you just drive it off exhaust gases, it's just a damn turbocharger. That's what a turbo is, right? Like that would be like trying to take a supercharger and making it gas actuated instead of belt driven. It doesn't work that way. Can you cover the SpaceX news? Sure. EJ, you cooking? What is it cooking? Oil? Said anything about oil, chat? You cooking? Full name is turbo supercharger. No, Smart. I'm not, I know about turbo supercharging. What I'm telling you is like if you took a Roots, right? And you took the pulley off the front and you put a turbine from it attached to the pulley and then tried to make the supercharger work that way. That makes no sense, right? That's not a supercharger anymore. It's just, why would you do that? Trying to make the shuttle engines run off anything but hydrogen would be like doing that. Why would you do that? Why don't you just use the turbo or something? Is that Apollo 8 on the far right screen? I'm not sure which Apollo mission that is, Jim. To be honest with you. Lox is back in fast fill. They did go into slow fill, didn't they, Bandit? Yep. It's a turbo superbo charger. Yep. You remember Apollo 8? Well, yeah. You just be making a turbo supercharger just to get a one. 100% doesn't make sense. You could do it. Anything is possible if you can figure out a way to do it. Will it be worth it? I don't know. Frick around and find out. Last, what's up? I know, hence changing the turbine and impeller wheels. Oh, and just like trying to make a supercharger gas actuated, you might as well just design something new. I'm not saying it's not possible. Maybe, I'm sure. But redesigning a turbo pump to rocket engines is what redesigning a connecting rod is to a car engine. That's going to be difficult. That's going to be difficult. That's a lot of work. Leaving for KSC soon? All right, Ron. How much more efficient is hydrogen now that it feels like methane? Hydrogen is the most efficient fully cryogenic propellant that we have, Cody. So I'll talk to you in car terms again, because that's something that, everybody here it's a little bit easier to understand. The hydrogen rockets are the most efficient. Why? Well, okay. Actually, I won't talk in car terms just yet. We'll get to that. So, say you have hydrocarbons, right? So you have RP1. How RP1 works is that it's a very energetic explosion. It makes a nice loud boom. That's why we use it in cars to move around. It makes a really nice loud boom. It's stable at room temperature, really easy to use, lets out a lot of energy. A lot of energy gets let out real quick, but it's not efficient. It's not efficient. Now, what do I mean efficient? What, does a rocket engine get good miles to the gallon or something? Well, yes. Yeah, literally. Yeah. In rocket science, there's something called impulse, okay? Now, impulse is the amount of energy that you can get out of a certain amount of propellants, okay? So, Carolox engines have very low impulse. They make a big energetic explosion, but it ain't very efficient. Hydrogen, on the other hand, because, think about that Carolox engine before we go to hydrogen. You burn off most of it, and you burn off so much that it's actually shooting soot out the bottom. There is unburnt fuel that gets blown out the bottom. That's the same case with a car. That's why we have catalytic converters in cars, so they can catalyze with the exhaust to... I did end up talking about cars. Nice. But yeah, there's a lot of unburnt fuel coming out of the bottom of the engine. It's not very efficient, but it makes a nice big explosion. Now, we go to hydrogen. Hydrogen has no carbon. There's no carbon in there, right? You can't have carbon emissions if there's no carbon in your combustion. When you take hydrogen and you atomize it with liquid oxygen, and then you blow it up, the only emission is water. That's the byproduct. Water. Yep, water. Because that hydrogen and that oxygen so much, they efficiently combine so well, right? Spoiler alert, there's this thing that we drink that has hydrogen and oxygen in it, right? They combine so well that you get near zero unburnt fuel coming out of the bottom of the engine. Nothing. the only thing you get is a combustion or deflagration byproduct. So basically, the byproduct is what comes out after you explode those things together. They chemically deflagrate. Deflagration is what it's called, as opposed to detonation. There's deflagration and there's detonation. Combustion, detonation. They're two different things. We can get more into that later if you want. The only thing that comes out is burned hydrogen and burned oxygen, and they chemically combine. They combine back together when they come out of the exhaust as water. Precipitation. Yep. That's how efficient it is. They're way more efficient. Probably, I would say probably like 33% more efficient. Repeating, of course. No, I don't know if it's 33. It really depends on the rocket engine. It depends on the fuel delivery system. It depends on your combustion cycle. There's a lot of things. It turns out the rocket science is complicated. But, like, I'll take those shuttle engines, for instance. NASA's using the hydrogen in this rocket for a very good reason. The shuttle engines here they're not just using them because, oh, we're going to use leftover shuttle engines. No, they're using them because shuttle engines are really, really, really good rocket engines. To the point where it's kind of a shame to throw them away like this, but I'll trade it for boots on the ground on the moon. As a space shuttle diehard fan, it really kills me to see these things get Viking funeraled, but that's the way it is. Now, the shuttle engines, if I'm going to speak in car terms, would be like a motor that makes 1,000 horsepower and gets 1,000 miles to the gallon. Yeah. Actually, maybe not 1,000. Let's say 100 miles to the gallon. A motor that makes 1,000 horsepower, 100 miles to the gallon. It's like that. Something like that doesn't exist, but it does in rocket science. Well, I mean, you could make a hydrogen motor do that if you want, because if you make a motor like an internal combustion engine run off hydrogen, you could theoretically do the same thing. Problem is, and this is the reason why we don't have hydrogen cars, is that hydrogen is a pain in the butt, and it likes to explode when you don't know what you're doing. There's a lot of people, anybody go driving lately? There's a lot of people out there that don't know what they're doing. Am I right? No. Hydrogen is so ridiculously efficient, and those shuttle engines basically, I'll give you the numbers for them. They make 2,400 kilonewtons of thrust, which is, I think that's 700,000 pounds of thrust. I think I could be pulling that one out of my tail. I didn't do the math. Sorry. They make 2,400 kilonewtons of thrust at 450 seconds specific impulse. That's ridiculous. That is insane for a rocket engine. The only thing that's even comparable to that nowadays is Raptor. Raptor is the only thing that you could even put in the same class, and maybe the BE-4 as well. I suppose you could put the BE-4 up there as well, too. So we hit 8 billion people on Earth today. Oh, that's cool. Sweet. Wheel to Wheel did build a hydrogen-powered LS2, made more horsepower than a comparable spec gasoline engine. Oh, yeah, of course. More horsepower? Are you sure? Ah, yeah, the people in insert neighboring state drive like maniacs. Sparrow, thank you for the 46. Is it at least one of the turbo pumps in the RS-25 axial flow and not centrifugal? So just changing the wheels isn't possible. I'm trying to trace the RS-25 schematic back in my head. I think it's a combination, and you say at least one of them. Yeah, I think at least one of them is axial, which actually, Smuck, we were looking at Raptor's plumbing the other day. Oh boy. They have the methane pump on a Raptor, the methane turbo pack, or the power pack, the turbo pump, is this is so ridiculous. Like it's nuts. They have a radial compressor. Or radial impeller, not compressor. They have a radial impeller that pulls the methane in, and then the methane goes down around, and then they have an axial flow turbine. They have an axial flow gas generator that goes up towards the radial impeller, and then it takes a right and goes into the rocket engine. There's an axial flow, but it's flowing the wrong way. It's weird. It's weird. Dude, it is like, that's strange. That is a very strange design, but that's what you need to do full flow. They have a jet engine that provides fuel to the rocket. That's, you literally just described a gas generator, an open cycle gas generator. You have a jet engine, because a jet engine is the only thing that can spin fast enough to pump the fuel to a rocket motor. That's literally what most, like, common rocket motors, like if we're talking an open cycle gas generator like the Merlin 1D, it's literally a jet engine strapped to the rocket engine. But instead of the jet engine creating thrust, it having a compressor and a fan at the front, it has impellers. It has fuel pumps instead, and that pumps the fuel into the rocket engine. That's what most rocket engines are. So is the RS-25E going to make more power than the leftover shuttle one since they don't have to be reused? Correct. Yep. They will. They introduced a lot of modern manufacturing techniques into the, or they're introducing a lot of modern manufacturing techniques into the RS-25E program. They are using manufacturing methods that were found during the RS-68 program, because the RS-68 is on its way out, and they're using all those modern manufacturing methods to make new shuttle engines. So, like a lot of people say, oh, if we were going to make shuttle engines today, what would they look like? They'd look like RS-25Es. Oh, yeah. RS-25E, more like regenerative RS-68. Actually, it would have, Stackless, it would have been really nice to see a shuttle with some Block 3 SSMEs or RS-25Es.
Go at throttle up.
That'd be really cool. Am I late to this party? No, you're about 6 hours early. Yeah, I know what you meant, Pixie. Yep. Noobzor, 42-month resub. Wouldn't hate that. Can you imagine? Shuttle? Oh, shuttle with some RS-25Es in the back? That would be really nice. Should bolt in. Just saying. I mean, the turbine on the V2's engine only turned 3,600 RPM. Yeah, it's not very much. So Smuck, actually, you'll appreciate this. Raptor is using hydrostatic bearings. Yeah, that axial flow, the radial impeller is actually suspending the entire turbine assembly, not in oil. They're suspending it in the propellant. Real space age stuff, literally space age stuff. That is absurd. It is like, who even thinks of that? Who even thinks of that? Hydrostatic bearings, hydrostatic turbo pump impellers. Like what? All right, cool, sweet. Yeah, I figured out how to fix the oil leak in my truck today. You know, actually not, I didn't. We haven't figured that out yet. There you go, Toothless. Happy birthday, buddy. How about a shuttle built around the J2X? Nah. The shuttle engine's better than a J2X. Didn't the RS-25E use hydrogen as a bearing fluid in places? Yeah, sure. They have regular bearings, but they flow hydrogen through the bearing to keep it cool, believe it or not. That's how a shuttle engine works. They flow hydrogen over the bearing for cooling purposes. That's different than suspending your entire turbine machinery in the propellant, which is absurd. That's ridiculous. I don't know how it doesn't create hydrodynamic drag. It's really insane. Muskie thinks of it. Yeah, you're right, Limey. Yeah, you ain't wrong. I mean, the fuel pump in your Mustang is cool to some extent and lubricated by the gasoline that it pumps. Yeah, that's true. Yeah, you know, you're not wrong. That's what I mean, dude. All this stuff, like, you know, people harp on me all the time for, like, explaining it in car terms, but, dude, a lot more people have cars than rockets, all right? And a lot of the technology does transfer over. It's very similar. Only the rocket stuff is just a little bit more precision. A little bit more precise. So I just watched a video about Raptor. He mentioned that there's no seal needed between the oxygen turbine and turbo pump because it doesn't matter if oxygen-rich exhaust mixes with more oxygen. But he didn't mention anything about the methane side. What are they doing there? Does it need a helium seal like the RS-25? City, I'm not 100% sure. What pocket knife do you use on a daily basis? I'm an EDC guy. Don't have a pocket knife. But if I did, I don't know if a Leatherman counts subtly. Oh, there you go, Forge. Right on. Ironic that the expendable version of RS-25 is the E version. Yeah, just a weird coincidence. 1:04 a.m. Eastern Time, Dak. I no longer have a car. That's a shame. Do you know how long the NASA Live coverage will go this morning? Will they broadcast through TLI? They better broadcast through TLI, Sadie. That's all I'm saying. They better. I want permanent coverage of this frickin' thing. We're going to be sitting here for a while after launch because I'm going to enjoy the view. I don't know about you. I'm enjoying the view. And then I'll go eat some hay and make things out of clay and lay by the bay. I just may. What do you say? Would iron engines be good on the shuttle for ion engines? Not enough thrust, Noswolf. Solar electric propulsion doesn't make it. Dude, you could do that and you could make more thrust. Kershaw is better than all other pocket knives. Noted. If the RS-25Es are made to be expendable, how would that be good for the shuttle where they would need to be reused? They're not really made to be expendable, Cody. When they say they're made to be expended, what they really mean is that it's designed to work with SLS and not a space shuttle. Sold the 2001 Forester to my grandma-in-law for $50. Okay. Can you cover the SpaceX NASA news? Yeah, when I feel like it. Yep. Poet and don't even know it. They hate us because they ain't us. There's a hearing on the James Webb Space Telescope results at 10:30 tomorrow. That's neat. It's vaping. I mean, Flatgate, if we want to be technical here, that's evaporated fuel. But we could call it vaping. That's fine. It's close enough. Tomorrow I drive to Florida. Route 154 for the win. Why are you driving to Florida, Oforce? Now, Route 154 was a one-way trip. What do you cut stuff with when you're working on the truck? Box cutting knife. I don't really cut stuff subtly. I don't cut things. I take them apart. You guys want to know the key to working on a car? Be patient. Be patient. I rarely ever need to cut things. You're moving to Florida, Force? Whereabouts? Smuck, don't copy me. This is my conversation. Don't copy me. Force, whereabouts? I said it first. No, you didn't. You jelly? No, not really. The Victory family is having a Navy-mandated Route 154 in February. Word. What's in the mug? Coffee. You're moving to Tampa? Why? That came out bad. What's in Tampa that you're moving for? Oops. Why? Gavin, I invited you to my wedding. Why? No, you're right. I think having lived in Winter Park, I could say that and have it not be derogatory. I think I have enough cred here. Be closer to family. Right on, man. You're in for a little bit of a change of pace. Florida is not Washington State, dude. Those are not the same place. 1 hour and 20 ahead of schedule. As a Tampaite, I resemble that remark. Right. Yeah, of course, you know what? Florida's sweet. I love Florida. It's so fun. There's so much. There's stuff to do. Like, if you live in the sticks, you know what I'm talking about. There's stuff to do in Florida. You could go boating. You could go water skiing. You could go to the theme parks. There's just You could go mudding, you can go off-roading, you could go racing. There's racetracks everywhere. You could watch space launches. Those are pretty cool. There's stuff to do. That's why I like Florida. Except for Tampa, there's nothing. Go Wings. Okay. Because we're moving to Rhode Island and we own a functioning automobile. Navy said we need to do Route 154 in it. Rhode Island. I'm close to Rhode Island. Like anywhere in Massachusetts is close to Rhode Island, but I'm closer than I was. Come on, there's a lot to do in our area. There is a lot of stuff to do in Massachusetts. Yeah. Yeah, that's why I like it. Yeah. Eat an alligator, wrestle a crocodile, eat some sandwiches. Wait. Artemis 1 is launching tonight? So, this might seem like a really dumb question. I'm getting a lot of those tonight, Celtic. I'm just kidding. You guys' questions have actually been really good. However, are people just sitting around watching telemetry from sensors? Is there like active work happening right now in and around a rocket? No one's near it. Don't go near a rocket when it's being fueled. No one's near the thing. They have, range safety protocols are in effect. Don't go near it when it's being fueled. They are watching, they're still tanking the rocket. They're watching the sensors and they are moving very slowly but methodically through the countdown checklist. You could even weather a hurricane. Now that's neat. Should do a meetup at Battleship Cove. It's close for you and I. Yeah, Hammer Nails, that actually, Battleship Cove is, to be honest with you, I'm kind of the same distance away from Battleship Cove, but in a different direction. Hello for the 10th time. Mockingbird, how are you? Well, for the 10th time, I gotta say hi the 9 other times. How are you? 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 There you go, buddy. That was weird. Don't make me do that again, please. How am I doing, Jeff? I'm doing good. I did it again without even thinking about it. I was stuttering. I'm good, Jeff. How are you?
My name is Jeff.
Are you staying up for the launch? Yes. Seriously, we should plan for that when it's warm again. It'll be a fun time. Yeah, sure. What's your opinion on Max ignoring directions for Perez this past weekend? Think Perez is going to leave? Howard Hughes. Obsessive compulsive disorder. What? What was the question? Sorry. Jeff, quite good. I got a job as a manufacturing engineer a few weeks ago. My guy. That's awesome, man. Yeah, Naroku. Oh, man. Dude, okay, so here's the thing. Max ain't the kind of guy to give a position back, dude. He ain't the kind of guy to do that. But also, pissing in your teammates' cornflakes is also not a cool thing to do. That's really messed up. Yeah, but also, Max ain't the kind of guy to give a position back. You know what I'm saying? I think that's fair. It's multi-21 all over again. Yeah, MS Voyager, very interesting. It's for a balloon. I don't like seeing Checo get the shaft like that, but yeah. Game Coder, did I miss a question? I'm trying my best to keep up with chat. What is Artemis 1? It's a mission to the moon, baby. Max already won the championship for this year. Remember what Checo did in Abu Dhabi in 2021. Yeah, that's true. Pissing in your teammates' cornflakes like that has consequences. If Max is prepared to deal with those consequences, then sure. Max has let his ego get the best of him now. Red Bull is going to be very toxic. That's what I mean, dude. How much do you want to win? And dude, don't get me wrong. You have to have the fight in you. You have to want to win. Look at Lewis. That guy could retire dude, he won 7 times. He won 7 times. He could retire. He ain't gonna retire. No. He wants another one. He hangry. Lewis is hangry, and I don't even like Hamilton. I know he's hangry. Max is very hangry, but you got to be careful. You got to be careful. Max is a jerk. Period. You have to be. You have to be an F1 champion in this day and age, guys. That's the thing. You have to be. Everybody said the same thing about Seb when he did the multi-21 thing versus Mark Webber. Nobody liked him, but everyone likes Seb now. You have to be a jerk. That's how you win. He wants his 8th after he was robbed for it. I don't blame him, Kiggy. I think watch out for Mercedes next year, because that car is, they got those side pods. Got those side pods dialed in. I told you, when they get those side pods dialed in, man, their car's gonna be faster than everybody else. Have you heard about Jay Leno? I did hear what happened, Red, but I haven't really looked into it. I hope he's okay. Jay Leno's like one of my heroes, dude. Yeah, that's Horner though, man. Like, Alonso wasn't a jerk. You sure? Yeah, he got burned, Limey, yeah. Alonso was not a good person in the Renault days. He was very mean. But hey, Max is young, dude. He's still young, dude. He'll learn. He'll learn. Lewis was like this back in the day. This is the reason why I hated Lewis in 2007, 2008 when he started driving. I hated him. Such an arrogant prick. But dude, you learn to win with class over time if you have the drive to keep doing it. And guys, I'm saying this. I don't like Verstappen. I don't like Hamilton. I don't like either of them. I like Kimi and Alonso. So, I mean, 2 cool facts from the NASA semi-commentary stream. One of the engines flew John Glenn to space. The other one serviced Hubble. I know. Yeah. I mean, Senna was a jerk. He was a huge jerk. Oh, yeah. But that's what he had to do. He had to be like that because that's the way you win. Because they weren't going to let him win. They weren't going to let him win. I love Lamp. I don't know what that means, Hellfish. But yeah, fellas, I think, like, dude, you got to have fight in you. You got to have fight in you. Now, Seb did it to get ahead in the championship with a multi-21 thing. I don't know what the frick Max was doing. I think Max is getting... That's why? You already won. You already won the championship. Why? You just stat padding at this point? I mean, all right, I guess. Maybe he saw a path to victory or something. I don't know. Did you see the spacewalk today? I was watching it before I started streaming, Ma. I didn't see it. Did it end well? Ferrari is... Yeah, Hellfish, exactly. Yeah, that's true. See last for a post-race picture. Huh. Interesting. Max settled a score he had to settle with Checo. He has done that now, and it's out of the way. I'm not sure what that means, Revs, and I'm not saying you're wrong. I'm saying I don't know what that means, but all right. I think he will do something for Checo. Yeah. Interesting. Apparently, Checo crashed on purpose in Monaco, ruining Max's lap. According to the rumors, Checo later admitted to it, and Max didn't forget. Yeah, Max doesn't seem like the kind of guy that would just be cool with something like that. But yeah, interesting. There's a rumor that Perez crashed on purpose in Monaco. Interesting. Man, Red Bull's all kinds of fricked up. Have you watched any of the Bruins this year? I've been keeping up with them, Thorne. I haven't really had time to watch. But also, please don't blow your load. Could you just be like this for the rest of the season, please? The Bruins are straight fire right now, dude. They're like 15-1. 15-1-0 or something, 15-2 or something. They were really freaking good, man. I'm like, we're gonna hit a wall. We're gonna hit a wall, and we're gonna finish it last. Dude, Monday Night Football yesterday was sick. That was an insane game. Dude, I'm a Patriots fan, not an Eagles fan. In 2017, with the Eagles won, I truly believe they were a better team than the Patriots that year. And I tip my cap. Frick you, Eagles fans, but I tip my cap. I think you guys got robbed. That roughing the passer call was nonsense. Like, I'm like, what? What just happened? What? No, that's not roughing the passer. What are you talking about? Oh my god, dude, it was hard to watch. I was mad as a Patriots fan that does not like the Eagles. I was just sitting there going, all right. I hate that too. You guys got robbed. You guys should be 9-0 right now. It's ridiculous. Your mic didn't like that. Yeah, you're probably right. Late hit is a late hit. It didn't look like a late hit to me, but.
And you're looking live at launch control here at the Kennedy Space Center.
It was a good game up until that point.
The top row is for the launch directors. And that row below is our NASA test directors. Currently
Forge.
Flying the ship, so to speak.
What?
Overlooking the countdown and making sure that everything goes smoothly.
Why is Ted Lasso in mission control?
And
He's
so
there
far,
for emotional
everything has
support.
gone smoothly. Got a thumbs up just a couple minutes ago from one of the NASA test directors.
They need to
Currently,
modernize
they're
the
working
aesthetics of
to
launch control.
configure the upper stage
I
of the
agree.
rocket, the ICPS, the Interim Cryogenic Propulsion Stage. That's built by United Launch Alliance. It's a modified upper stage from the Delta IV.
Yeah, Spraz, I get it. Yeah. Jay, everything is looking good. Weather's looking okay. I think it's going to fly, Hammernels, but I always think it's going to fly, so take that with a grain of salt. Crap, upper stage.
Tanking-wise, we are currently sitting at 100% full for the
Yeah.
core stage liquid oxygen
But-
and 99% filled on the liquid oxygen side. T-minus 4 hours, 58 minutes. L-minus 5 hours, 28 minutes until liftoff. This is Artemis Launch Control.
Okay. Shutzy, so that gas leaving the rocket will ignite with a spark? No. That won't ignite. It'll make other things ignite very, very nicely, though. That's GOX, gaseous oxygen. Yeah, if that combines with something, if it atomizes with something, it'll make it blow up really, really nicely. Yeah. LOX makes things catch on fire really easily, like rocket engines. No, it's just basically they're venting the tanks. They have to top the tanks, guys, because the propellants are boiling. We talked about that a little bit earlier. The propellants inside of here are boiling like a pot of water. And what happens if you have the cover on a pot of water that's on the stove and it's boiling? The cover does that little... I hate that noise. It's like, oh, something's wrong. No, you know the noise that I'm talking about, right? It'll create gas and it'll try to pressurize, and if it doesn't pressurize, it'll just lift the lid off, right? So same thing's going on with the propellants here. They're boiling because they're extremely cold at high pressure. So you have to vent and you have to continuously top the tanks. Daryl just announced, the NASA PAO just announced that they are going into topping. They're in LH2 top right now, and then they go into LO2 topping as well. Now, when they top the liquid, you got to have a place for the gas to vent. So they top the liquid through these things, these little tab things down here. They're called tail service mast umbilicals. There's 2 of them kind of in line like this. The one that's closer to us here is the hydrogen, and the other one is the oxygen. No, it's liquid oxygen. And that goes through these little pipes on the sides of the vehicle, and then those pipes go into the bottom of the liquid oxygen tank. So liquid is filled from the bottom, the propellant's boiling, and you have to give it a vent because the rocket has to stay at the same pressure. Both tanks have to stay at the same pressure throughout the entire launch campaign. Actually, they will change pressure when they press for flight, when they close the cap here. They close that off because they need tank ullage, but that's a whole nother story. But yeah, long story short, it's gaseous oxygen that's coming out from the topping cycle on the liquid oxygen tank. Loxygen. Yep. Does gaseous oxygen rust things faster than air? Yes. Yeah. Yes, engineering. Absolutely. Liquid oxygen oxidizes things. That's what rust is. Rust is just oxidization. Only it's oxidization of certain metals. Certain metals corrode, certain metals rust. So if you took iron and you sprayed LOX onto it, you'd create iron oxide, which is rust. Yep. Oh yeah. It makes things rust real good. You would create less rust on something by pouring salt on it. Like if you had a plate of metal, like if you had a plate of steel here and a plate of steel here, you poured salt on this one, you poured liquid oxygen on this one, that thing would just insta rust. Oxygen is very good at oxidizing things. So yeah, oh yeah, it'll make stuff rust. Oh yeah, absolutely. Any leak issues? Nope. Tanking finished ahead of schedule, Geek. Everything is good. Tracking no errors right now. SRBs make for a good boom, like that Delta II failure at Cape Canaveral. Yeah, Joe, I'll be honest with you. That Delta II, the one where they were like, we've had an anomaly. They cracked the casing on one of the SRBs because it turns out if you drop it, it's not good for it. Yeah, that's why that happened. Somebody dropped the SRB. And then it's like, yeah, it's fine. It's fine. It's fine. Yeah, and then they just put it on the rocket, and it's like, yeah, it'll be all right. Yeah. Fun fact, the oxygizer, nice. The oxygen tanks on the Apollo Command Service Module, or the Apollo Service Module during Apollo 13. You remember that whole stirring the tanks thing? Tanks don't stir very well when the thing shorts out inside of the tank because somebody dropped it. Oh yeah. Somebody dropped that tank that exploded and then just said, it's fine. It's fine. Just put it in. It'll be all right. So, long story short, if at any point when you're going to build your rocket, you drop something, don't use it. Just put it over there and just get another one. Yeah. You want to make your SRB work correctly? Don't drop it. Yeah, it's probably a good idea. And then they dropped SN9, and that didn't turn out well. Yeah, don't drop. Yeah, no, that's right. 5-second rule. No, the 5-second rule need not apply. No 5-second rule. They tried that rule. It didn't work. They almost killed Jim Lovell. and Fred Hayes and Jack Swigert. Bad idea. Don't do that. Do not hump. I'm serious. I'm showing the picture, dudes. You guys brought this up. See? That thing is holding a rocket. There's a segment of the SRB in there for SLS. Don't hump it. It's bad for it. Look, it says it on the side. I'm telling you. Do not hump. I know that, okay, so for the trained people, I know that humping is a railroad term. I know it's not that, but also it's still funny because people don't know what that means. But also, yeah, I get it. I know. I gotta make that a shirt. Oh, jeez. EJ, please give us this emote. I'm not doing that. We're not adding that. No, we're not adding that. No. No, I'm not doing that. No. No. Do not add. Do not add. How far into it has SLS gotten the last few times it was tanked for a launch? Last time we got within an hour of launch, and then they said no. Nope. I don't need that, Hellfish. Let's not do that. Okay, you do that. We're not doing that. Yeah, Hammernail, she's a freaking beast of a rocket. Yo, just dropping in. How's SLS going? Fueling is finished ahead of schedule, drummer. They're in topping on both liquid oxygen and liquid hydrogen right now. On Tim's stream, someone asked if he liked Countdown by Rush, and he didn't know what it was. No. To be honest, NASA should launch Artemis 1 from Ohio. Maybe it would work, you know. Everything happens there. It's all Ohio? Tim really didn't like... He really doesn't know Countdown? Isn't he a musician? Tim, you're a musician! Tim! No! What do you mean? What do you mean you don't know Rush? Tim! Why? Why? No! No! Exit the warrior, today's Tom Sawyer? No! I will not stand for this Ohio propaganda. I've married into a family of Michiganders. Or I'm marrying into a family of Michiganders, Brand. Yeah, I have to hate Ohio now. I'm sorry, guys. It was a requirement. I don't hate you. Like, I'm from Massachusetts. It's just Ohio. You're there, but it's Michigan. Like, I don't know what to tell you. Frick Michigan. No, frick you. I'm staying up all night for this one. It better bloody launch. If it doesn't, I'm blaming you. Yes. Blame the guy that's 1,100 miles away. Sure. Are you from Boston? Yeah, Shutzy. Mm-hmm. Michigan State University or U of M?
Discovery, go at throttle
U
up.
of M. Sorry, man. Sorry, State guys. Yeah, go blue. It's adopted though, so it doesn't really mean much. My college football team is UCF. You know what you did. No, I didn't. I don't know what you're talking about. Cool, you'd love to visit Boston? It's a cool city, Shutzy. It's pretty sweet, man. It's a good time. It's your fault. They left it out in a storm. I would have said leave it too, so. Instant hurt for you Trains fans. Joe, is this the steam engine crashing? Because I don't want to watch that. If it's the steam engine crashing. How could you? I don't want to see that. My second favorite... Your second favorite American is from Boston. El Presidente. We choose to go to the moon in this decade and do the other things. Not because it is easy, but because it is hard. Shutzy, we kind of talk like you. You ever notice that? He admitted it. No. I plead the fifth. Fifth! That excavator came out of nowhere. Yeah, I know. You used to. Yeah. Landing on the moon isn't the only thing that's had. 1, 2, 3, 4, 5. There! Ah! So many numbers in the Constitution, I can only choose 1/5. Still funny, man. Still funny. Still funny. Just saying. Still funny. Yep. Oh my god. Good to see the caffeine levels at the proper amount. Yeah. My favorite number in the Constitution is 2. Yeah. A lot of people know 1. A lot of people know 2. A lot of people know 5. Anybody know 3 and 4? Everybody forgets those ones. Those are kind of important. Fourth one's kind of important. That's kind of need that. What about this insulation got lost in the 100-mile-an-hour winds, but was expected to stay on when going much faster at launching to space? There we go. Niroku, everything is looking good right now. Yep. Do they have a second iteration of this rocket, or will they use Starship for future Artemis missions? They have bigger variants, Adina sign. Yeah. Let's see. So, are we go for flight? What about the... Okay, so the insulation. Here's the thing, Liquidator. The insulation is designed to have winds up to like Mach 25 going this way. This way. When the wind comes at you this way, it's a little bit different. We're talking about shearing force versus compression force. Yeah. If the rocket was pointed into the wind from the way the hurricane was going, it wouldn't be a problem. Really wouldn't be a problem. But the rocket's really not designed to have wind hit it perpendicular. It's kind of designed to have a lot of wind go at it this way. That's important to understand. So what happened was some room temperature vulcanization cream, some RTV that they were using for thermal protection did come off a little bit. But they literally put some guy out there on a slide wire and he fixed it. It's pretty cool. In America, do you have to support your college's team, or you can just support who you like? Elris, you kind of support what you like. The reason why I support University of Central Florida is because the college that I went to, Full Sail, it's down the street from UCF, and Full Sail doesn't have a sporting team. They don't do sports there. It's a school for nerds. They don't do sports. They still don't do sports. So UCF is down the road. So they're my adopted college team. Also, because UCF does a lot of programs that have to do with the Space Coast, they definitely have uniforms that look like this. Yeah, that's pretty neat. Yeah, I like this. I like that. That's this whole thing going on right here. That's pretty cool. Look at the numbers. Constellations on the numbers. Yeah, that's pretty cool. Yeah. So that's like a double reason to support UCF. Also, where's the other one? Also, this UCF uniform right here, the numbers are literally shuttle tiles. Yeah, the numbers on the jerseys is shuttle tiles. Look, and the guy's definitely standing in front of a Redstone rocket. This is why I like UCF. Yeah, they're space uniforms, man. Space uniforms. That's cool. That's really cool. I dig it. Yeah, see here. Look. See? Uniform shuttle tiles, bro. Can you check your last? Sure, Naroku. What's up? Yeah, see? I dig it. Throw back to the UCF shuttle uniforms. Bingo. Michigan is looking good this year. Yeah, they're doing all right. Esports? Yeah, maybe. You see Lego's Black Friday set? Eiffel Tower, that is 10,000 pieces. That is 59 inches tall and a 2x2 base. No, I haven't, but that's cool. They have a foosball team. Nice. ICPS LOX load and LH2 load is underway. Okay. Yeah, that's why I like UCF. UCF's my college team. They got robbed a couple of years ago and it pissed me off. Stupid Big Ten. All space pictures are fake. CGI. CGI isn't fake. It's CGI, Dread. What is it? What does it not exist? Of course it exists. It's CGI. CGI exists. you're being very CGI-ist right now. Okay? You're being very CGI-ist. I don't appreciate it, man. I don't appreciate it. Hair, I think so. Maybe. You're being very negative. Being very negative. This chat is CGI. I might be CGI. What are you, a racist or something? It's messed up, man. Toy Story is a fake movie? Yeah, I know, right? Don't hate on Woody and Buzz like that. Lightning McQueen's a real person. Okay? Wow. Wow. From our perspective, EJ, you are because you're a digital webcam. No, I'm real. I exist. You shut up. Shut up. You just don't get it, do you? You didn't see it. All right. What is the last rocket for the moon? Was it still the Saturn V? Yep. That was the last one. See. Prove it with science. Yeah. Spoken like a real synth. Hey, synths aren't CGI either. You guys suck. Yeah, anyway. Why launch so late? Jax, there's a lot of things. There's a lot of things that have to do, with like making sure you launch at the right time. There's a lot of technical reasons. Weather has to be good, etc., etc. The biggest one is that the moon needs to be in the right place. Yeah. Yeah, you can miss. Anybody that's ever played Kerbal and done their first moonshot knows what I'm talking about. Yeah, the moon's got to be in the right place. That's really important. Yeah. Yeah, you need the moon to be in the right spot. If it's not in the right spot, you're not gonna have a good day. I mean, unless you like solar orbits. And when we're this distance away from the sun, if you miss the moon, what it's going to do is it's going to accelerate you away from Earth's gravity. And if it accelerates you away from Earth's gravity, it's going to put you in an orbit that's very similar to Earth. So that means, at the very least, if you pray that the orbit is resonant, you're not getting the capsule back for 365 days. Because at this altitude, above the sun, with what's called the semi-major axis, our orbital period is 365 days because 1 year. Yeah, and then you better hope that it's resonant, meaning that, it might come back. Yeah, you don't want that. We don't want that. That would be bad. Yeah. Moon's got to be in the right place, dude. That's important. Yeah, they also have to. Yeah, that's the other thing, Aqualex. That's another good point. That's one of the technical reasons. Orion uses solar panels, and if you launch it and it goes to shoot for the moon and the Earth is eclipsing the sun, it can run out of power. We don't want that. That would be bad. I don't get it, Flykin, but all right. Will you be live or will you be taking a break beforehand? Well, Stroker, we still have to figure out what's going on with that thing. We got to figure out the oil leak. I did get the gauge cluster in, the new one, and we put it in at the beginning of the stream. Oh, man, does it look fly. It looks real good, man. I guess that's an okay reason. Thanks for explaining. Yeah, I mean, dude, I could get into technical details. I could get into weather conditions, wind conditions, upper level wind conditions, surface electric field rule, blah, 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 recovery condition. The moon has to be in the right place. That's really what it comes down to. Yeah. It is what you say, Bing chilling? The oil leak is not very Bing chilling, no. Turn down the emotion emulator. I will do what I want. So what are you going to do for the next 5 hours? We can mess with the oil leak, Cody. I want to kind of go and the truck is leaking oil. I found that it's leaking and it's not good. It's not good. Who told me to see last? Gee, Funky Flex. What are you up to? How long does it take for the fueling process to finish on SLS? It's already done. Takes about 2 hours. It's already finished. They're already topped. Bro, all right, Dread, what do you got? Bro, I watch your stream on occasion and I like you. And all this will unfold. Do me a favor and prove the earth is round. Mind you, I graduated from an aeronautics school. You have your A and P cert. All right, just because you can work on planes doesn't make you an expert on physics. I mean, Dread, here's the thing, brother. Here's the thing. Look, I usually screw with people that say that, but if you're not trolling, and I mean, I don't know, you still could be trolling, but maybe I'm taking the bait, whatever. I can't prove to you that the Earth is freaking round. I mean, I could say gravity and then explain the physics behind gravity and relativity, but would you believe me? Be honest, would you believe me? You wouldn't believe me. Come on, dude. Don't make me waste my breath. Let's not waste our breath. Just enjoy the stream, dude. Seriously, like I could sit here and explain it if you really wanted me to, how gravity wells work and how non-uniform spheres work, precession, and all the other stuff that pretty much proves that we live on... Actually, I mean, Earth isn't perfectly round, believe it or not. It's kind of like a big jello mold that kind of jiggles around as it's spinning, if you really want to know. It's not perfectly round. There's nothing that it's perfectly round in the universe. I mean, not that I know of. I mean, I could be wrong. Who knows, dude? You know, I mean, dude, I'd prefer not to talk about that stuff, man. Like, I'm not looking for an argument on the internet, dude. You know, if you believe this is some crazy light show, just enjoy the damn crazy light show with me, okay? No, I just understand physics and you wish you were trolling. No, you know, dude, I don't know, dude. I can't prove it. Like, I'm not gonna sit here. Like, that's the thing, man. You can figure out gravity from Einstein's theory, from theory of relativity. That proves it pretty dang well. But you know, like, I could sit here and explain it. Would I be changing your mind? I don't think I'd change your mind. I just don't think, like, most folks that are, you know, strong in their convictions, it's really hard to change their mind, dude. I don't really, like, I'm not gonna think less of people if they think that way. It's just, all right, you can think that way if you want, man. I guess as long as you're getting entertainment out of the stream, my dude. When the boat sails away from you on a coast, the hull disappears before the sail. Done. Yep. I mean, subtly, you don't need to explain it to me. Did you get those TPS reports done? Yeah. Yeah. If you could just go ahead and come in tomorrow, that'd be great. I mean, Dread, I will say this. I'm not, like, once again, I don't think you're looking for a bunch of math and a crazy explanation. Most people that ask me this question aren't. And I do get asked this question from time to time. The thing about space is, all right, you look at a city. Say you're standing in Manhattan. No, this is not like, oh, you're standing in Manhattan, you can't see the other side. No. Say you're standing in Manhattan, right? You got perfectly straight streets, right? And you got perfectly square long blocks and short blocks, right? That's a human idea. It's a human idea. You have a perfect grid. That's a human idea. Humans think in uniform, right? That's how we think. We think uniformly. So if you look at like a city as opposed to a forest, completely different thing, right? Like, obviously, you're going to stand in New York City, and then if you stand in Yellowstone National Forest, the environments don't look the same. So now you're sitting in Yellowstone National Forest. You're looking around. What do you see? All different types of trees. Maybe some are falling over. You see brooks. You see, you know, volcanoes. There's all this kinds of crazy stuff going on. The terrain is not perfect. It's not uniform. There's mountains everywhere. It's very random. There's no rhyme or reason to it. You know what I mean? I mean, there's trees, and you have similar trees and stuff. So there are some patterns, but for the most part, it's entirely random. You know, the terrain is based off of plate tectonics, right? And the trees are there because, you know, they seed and they grow, right? That's what they do. They've done that for millions of years, right? The point that I'm trying to make is that it's imperfect. It is not a human construct because we don't think perfect. We don't think like that. You know, you look at a house in the middle of a forest, you could tell that that's not supposed to be there because it's not uniform with everything else, right? Because humans think, you know, you have a nice cube house, like you think a log cabin, right? Right? The forest is imperfect. It is completely imperfect. It is totally random. space, that, you know, is like that. Space is not perfect. Earth is tilted. It's spinning on a tilted 27-degree inclined orbit. And then our orbit isn't perfectly circular either. That's why we have leap years, right? You know, you notice how some years, some months have more days than others? It's because our orbit isn't perfect. It's not a perfect circle. Heck, Earth isn't even a perfect sphere. All the other planets, no planet is on a near zero axial tilt. It's totally random and totally imperfect. Like, once again, I could go and sit here and tell you the math about everything, but the fact that space is also imperfect tells me that we didn't come up with it. It is very imperfect. Does that make sense, dude? Once again, I'm not going to sit here and try to sell you on math. That's a waste of time. But if you go and read about how space is, just read about planet orbits. Earth's orbit comparatively to Mars, comparatively to Venus. It's all super imperfect, just like a forest would be. There are patterns. Planets are orbiting, obviously. But there are patterns in forests too, with certain types of trees in certain areas. Or if you're in the desert, you have plants that are growing next to a river. There are patterns. There are patterns like that in space too. But it's very random. Does that make sense, dude? I'm not going to try to sell you on it, man. If you're skeptical, you're skeptical. Healthy skepticism is a good thing. But just, I mean, consider that. I don't know. Maybe that'll help. Dude, it is so ridiculously random. There's no way someone thought of it. No way. Not a chance, man. S. Stop. Right? Dude, it is so ridiculously imperfect that there's no way someone thought of this. Could be wrong though. I'm not going to sit here and say that, oh, well, it's the scientific consensus that there's no consensus in science. Science isn't a vote. Science doesn't work that way. I'll explain dark energies. Sircon, I'll be honest with you. I don't know enough about it to explain it. And I'll admit when I'm out of my lane. I don't know. Dark energy? Maybe it's negative relativity. I don't know. I have no idea, dude. You could say it's perfectly imperfect. Yeah, you could say that about a lot of things. That's what my mom says about me. Wait. Yeah, self-burn, huh? Yeah, how often are you going to see that? Yeah, I gotta keep myself down a peg or two, Sleepy. Because if I don't, you guys will. I'm a streamer. It's chat's job to stick it to streamer. Yeah, man. It's so ridiculously imperfect that I don't think people came up with it, dude. I'm like, that's a selling point for me. And there's no crazy math behind that or anything, you know? There's no crazy math. Like, dude, space is a very violent and imperfect place. It's very much like Earth. Earth was a very violent place. It still is a violent place. We've tamed it to an extent, but you can't stop a hurricane now, can you? You know what I mean? Space is like that. Space is trying to kill you at more times than Earth is. All the time. Space is trying to kill you all the time. That's how I know nobody thought of this, you know? Because if we thought of, if humans was, if an idea, if space was an idea that humans came up with, it'd be much more like heaven. You know what I mean? Dude, we ain't that good. We're good, but we ain't that good. Helen Hunt, Ken? Wasn't that Jodie Foster? Contact? All right, never mind. Yeah, Phoenix. I mean, he probably did something. You're not wrong. I read stream. Oh yeah, you read the stream title too fast. Yeah, Bill, we got an oil leak somewhere. I'll just put an exclamation point in there because I forgot to. Yeah, Zelly, it's so ridiculously imperfect. That's like that was one of the selling points for me, because you know, when you're learning this, you don't blame you for being skeptical. Being a skeptic is part of being scientific. That's literally part of the scientific method. You're not trying to prove your ideas, you're trying to disprove your ideas. You know? This is why I don't really have problems with, you know, if people are like, oh, I'm skeptical, I think the earth might be flat. All right. Okay. You know, I could sit here and try to go into theory of relativity and gravitational pull and mass and force equals mass time acceleration. But people don't want to hear that. The people that think that, they don't want to hear that. They don't want to hear that. And if they have, they've heard it before. Screw that. I'll figure out something else. I'll figure out another way to explain it. You should make SLS and KSP. I did the other day, Cody. I made a shuttle-derived launch vehicle. Last Kerbal Stream, dude. Yeah, so people don't want to hear that, dude. They don't want to hear that stuff. You know, the best way to address this is just say, hey, dude, if you believe that, that's fine. You can go believe that over there. I'll believe that over here. We'll enjoy the light show. It'll be fun. Could we do smart reuse like Vulcan on SLS? No. Vulcan is a first stage, T-Man, and it's really not going to go much faster than maybe 7,000 miles an hour. The SLS core stage is going to hit the atmosphere going 17,000 miles an hour. You would need one big heat shield. You would need a big enough heat shield. You would need such a big heat shield that honestly, it would weigh down the launch vehicle and make using hydrogen and shuttle engines not even worth it. Airborne, everything is looking good. NASA isn't tracking they're not working any problems as far as I can tell right now. Perhaps an inflatable heat shield, and even that, Tesla, you'd need like a 20-meter wide inflatable heat shield. It's just not worth it, man. It wasn't designed for it. You'd go redesigning so many systems, you might as well design a new rocket. That's my way around theological discussions, too. You believe you, I believe me. Yeah, Deadbringer, I mean, yeah. If you want to think that, that's fine. But I find that people that are skeptic of like, not settled science, not consensus science, but, I mean, relativity is the best theory that we have. And it's not a theory, it's been proven that gravity bends light. That has been proven. Heck, if you look at one of James Webb's first pictures, you could see that James Webb actually pointed at a galaxy and used light refraction from that galaxy to magnify other parts of the universe. They actually used an entire galaxy as a magnifying glass because of relativity. But I could sit here and explain that, but people don't want to hear that. They don't want to hear that because, like, most people already made up their mind, dude. That's the big thing. It's really hard to change somebody's opinion about something when they don't want to change their opinion. Gravitational lensing is metal, dude. That's the coolest thing I've ever heard. Yeah, exactly, Chupon. Bingo. Mm-hmm. Yep. But, you know, like, the other thing, fellas, is that if somebody has a dissenting opinion from me, I ain't gonna get mad at them either. Why? Why would you even bother? Just because somebody said something I don't agree with and I don't get all bent out of shape about it, that's ridiculous. That's what children do. I don't do that. Except sometimes. Sometimes people troll me pretty damn good and it does piss me off. You little pieces of shit. But yeah, no, you know, if you want to come together, have a discussion as adults, I don't have a problem with that. I ain't gonna get annoyed because you think differently than me. That's ridiculous. Evil Rays, we're looking good. NASA's tracking no problems. SLS was fueled ahead of schedule. They are in ICPS fueling right now. Ford sucks, GM bets. Well, Tessa, in that case, you're wrong. You know, that's fine. You can be wrong. It's okay. I think differently than you and you get annoyed. What makes me different? Well, what makes you different, Jackal, is that I don't like you. Yeah. There's a mission in planning that would send a train of... Sorry, Jack. That was a joke. I delivered it a little too deadpan. Sorry, and I was moving on to the next thing. I'm kidding, man. There's a mission in planning that would send a train of spacecraft to 100 AU to use the sun's gravitational lensing to image details on exoplanets. Cool. I'm in. Let's do it. Not bent out of shape by gravitational lensing. Good one. I throw science quips in there because it's funny. Why so late for the launch? I was telling other viewers, this public, that the real short story is that the moon has to be in the right place, and if you miss, you're not getting the capsule back. They need parts of this capsule back for Artemis 2, so moon's got to be in the right place. Concerning the truck, clean the area very well, put the camera down there. You want to work on that now? Well, does the F-150 Velociraptor suck? I hat about the electric Raptor. I have a hat on too. Yeah, Scrot, I'm with you on that one. Which is why, like, with Dread, you know, like, dude, you sound like you got your mind made up. If that's the way you think, dude, that's good. I'm not going to try to change your mind. I never try to do that, dudes. I never try to change anybody's mind here. I just explain things. And if you like it, you like it. If you don't like it, you send it right back. Believe me, people let me know when they send it right back. You know? Well, I got to change hats twice now. There you go. Three hat changes back to back. Fine. You did this. 420. T-minus 420, baby. That's what I'm waiting for. That's what it's all about. Woo! That's the number. That's the meme number. Ah. You suck. We're trying to look like rock stars, Gene. Instead, we look like a bunch of freaking vankers. That's a good looking rocket. Yeah, Sigma, I'm a fan. I'm a fan. I love SLS. I do. I'm an SLS fan. All right. I celebrate that rocket's entire catalog. Block 1, Block 1B, Block 2, EUS, VOLE boosters. I celebrate the whole catalog. For my money, it doesn't get better when SLS shoots an Orion capsule out to the moon. Damn shame about K-Mac lap 1. Yeah, Danny. Yeah. Do you think they'll get past SLS 6? I heard they ordered through 10. Or was it only 6 so far? Wasn't sure how the funding is set up now. Right now, on the books, Panda, there's going to be... Hi, Red, by the way. There's... On the books, we're up to Artemis 4. The long lead items for up to Artemis 12 have been ordered. We do not have a block buy on the core stages, but right now they have pretty much all the engine orders placed up till Artemis 12. And the Orion capsules to Artemis 12 are purchased as well. The exploration upper stage is currently under critical design review, and once it passes CDR, then we should start seeing those get made. That should happen sooner rather than later. Yeah, me too, Yuri. Thanks for the info. So, Red, I have a feeling, and I don't... Oh, wow. Look at that, S. Yeah, that tour is really hardcore, dude. I wish we had that when I built it. Red, I have a theory that after this launch and based off of the telemetry from Artemis 1, we should see a block buy. And I have a personal theory. This is EJ's crazy, please don't make me change my tinfoil hat opinions here. I honestly think that NASA low-key wants SLS flying 4 times a year. And if NASA doesn't want SLS flying 4 times a year, I have a theory that there is some commercial customer for SLS. It doesn't make any sense doing it that way, but I've read nomenclature just... Like, okay, I'll give you an example. I've read things, that are very strange, okay? Now, one thing that's strange is NASA opening up multiple high bays in the VAB for commercial customers. Now, I have a theory that could be Starship. Could be Starship. Starship could use the VAB. That's kind of unlikely because Ketch Tower and Mechazilla, but Starship could use it. But they've opened up multiple high bays for lease. Why? That makes no sense. Unless SLS has some kind of commercial tenant. I have no idea. I have no idea who or what. I know that after Artemis 4, what they're going to do is spin off SLS into its own company. A wholly government-funded subsidiary, which is what they do. They did that with the space shuttle. The space shuttle was operated privately, believe it or not. NASA just paid for all of the missions. The space shuttle was operated by a company called United Space Alliance. USA for short. And United Space Alliance operated the shuttle, and NASA controlled the shuttle. So the space shuttle was technically privately funded. But it was privately funded. It was a private company, but it was publicly funded. Sorry, that's the right way to say it. So, I haven't heard much, S-Master. So, for Gateway, they need 3+ launches a year to keep it crewed. But Gateway is designed to be unmanned, or uncrewed. So, hey everyone, don't forget that the Europeans postponed Ariane 6 launch. Europe won't have any launch capability until late 2023, 2024. Ugh. Lunar Starship is planned to launch from the Cape and very well may need clean and maintained facilities. Keep that in mind. Oh, absolutely. Yeah, absolutely, Prey. But I firmly think, Red, that we're aiming... They're going to block by, and I think that NASA low-key... NASA and maybe some other customer... Like, NASA has hinted multiple times that they want a commercial customer for SLS. Maybe I'm interpreting that wrong, and maybe I'm interpreting that they want to commercially operate SLS. Like they did with the space shuttle, which does make sense. That does explain the VABs coming up for lease, because NASA would lease the other high bays in the VAB to the SLS equivalent of United Space Alliance, right? So that does make sense, but I'm not 100% sure. But I know I'm pretty sure we'll see a block buy after Artemis 1, maybe sometime later this year. Who knows? There's not much left in this year, so if it's not this year, it'd probably be next year. Joe Simbawan! Thanks, man. Thanks for the 5 subs. I do appreciate it. Right on. No, they don't, Jim. Not as of right now. Who knows? Yeah, very interesting stuff. So Europe might be looking to rent launch capacity from NASA. Yeah, but for SLS cross-pollen?
T-minus 4 hours and 12 minutes and counting here at the Kennedy Space Center in Florida.
I'm with you.
You're looking live at the Space Launch System rocket with Orion at the top, getting ready for a launch to the moon.
Open.
We are currently in the midst of cryogenic tanking the upper stage of the rocket after a 4-hour and 23-minute successful tanking of the lower core stage. Currently, both liquid oxygen and liquid hydrogen on the upper stage are in fast fill.
Red, I'll tell you, when this thing goes and we see those shots out at the moon, it's going to hit different than you think. I'm 100% sure of this. It will hit different. This Orion has cameras on it, and NASA's going to be live streaming views from the Orion capsule for the whole mission. We have that confirmed from NASA TV. Trust me, you see this thing out at the moon with live shots, it's going to hit different. You won't be as cynical about it. Trust me on this one.
The liquid oxygen team reporting out that they'd like to pick up the pace a little bit on.
I'm not 50, Red, but I'm right behind you. I'm 34. I get it. I get the sentiment. It's coming. Trust me. Red, I wouldn't just be... Red, okay. All right. Remember you saw me talking to the flat earther a second ago, right? You saw me talking to the flat earther. I'm not going to sit here and try to be like, you know, oh, well, this happens. Screw that. That's not going to help. Would I steer you wrong with this? Why would I say that I think it's going to launch and then just disappoint you like that? I know you, dude. Why would I do that? What would I do that? Just to make myself feel better that I think it's going to launch? Hell no, man. I wouldn't say it's close if I wasn't sure. I'm not in that type of business of just the feel-good news. I don't do that. I talk about the news in the space program. I follow it very closely. We'll get a moon landing. Couple of years. Trust me on this one. If not a couple of years, I'd say within 5. Now, you know this stuff takes time. It takes time. Got to be a little bit patient. But also, I wouldn't sit here and say with conviction that we're going to land on the moon on Artemis 3 if I wasn't absolutely sure. So, I mean, dude, I've a pretty good track record with this stuff, don't I? Am I right? EJ makes space propaganda. You shut your freaking dirty mouth. What's the payload? Well, you need a big rocket to get out to the moon, and the payload is quite heavy, Dan. I mean, your mother's up there. I'm sorry, man. I had to. If you want to punch me in the face, that's fine. I'm sorry. I had to. No, it's an Orion capsule in the ICPS, the interim cryogenic propulsion stage. Nah, the rocket ain't big enough. Boom! Oh, I did it again. Oh! I'm sorry. That was messed up. I shouldn't have said that. No. Okay. So, Dan, what do we got up there, dude? We got an Orion capsule. So it's the capsule with a service module attached to it, and the interim cryogenic propulsion stage, the ICPS for short. Basically, from here up is the payload. Anything that's see where this tapers in, that vehicle stage adapter. That's called the LVSA. Anything from here up is payload. That's what gets into low Earth orbit. So this thing will launch a fully fueled ICPS upper stage and an Orion capsule. Now, where are they going? They're going out to the moon. It's going to go out to the moon, and then Orion's going to use its service propulsion system, the European service module, to circularize, or, well, not circularize. It's going to capture around the moon into what's called a DRO, a distant retrograde orbit, which is like if you were going to the moon in Kerbal, and you hit your parasynthion and you burned retrograde, and it's just enough to capture the moon, but not circularize, just enough to capture is where it's going. And it's going to spend a week out there, and we're going to get live views of it, man. It's going to be sweet. Now, in terms of payload mass, Orion in the service module is about 25,000 kilos, about 52,000 or 54,000 pounds. It's pretty heavy. And then the ICPS upper stage is just a Delta IV derived cryogenic second stage. And yeah, we're going to get views like that, basically. Yes, and that too. There's going to be views on the solar panels. You'll almost have a third-person view of Orion.
Maximize power production in the deep space environment.
Hopefully that helps,
Another
Dan, and
week
hopefully you don't want to punch me
as
in the
Orion
face. I
coasts
mean, if you
towards
do.
Earth.
EJ ain't a rocket big enough to send
The
an American
European
mother up there.
service module separates.
You talk bad about my mother again, I'm going to find you. Fight me in real life. Fight me in real life. Sorry. I'm sorry, man. I'm having too much fun with this. That's going to be one of the cameras, guys. There's a camera on the end of the solar panel that'll look at the capsule.
At an altitude of 400,000.
See it on TV. Oh, God, Dredd, don't do this to me. Maybe a little on TV.
Orion will enter the Earth's atmosphere.
I got some news for you. I'm going to tear a hole in your atmosphere. Well, Pilgrim, Maybe if you eat the plasma off my capsule. Wait, channel points? Sorry, you're probably getting it all day. Primo did it without asking me, silly. You a photographer? I'm a combat correspondent. Oh, yeah? Seen much combat? Well, maybe a little on TV.
Two drogues used to slow and stabilize the crew module during descent,
Jono, it's a great
cut
movie.
free, and 3 pilot chutes are deployed, used to lift and deploy the 3 main parachutes. At 9,000
Nice,
feet
yes,
in
yes.
altitude and a speed of 130 miles per hour,
Oh!
the 3 main parachutes,
Units of measurement that I understand.
116 feet in diameter,
All right.
slow the crew module to a safe landing speed of less than 20 miles per
I'm working
hour.
on it, Stroker. I was actually at the post office yesterday.
After a 4 to 6
I'm working on
week
it.
long mission, and after traveling more than
I already made your mom
1.3
joke,
million
yes.
miles, Orion will target a landing 16 minutes after entering Earth's atmosphere.
Hey, all right. You know what the Imperial measuring system is? It's float. It's float point for measuring systems. It's true. There are more precise ways, but it's float. It's true.
Return to
Think
Kennedy
about it.
Space Center. We are going together and invite you to follow along at www.nasa.gov
It's close, Cody, but it's not exactly the same.
/Artemis-1.
See sub notifier. Let's go. Lighting a huge candle, hoping to celebrate the streak. Let's go. SLS fly, baby, fly. Indeed. Indeed. We're going together. Separately. But you hate channel points. I do hate channel points. I just haven't really bothered to go and shut them off either, silly.
Discovery, go at throttle up.
Hey, Spherecraft, 65 months. Huzzah! Oh, EJ, I finished learning AC/DC's riff-raff on bass. It's fun to play. Oh, riff-raff. That's Powerage. Old school. Very nice. It's Powerage, right? Powerage?
To learn
a
more
good song.
about Artemis 1, get to our website, nasa.gov/Artemis-1. Again,
Word.
nasa.gov/Artemis-1.
Good tunes.
This is Artemis Launch Control.
Are you even able to shut off channel points? Yeah, I could, Aqualex, but the box has been opened. So we'll just roll with it. So what did they change about Orion when the program changes? So Cody, what they were trying to do with the Orion CEV. So the Orion during constellation is called the Crew Exploration Vehicle, CEV for short. This Orion is the MPCV, Multi-Purpose Crew Vehicle. Now, I'm going to be honest with you. The real difference between CEV and MPCV are the letters. But the service module is European, and in Constellation, the CEV service module was going to be made here. They built that's one of the big differences. But honestly, the Orion MPCV, that thing, basically is what the Orion CEV was going to move to eventually be. The Orion Crew Exploration Vehicle for Constellation was going to start out as a low Earth orbit access vehicle, something analogous to Dragon or Starliner, and they were going to launch it on Ares 1 and upgrade it over time to make it an eventual BLEO capsule. So what's a BLEO capsule? Beyond Low Earth Orbit capsule. They were going to use the data from sending it up and down in space multiple times to the ISS. They were going to use that data to make a capsule like the MPCV. When Constellation went out, they said, don't do any of that. Just build the deep space capsule right off the bat. Which is, I mean, not really a smart way of doing things, if you ask me, but I'm just an armchair rocket scientist. Orang rocket gonna go. Height. Height. Yeah, Midge. We are about 4.5 hours out. There is a planned 35-minute hold. So they'll stop that clock up there on the top left at T-minus 35 minutes, and then at 12:34 they will resume. Actually 12:30. That's how you get things like the new WRX. Sugoi. Haha. Sugoi desu ne. Hi. Simple. Make a channel point redemption of 1 million to turn off channel. I like the way you think, Red. How much of this launch vehicle is coming back for reuse? The capsule, Chano, and that's about it. Now, I know what people are going to say. What do you mean it's not reusable? Everything should be reusable nowadays. Yeah, you're probably right. But when you go to the moon, it's really hard to reuse things. Yeah, when you're going to the moon, that gets a little difficult. The difficulty level goes up so much, Chano, that reuse, which is already something that's extremely difficult, gets even more difficult. Yeah, long story short, it's hard to incorporate something that has enough C3 to get something to where this Orion capsule is going to go. C3 is characteristic energy. It's hard to give something enough boom to get up there, send something out to the moon, and then come back down in one piece. That's really, really difficult to do. That's not something that we've figured out yet. Now, don't get me wrong. There are people that are trying to figure that out. See these two frames right here? There are people that are trying to figure that out. But even SpaceX engineers have said that this is an insanely hard problem to solve. It is really, really difficult. Bye, those. Thanks for the raid. Yeah, Chano, I'm with you. But you got to remember that Falcon 9 wouldn't even be able to get the Orion capsule close to a lunar injection orbit. No way. Inject. No, the burn that is generally regarded as a transfer from Earth to the moon is called a TLI burn, or translunar injection. Falcon 9 has put stuff out by the moon, the Transiting Exoplanet Survey satellite, and a couple of lunar landers that didn't work, but it really can't put something as big as Orion. Heck, not even Falcon Heavy could move this thing out there. You'd need... Falcon Heavy could probably get Orion to low Earth orbit, and that's reusing the boosters. This is the amount of power that I'm talking about. There's a reason why SpaceX is moving, trying to get away from Falcon 9, and, well, not trying to get away. There's a reason why they're pushing so hard for Starship, because Falcon 9 is an amazing rocket. But it's an amazing rocket in the same way that the Space Shuttle is an amazing rocket. It's really good at getting payloads into low Earth orbit, but getting beyond that does get a little bit difficult. That's where you gotta step up your game and build something like this. Building this is way harder than building a Falcon 9. Something like Falcon 9. Way more difficult here. There's a reason why, people harp on it. Oh, yeah, so why are you using 30-year-old parts? The shuttle and junk. Why you do? The reason why you do that is because if you want to get back into this game, you go with what you know. That's really, really important. That's a really important thing to understand. They are using old technology, but dude, the old technology is still the best way to do it right now. Zoom! It's going to take some time before we start to see some type of reusable architecture to get out to the moon. You got to remember, SLS is trading that reusability to get to the moon fast. Starship is going to need to be refueled multiple times in low Earth orbit before it can even get close to the moon. See what I mean? You're trading complexity for simplicity here. But hopefully we get to a point in the future where we don't, making an expendable vehicle, the trade-offs aren't there anymore because we have technology to be able to get back to the moon. That's, once again, that's Starship, baby. You know, it's going to take some time, but right now, I don't give a frick what anybody says. This is still the best way to do it. Because we kind of closed this book on doing this in 1972. So it's best to pick up right where you left off. You know, using rocket components that you know, because I'm pretty sure there's nobody left around that knows enough about Saturn V to remake one. I'm not saying it's impossible, but I mean, the shuttle engines can potentially afford you more power there, but just me. That's just me. Is this the closest Artemis has gotten to launching before they scrubbed it? No. We've gotten within an hour of count, Jax. I guess I'm confused as to why we're going to the moon again. What are you confused about, Brain Freeze? Artemis is basically a resto mod. Yeah, Dan, yeah, you could say it that way, but you know what, man? People build cars nowadays all the time. They resto mod cars, but you resto mod it with motors from the 60s. Ain't nobody gonna scoff at you. You put a big block Chevy in a car nowadays. You know, you have an IROC Camaro, you put a 454 in it, everyone's gonna be like, nice. Chevy hasn't made 454s in 30 years. Except as a crate motor. I'm talking about something in a car, you know what I'm saying? Sometimes the old tricks are the best tricks, brother. And I'm saying that as a Ford guy. Big block Chevy is very nice. Very nice. Nice. Rip the 392. Ah, oh, Vanilla, don't. I don't want to talk about it. I don't want to talk about it, homie. Chevy trucks have 496 as the option. I have found the obnoxious Chevy guy. Sorry, forget I said anything. No, I haven't, Phoenix. Can you afford to make this statement? Oh, yeah. Yeah, Pythos, I can. I got 2 Fords right there. I can 2 Ford to make this statement. Now what? Yeah, you weren't expecting that, were you? My brother put a 282 from a Mustang in his 55 F100. 282. So 4.6? Nice. Mod motor. Sweet. Isn't it going to take Starship 12 refueling launches to get it to the moon? Yep. That's the price you pay for reusability, Cody. That's what I mean. That's a complicated mission. I'm not in... Now, do not get confused. I ain't saying SpaceX can't do it. In fact, I hope they do. Fueling depots would be a very good thing to do for helping us get further in the solar system. But right now, you want to go explore the moon? You want to go explore the moon? You want to do lunar architecture? That's the right way to do it. Now, Brain Freeze, did you type in why? It's cool nonetheless. Like, are we just doing it for research or more? The whole thing behind the Artemis mission is to learn how to live and work on the moon, Brain Freeze. The long story short is it's preparing us for a Mars mission. That's the idea. Dan, you ain't wrong, dude. You ain't wrong. You're gonna get hella ideas soon. Yeah, I hope so. Dude, you're not wrong, man. I know people that work at NASA. They do play Kerbal. I'm dead serious, man. I play Kerbal. I'm a Kerbal nutcase. You know? Brain Freeze, the short story is that we're going to learn we're basically going to pick up right where Apollo left off. Got to learn to live and work sustainably on the moon for long periods of time. That will prepare us for Mars missions, because we're not just going to send somebody to Mars right now. That's not happening. And Mars is a 3-month trip out, it's a 3-month trip out, an 18-month stay on the surface, and then a 3-month trip back. 26 months total time. That is a long time to be in space. That's a long time. That's a long trip. That's a lot of time outside of the Van Allen belts. That's a lot of architecture to figure out. A lot of surface architecture, a lot of like, what does your spaceship look like? Are you going to do that all in a capsule? That's not going to work that way. We got to figure out ways to live and work on the surface of another celestial body for a long period of time. That's the idea, Brain Freeze. It's going to prepare us for going to Mars. Now, NASA just says, oh, it's just going to prepare us for going to Mars. They don't tell you what I just said. It's really important. Now, Why would we choose the moon? Is the moon like Mars? No, not really. Mars is a planet, moon's a celestial body. They are arguably two way different things. But I will contend to say this. One, the moon is 3 hours away via rocket, or 3 days away via rocket. That's better than 3 months. Am I right? Two, I would contend to say that it is harder to live sustainably on the moon than it is on Mars. If you can make something that, if you can make a base, if you can make a moon base, you can absolutely make a Mars base. It is easier to make something on Mars. You have more resources at your disposal, right? Earth is obviously the easiest. You want to make a sustainable habitat on Earth, literally just build a log cabin. You can't go building a log cabin on the moon or Mars, can you? You know what I mean? I mean, that'd be kind of cool. I'm sure on some planet you could. Not on those two, though. Moon isn't a planet. I know, it's a celestial body. Shut up. So, brain freeze, we're basically going back to the moon, picking up right where Apollo left off to learn how to live and work in deep space for long periods of time and on the surface of other planets as well. We're doing all that so we can figure out what would be the ideal way to get people to the surface of Mars in the near future. Does that make sense, dude? Igloos would probably work on the moon. Yeah, I mean, that would be kind of a bad use of water, Dan, but yeah, sure. Instead of longitude, use... Nice, nice, nice. Nice, Forge, that's cool. There's a parallel with your KSP playthrough here. Reuse is like building your own pads. This is like saying, okay, pads, but we want to get some awesome stuff done. Yeah, pretty much. Living in the lava tubes on the moon and Mars is doable, by the way. Yeah, I would want to practice doing that on the moon before we send somebody to Mars to their death. I don't know, Airborne, I have no idea. Why don't we just build a planet that's closer? Because we're not the Forerunner. L minus 4 minute or 4 hour 20 minutes. 2 hour launch window, guys. Want to go stream from Mars? Nope. No, I'm good. I like Earth. Earth's pretty sweet. You already said that people are expected to die on the journey to Mars. Yeah, ideally you don't want to do that, Niroku. Ideally. We should go back to an old landing site and look at the stuff to see how radiation destroyed it. Yeah, Gujar, I agree. I think an Artemis mission should do that, but yeah, NASA doesn't seem to want that. You really want to pick up, like they really want to pick up where Apollo left off? Go land where Apollo 17 took off from. Go see if you can drive that damn lunar rover around. Now, that's what I would be on about. Let's land right in Taurus Littrow. That's the way to get lunar missions, kick off lunar missions with a bang, am I right? Can we just make a really big lasso and move and pull Mars closer? I'm not going to say that that's an impossible thing to do, Jax. I'm just going to say doing that to us would be like showing Leonardo da Vinci the space shuttle. He'd be like, what is that? Is that the devil? What is this? That's the devil. Okay. I don't think we're smart enough to do that just yet. Just take Earth and push it closer to Mars. You want climate change, CJ? That's how you get climate change. You get a lot of climate change doing that. I don't think we need to do anything moving Earth. That's a bad idea. Yeah, that's a bad idea. Yeah, yeah, that's a bad idea. Yeah. Yeah, we don't want to do that. This radiation thing really bothers you. You want to deal with the radiation problems. Since smokers, 3-ish years of... Yep, no, that's gone. That went off the page. Since smokers? Is NASA planning to make a new rover? Yes, they're partnering. They partnered with GM, Cody. Yeah, they're going to make a new rover. 3-ish years of no smoking will add more years to their lives than the space radiation would take. I don't think radiation is as big of a problem as people think it is, Aqualux. It is just a problem that needs to be solved. Just like having oxygen to breathe in space is a problem that needs to be solved. It's not insurmountable. No way. Space 1999 used the moon as a spaceship. I don't think moving the moon is a good idea either. That would really screw up the climate on Earth. Like, there's that whole tide thing. Yeah, I don't think that's a good idea. Why don't we just build a really huge rocket engine on Mars and bring Mars to us? Okay. Are you guys just thinking up the dumbest possible thing to get to Mars quicker that you could possibly think of and just typing it in chat? Do you really love the lamp, or are you just saying that because you saw it? Do you think astronauts sign a death or dismemberment clause? Yeah, probably, Niroko. But they're on hazard pay when they go on orbit. I love lamp. Do you really love the lamp, or are you just saying that because you saw... I love lamp. I love carpet. I love desk. I love lamp. I love lamp. I love lamp. Yeah, no, Cody, I don't think we should do that. That's probably not a good idea. It's a test launch, brain freeze. So what they're trying to do here is they're trying to get a good read on Orion. And Orion, well, obviously you're testing SLS, right? But like once you get on orbit and once the SLS does its thing, you really, really want to, what they're really trying to do is get Orion out to the moon and then leave it there. Why? Why would you do that? They're trying to get Orion out to the moon and leave it there for a week to see how it fares on a long duration mission. Orion is a capsule that's basically the building blocks for this future Mars architecture that I'm talking about. Orion is a beyond low Earth orbit capsule. It is designed to operate for extremely long periods of time outside of Earth's gravity well. Now, I shouldn't say outside of Earth's gravity well. That's technically not right. It beyond, like deep space. Humans generally regard deep space as anywhere out of medium Earth orbit, so past the Van Allen belt. So the moon is technically in deep space, but it's not out of Earth's grav well. But it's technically deep space. When I say beyond low Earth orbit, that's what I mean. The capsule's designed to operate out there for long periods of time. So like, think about Orion as like half satellite, half capsule. That's really what it's supposed to be. It's supposed to sit up there for a long period of time. This is putting Orion through its paces and giving a good bench test for SLS. That's what this mission is for. Orion is actually pretty freaking cool. There's a lot of future-proofing that's gone into the capsule design. It's not just something like the Apollo capsule where we could just put people in. No, Orion is designed to be able to slave itself. That's probably not the right choice of words in this current year. It's designed to be able to attach itself to other vehicles and control them. Now, in Kerbal, that's no big deal. You just dock it and you hit right-click and control from here, and then you can control the entire vehicle from your capsule that you just docked to. Doing that in real life is a lot more difficult. Orion is future-proof to basically be able to become the command bridge for any larger spacecraft. So you have a gigantic Mars transfer vehicle, right? And Orion can dock to it, and when it docks to it, it takes control of the entire ship from the capsule. That is really crazy future-proof integration right there. That's why Orion is kind of like the foundation for this future Mars architecture that I'm talking about. So it's kind of a host module. Yep. Funny how Lockheed Martin and SpaceX are working to make Orion control lunar Starship. It's kind of difficult, but they're doing it for Artemis 3. Yep. So it's running its own OS. I don't know what it's running, Adina sign. So Orion is a parasite? Yeah, it basically can take control of stuff that it docks to. As long as the stuff that it's docked to is designed to be taken control of, right? So think about in the future... So during the Constellation program, they kind of came up with some concepts of what these vehicles would look like. Take something like this. This is like a potential future Mars transfer vehicle, right? The Orion over here can control the engines back here. Now, on top of that being a pretty ridiculous hardware system, the software to do that is very, very complicated as well. I mean, coders, that's some hardcore integrated architecture right there. And that's what Orion is designed to do. It's designed to take control of whatever it docks to. But if Orion's not attached to it, you can also control the ship locally as well, which is pretty crazy stuff, dude. That's like cutting edge space flight technology. That's really, really, really hardcore. What's Inspiration 4 below the Van Allen belts? Well below the Van Allen belts, yes. Yeah, that's AST, Forge. There are guys that work for AST that watch the stream, by the way. Yeah. So think about like Orion as the saucer section. If we're going to talk Star Trek terms, it's the saucer section. You can attach it to other things that make that saucer section go further, right? Don't have a coolant leak, though. If you get a breach of containment between the dilithium crystals, you're going to have a bad day. I can't change the laws of physics, Captain. Can't change the law. I know that's the original series, and I'm talking about TNG. Trekkies, I get it. Shh. Shh. I know what I'm talking about. Funny, I got to sit with some software engineers down in Houston, granted years ago, but they were like, hitting the enter key too early. We try and keep all programming as simple as possible. Sorry about the early enter. It's all good. Imagine it dock and finding the drivers haven't been updated. Yeah. They put a capsule on a rocket before and the drivers weren't updated and it didn't end well. You remember that? But can it run Crisis? Man, if it can't run Crisis, I don't want to be a part of it. So how many Orion systems will be testing for this flight? Well, solar panels, service module, electrical systems, navigation system, stroker. Basically, that's a fully kitted out Orion. The only thing it doesn't have is the environmental support and life control systems. Or the environmental control and life support system. Sorry, I messed the acronym up. It's called ECLIS. There's no life support on board. It's just a pressurized tin can of air, basically, of nitrox. And it doesn't have the seats in it, and it doesn't have a control module in it, like the control panel. This is testing all of Orion's autonomous systems. Like I said, Orion can just sit out there. It could sit out there for 200 days by itself, no problem. With people on board, 21 days. Turns out when people breathe, you need oxygen. And that goes down. No fuzzy dice. Maybe in the future. He looks like he wants to go to bed. Well, it's way past pudding time here. Oh no, what is your question? Fun thought project. Good name for the base on Apollo 17 landing site would be Challenger Base. Fold 2. Name for Apollo 17 in the shuttle. Yep, I agree. Good way for remembrance. Yep, I think that is a very good idea. Yeah, oh no, that'd be cool, man. I think that one of the Artemis missions should go to an Apollo landing site, and I think it should be Apollo 17. Pick up right where we left off. Do you want to work on the truck for an hour or two to find the oil leak? When is the launch? Sorry, I thought it was supposed to be tomorrow. It is tomorrow, Modern. 1:04 a.m. Eastern Time. Finally continue that game of golf. Now we're talking. How far do you think that drive was, Dan? That was a happy Gilmore drive if I've ever seen one. Do we know when TLI occurs? It's a... Oh, I don't have the mission timeline in front of me. Within a couple hours of launch. You hit that guy! Shouldn't have been standing there. At least a few thousand yards. I mean, well, I hope it was like a par 20. Geez. $2:33 a.m. Eastern Time on the TLI burn. Yep, thank you, Devlin. Unmute, EJ. Update. I am unmuted.
Rotation rule, but it is now thinning out, and that was the only one they're tracking. not within the launch area.
I'm going to be here for the duration.
And so because the clouds are starting to thin over the launch complex, we are back to 90% go for launch. Again, we are back to 90% go for launch weather. Only concerns that the LWO is tracking at this moment is the thick cloud rule and the cumulus cloud rule.
Damn, boy.
You don't see it in the shot. It is nighttime. But early in the evening, we did have some cloud cover over the area.
90% go, 10% probability.
But conditions are calm enough for the LWO to bump up the go for weather to 90%. Great news there.
I would.
Launch director has asked for another update in just about an hour on the weather.
Oh, that's cool, Scott.
And I just heard a completion of LOX fast fill complete for the upper stage liquid oxygen tank.
They're in topping on the LOX for the ICPS. That's very good. We're just waiting on LH2 topping on the ICPS.
And now they are proceeding with an LO2 tank valve test. Great news there. We're still tanking the liquid hydrogen in the upper stage. Again, another milestone reached. Fast fill is complete on the upper stage liquid oxygen tank.
I'm not saying nothing, Jack. No, you don't hope
this is
it
Artemis
works
Launch
faking
Control.
it. They replaced the seal. TLI burn is 20 minutes long. Low energy stages, banana time. What do you want? It's wild how explosive deconstructed water is. I know, right? It's kind of crazy, man. To be honest, it's a scary experiment. If we can't stand radiation levels there, we are locked on this planet. Hard disagree, Skylines. Hard disagree. We're not riding in a convertible to the moon, you know what I'm saying? There are ways around it. It's a problem, and it's a problem that needs to be addressed, but it ain't an insurmountable problem. Look at all the Apollo astronauts, dude. They were up there for 3 weeks. No, 2 weeks. Apollo 17 spent 3 days on the frickin' moon. They spent 3 days on the surface. Compare that to Apollo 11, who spent 23 hours on the surface. 3 days. By 1972, we were up to pretty good duration stays on the moon. And most of the Apollo astronauts lived a long, healthy life after that. Now, once again, the radiation is a problem. Absolutely. Duh. But it's a problem that you can address. You know, it's like sailing across the Atlantic Ocean and then worrying about getting wet. Why would you worry about getting wet? Of course you're going to get wet. It's a boat. Right? We can come up with a solution, you know? Jack Tank, Caslow, thank you for the resubs, dudes. Radiation shielding is too heavy at this rate. That you can live 1+ year in space. Radiation shielding? Skylance, what do you think radiation shielding is? What does radiation shielding look like on a spaceship? I'm curious. I'll have you know 100% of my boats are dry thanks to Flex Seal. Touche. Does it sway at all when it's on the pad? Yeah, a little bit. Radex. Mamsie, I like you. Weird flex, but okay. No, I wouldn't use water. Water will work, but I wouldn't do that. It's heavy. Can be both magnetic shielding and dense atom materials that block electromagnetic waves. Skylance, you can do it with aluminum. You want to bounce it. You don't want to absorb it, and you don't want to block it either. You want to bounce the radiation off, just like a boat hull will bounce water away. That's why I use that analogy. Right? You don't want to water shield your spacecraft. Bad idea. Water absorbs radiation. Not a good... Nope, that's not what you want in space. That's like a boat hull that absorbs water. That's not what you want. You don't want that. You don't want that. Making it out of aluminum or titanium or some other material, I'm sure we could come up with something. I'm like 100% sure. Because aluminum does the job pretty freaking well. And we learned that from the Apollo program. Were you at Geek Squad at Best Buy? I worked at Best Buy. That was the last normie job that I had. You need something that bounces the radiation, and there are tons of lightweight metals out there that bounce radiation. This is why I don't think it's an insurmountable problem. And even if it is, I'll still go. Whatever, that's fine. We learned things from the Apollo program. Write that down. I mean, you can ask your buddy that's working on this experiment, Sky. That's really cool. There's ways to get around it. There's ways. Imagine being a normie. That's impossible for you. Ooh, roast my vans. Skylands, I don't think this is an insurmountable problem, dude. I really don't. I really don't, and I honestly wouldn't let it bother you. This is it's a fixable problem. We can figure it out. Love that shirt. I was a Geek Squad agent from 06 to 12. Hell yeah. So I ordered one of these with the company thing because this is the shirt that I wore when we would unload the truck in the warehouse. I wore it so people would leave me alone so I could get the work done. Yeah. It's true. Smelly shirt's not smelly anymore. I haven't used it to unload a truck in 7 years. These days, warehouse people have to wear blue shirts. Oh, we had to wear blue shirts at the time. But if you have an undershirt and a collared blue shirt on and they ask you to unload a truck in the middle of summer, you will the rest of the day, you will literally smell like a gym locker. And people will not come near you because you smell. So we figured out another solution. And then they were eventually like, well, you have to wear your blue shirts. I'm like, dude, you're not unloading a truck. You see how hot it is in that trailer? Well, I'm a manager. I can't be bothered with doing things like critically think. You have to wear your blue shirts. It's company policy. I'm like, yeah, I know. You can't be bothered with things like common sense. Am I right? Am I right? Screw me. Right? Yeah, I guess we do. Yep, you're right. When rocket go up? 4 hours. Guess I'll go stream then. I guess I'll go stream then. Oh yeah, that was the conversation. They didn't like that. They didn't like me. When I was working at Best Buy, I was still very much in that talk back to your boss phase because frick the man. That's not a good mentality to have. That's a really good way to get on your boss's bad side. You probably shouldn't do that. Frick the man. Yeah, right. Staying up for this? Oh, I absolutely. I'm staying up for this and then some, man. I'm following that right. I'm in it for the views, man. The views are going to be like Starman. You guys remember Starman? But you still do that. Shut up, man. I don't have to take stuff from you. I threw it on the ground, son. I threw it on the ground. Sell out. Shut up. Shut up, punk. I said forget about it, cuh. I'm gonna go ahead and have to ask you to put your blue shirt back on. Yeah, dude. One time the GM, I was putting product out, and it was in the middle of summer, and I was on the sales floor with an undershirt. He's like, "What are you doing? What is this? A John Mellencamp video?" I'm like, "No." He's like, "You got to put your blue shirt on. What are you doing? You're not on break." I'm like, "Wow." All right, I'll go. Sure. I put my blue shirt on. All right, that's fine. I mean, considering we all pay your rent, we're technically your boss. No, you're shareholders. You're not the boss. Yeah, Hellfish, maybe we'll do that oil leak after or something. Something massive I noticed when moving from New Zealand to Canada when I worked at Canadian Tire. NA managers don't like their lowers questioning them. Yeah, Superfits. Yeah, it's the real ego thing over here. Great. How can I sell my shares? Well, if you look right next to your name, there's no sub icon, so you already did. So your word means dick in here. I mean, if you're going to be like that. Giving me flashbacks to retail, working in shirt and ties and handling food and stacking shelves. Yeah, I know. It's STX. It's like they almost didn't really put much thought into it. I had a manager that told me I had to wear a high-vis jacket in the yard, despite there being no trucks, only high-vis winter jackets, and it being in the middle of summer. What are you going to do, Dan? What are you going to do? There's a reason why I got out of that business, because it made my brain crazy. Like, I'm like, no, I don't need to do that. I will admit though, dudes, and this was a bit of Schadenfreude, and I really do feel bad about this. I honestly and truly do. Going in there and putting in my 2 weeks notice and saying like, oh yeah, I'm not really getting the satisfaction out of this job. I'm not really getting the satisfaction. It's really not inspiring joy in my heart anymore. Oh, okay. Yeah, we've noticed this. So what are you going to go do? Do you have another job lined up? Oh, yeah. I'm going to go play video games and get paid for it. What? Yeah, that's really doing well, and it's really satisfying and engaging work, and I really enjoy doing it. Oh, well, all right. See you later. That was freaking, that was cool. That was really cool. I'm not going to sit there and pretend like your boy wasn't kind of a jerk. But also, yeah, it's a little bit of a dick. Probably shouldn't have laid it on that thick, but it's a life lesson. You learn, you live and learn. Sorry, Best Buy people. My bad, man. I was a complete tool. No, I seriously said stuff like that, dude. It was bad. They knew I was full of it. They knew I was just saying it to be a jerk. And now, dude, it's kind of cringe when you think about it. It's kind of cringe. Oh, damn it, Alex. Why? You know what? This hat, I only put this hat on for a second, so this hat's getting some hat time again. It hasn't gotten hat time, and you're still a jerk? Yeah, tell me something I don't know. Mando, what up? Well, here, you were playing games. Yeah, I know. It's awesome, Rain. Every time I haven't gone into Best Buy for a while, but every time I do go into Best Buy, or if I see someone from Best Buy, they go, still doing that streaming thing? Implying that I've failed somehow. I'm like, yep, nope, doing the same thing. Still make money off of it. It's pretty dope. What is it with you guys? You don't like the Endeavor hat? Damn it. I like that hat. God. You know, Bob, that will only make someone try hard just not enough to get fired. Oh, Sparks! What? What the f... You really suck! You really suck! How many hats do you have? Don't worry about it. All right, fine. I'm getting another one. You guys better not. All right. Don't retrieve another one, please. I'm running out of hats.
Discovery.
Kuro! We're going deep until you come back with a cowboy hat. Don't make me wear this, man. Come on. Somebody redeem another one. Somebody redeem another one, please. Help me out. You can hook me up with a Tractor Supply hat? All right. One of the solar panels didn't deploy. Oh yeah, it's got to be like this. No, it's got to be your bowl. Sorry, EJ, you told us not to. Oh! Screw you, chat! Screw you! Doom ba doom ga doom ga doodly doom do doom ga doom ga doodly doom ba doom ga doom ga doodly doo do doom ga doom ga doodly. Up, you redeemed it again. No more cowboy hat for you. You redeemed it again. Not my problem anymore. You're just gonna have to wait until it comes around in the rotation again. Two times more. Stop it. It's my Asteroid Day hat. The Asteroid Day people gave me. Those people are cool. It's... Yeah, but Syrian, there's a problem with that hat. It ain't no 10-gallon hat. It's a 10-liter hat. You know what I'm saying? It's too small. Do you have a KSP hat? I don't know. We need a cool down on the hats. Yeah. Do you have a Boring Company hat? I do. I just don't know where it is. Yeah, Hoglegs, yeah, they were kind of stupid. Yeah, I'm getting my steps in. That's right.
Discovery.
Where's the propeller hat? I don't have that. 17-month resub. Nice cowboy hat, though. Thank you. You have a Patriots hat? I do. Or do I? You're going to have to find out. Dead scum. I gave you a hat. Where's that one? We haven't gotten that far into the rotation. Do you have a Boeing hat? I don't know where it is. How about a Lions hat? I don't have... Damn it, Dama. What happened to the automatons? It's next to my rack of hats. No, you know what? I like getting up to show the hat. There we go. Oh yeah, this one will get voted off the island real quick. Look at it. Oh, look at. Oh, that says champions right there. Oh, you guys said change the hat. Oh, nobody's redeemed it yet. Oh no. Ah, crap. Damn it. Ruining my fun. There you go, Arnok. There's your hat. Deflategate? That was a quarterback thing. That guy ain't my quarterback no more. You can make all the Deflategate jokes you want. I don't care. Doesn't get rid of our Super Bowl rings, boy. Super Bowl. Get the Yankees hat? We all know you have one. You are a bad bass player, Dan. You don't know what you just did. The Eagles took a hat away from you? Yeah, they did, Naroku. You know what, dude? That was a good Super Bowl. That was one of the few Super Bowls where I think the Patriots got truly outplayed by the other team. You guys were on fire that year. I'm not even kidding. With that being said, piss off.
Go at throttle up.
Stupid birds. Birds don't exist. Damn drones. Oh, look. Look who decided to buy shares. Screw you, S. I'm not congratulating you. You suck. Take that. I want my shares. No. No, you don't get it. Why you got to be so rude to a fellow Dan?
T-minus 3 hours and 17 minutes. until liftoff of the Space Launch System.
Mute that
That's
shareholder.
minus 3 hours and 47 minutes. We have a half-hour hold that we're going to be going into at the end of, towards the end of the countdown. I want to give you an update now.
Ew, blue? No.
The launch team is tracking an intermittent leak on the cord stage replenish valve. This is on the hydrogen side. The location is at the base of the mobile launcher. The team reporting to the NASA test director, it's going in and out of
4%.
of leak measurement. Momentarily, it spiked to 1.5%, but then came back down, and they continued to monitor it. Going over 1% is the violation.
4%
It was only there for a
fast
short
fill.
period of time, came back down. It's 1% is the violation, Mark, as I understand from the engineers, because this is an open air sensor, different from the closed volume sensors on the previous leaks, if you may recall from the previous launch attempts. So the team is monitoring it. If it were to continue to degrade, it would put the upper stage LH2 into stop flow. It's back down at the moment into the 0.2 range. And so, again, the team just continues to monitor, but they have advised Launch Director Charlie Blackwell Thompson that there's not a lot they can do from here. If it were to go back up above 1%, they would have to send the red crew into the pad.
Ugh.
Now, that's the team that is specifically trained to go into the launch pad with a tanked rocket and do work. But we're not there yet. I want to emphasize, not there yet. Again, the team's monitoring this.
Nobody's expecting
Of
the
course, we'll
Red
keep you
Crew
updated.
Inquisition.
Percentage-wise, let's talk about the upper stage.
Going
We are
throttle up.
at
Razzlack.
60% filled for the liquid hydrogen upper stage.
No,
For
it's not too bad, Donald. It's just
Liquid
a small
oxygen,
spike.
we're almost filled.
Where's the
Currently
leak,
at 92%. Again, upper stage 60% for liquid hydrogen
ma'am? Oh, leak events.
and 92% liquid oxygen. We're in fast fill for liquid hydrogen and topping for LO2.
I didn't expect that. I think.
Quick look at the core stage just to review. We can put up a graphic that'll give you a check on that.
the red shirt.
Core stage reached its replenish mark, which means fully tanked and filled at 7:45 p.m. Eastern Time. And there you see the graphic. 100% on both tanks.
I'm with you, Gallatin. Let's send it.
The core stage, of
But we
course,
gotta make sure it's right. So
750,000 gallons of super chilled propellants.
why not just say
And
over
of course, we'll continue to
500,000
track the
gallons?
countdown. This is Artemis Launch Control.
Sean, does it annoy you? Are you pissed? Are you pissed? It's like 200% full. Yeah. Nice hat. Oh, thank you. All right, so it looks like they had an LH2 leak leak flow rate sensor go slightly above. Now, don't get me wrong, guys. They have a like when you flow hydrogen, you're always going to get some hydrogen gas. It's just kind of a byproduct of moving liquid hydrogen around. NASA does know that it leaks, and they have a scavenging system in place to catch all the hydrogen gas. But if it goes too much, if it leaks too much, if the leak rate is too much, that means there's something
Quick update,
wrong.
We are now in stop flow for the liquid hydrogen core stage. Again, we are in stop
Tacky
flow
mushrooms.
for liquid hydrogen core stage due to an intermittent leak.
They
the
stopped out of
replenish
an
valve.
abundance of caution. They stopped the fast flow on the second stage. But this is why planned holds are in place, dudes. So no, This is why they have planned holds in place, dudes. That's why that timer up there isn't correlative to the liftoff time. There's aggregate amounts of time in case something like this happens. Artemis oil leak? No, my truck's leaking oil, not Artemis. Like, yeah, my truck, the red and white one, not the dark red and black one. This one's leaking oil. We got to figure out where that's coming from. That's not this. This is not leaking oil. This is leaking hydrogen. Can we just pour some of that stop leak powder in the tank? You don't want it to stop leaking, Chupon. If hydrogen stops leaking, you're going to get an explosion. You need it to leak, but the leak rates need to be at an acceptable flow. You're not going to flow liquid hydrogen and not get some hydrogen gas. The thing is, that's just kind of a byproduct of moving it, right? It's just a byproduct of flowing gas around. It's always going to leak a little bit. It's the leak rate. The rates at which it leaks at. If it leaks too much, even if it's a fluctuation like what they just saw, fluctuation of leak, what happened? Because if it's leaking too much, that means it could be plugged up somewhere in the system somewhere else. You do not want hydrogen gas leaking too much. I don't think I need to tell you what happens when hydrogen gas leaks. Hydrogen does this thing. It really likes finding things that make it explode.
That they are now putting
you don't want that
into work to send the red crew.
That's bad.
Into the pad. Again, the NASA test director putting together a plan to send the red crew into Launch Complex 39B and the mobile launcher area. Discussion is about an intermittent leak on the upper stage.
That's why they just
intermittent leak for the core stage replenish valve, which is inside the mobile launcher. Now it's in the planning stages, so they are not going out there yet.
The red crew, they aren't calling them red shirts because of Star Trek. The red crew there is basically the crew that is trained on operating around a rocket that's fully fueled. That's their color coordination. They're not red shirts. Please don't call them that. That would be very bad.
The packing nuts at the base of the ML. The leak has increased. And so the team currently taking planning action.
I hope
to send that
so,
red crew team in. Of course, we'll keep you updated on the latest. This is Artemis Launch Control.
Yeah, he said packing nuts. Do you guys mind
so
if I just...
Red Gate has advised that they are now putting a plan into work to send the red crew.
It's a ground side system, Novus. Yeah,
into the pad. Again, the NASA test director putting together a plan to send the red crew into Launch Complex 39B and the mobile launcher area. Discussion is about an intermittent leak on the upper stage. Intermittent leak for the core stage replenish valve, which is inside the mobile launcher. Now it's in the planning stages, so they are not going out there yet. But again, the team being mobilized.
Yes, immolated. Those are for instrumentation.
The red crew operates out of a building about 4 miles away from the launch pad. Discussion is around torquing down the packing nuts at the base of the ML. The leak has increased. And so the team currently taking planning action to send that red crew team in. Of course, we'll keep you updated on the latest. This is Artemis Launch Control.
Lettuce. So, packing nuts. No, that's not those packing nuts. There is a valve that's leaking, And sometimes I'm just going to get this out of the way. D's nuts. All right. D's nuts. There you go. We've got it out of the way. I can't explain this without that joke being made. We'll get it out of the way, and now we will proceed like adults. Okay. The packing nuts are on a flange that are between, so it's basically a pipe. There's two pieces of pipe that are bolted together, right? And then there's a sensor in there, right? And it's going to leak, and it leaks into a scavenging system, okay? And what these packing nuts are there for is basically to hold everything together. The thing is that when you flow hydrogen through these things, everything contracts. And if the bolts are made out of some type of different metal, they might contract at a different rate than the flange, and it might make a leak. And basically, long story short, when you flow hydrogen through things because it's so cold and all the metal contracts, that you can actually change the torque spec on something. You have to do a lot of preloading when you're using cryogenic fuel. You have to over torque things, and you have to overstretch, under torque and under stretch things because it's contraction, not expansion. And basically, the nuts can actually detorque themselves because they're cold and they contracted. That's what can cause a leak. It does happen. There is a ground side leak, Jester, in the mobile launcher, and it's a valve and pipe that goes to the second stage liquid hydrogen topping system, the ICPS topping system. They have a slight persistent overreading on the leak rate on a system that is inside of the mobile launcher that is designed to monitor hydrogen flow up the launch umbilical tower and into the upper stage. The NASA flight directors and flight controllers, launch controllers, are now coordinating what's called a red team. The red team is basically the hazard pay group. They're going to go out there, and if I heard that right, the guys are going to go out there with a bunch of ratchets and just with a torque wrench, just retorque the bolts, and then they'll flow the hydrogen again. The reason why the red team gets hazard pay is because they're going towards one of the biggest rockets that's flying around fully fueled. Hopefully you ground yourself. It's very dangerous. They are the crew that's designed to operate in and around the rocket when it's fully fueled. That is not... Now, don't get me wrong. Rockets are relatively safe when it's fully fueled. But it'd probably be better to not play games with the big exploding thing up there. Especially when hydrogen is involved. Yeah, Geek, to say that there's some hazard pay would be a little bit of an understatement. Guys, all right, hang on. I'm taking the CRST hat off. Sorry, Ernok. Taking it off. I think I've exhausted my hat supply. I'm going back to the NASA hat. I want my NASA hat. I want my NASA hat. Hats off to you. Thank you. I love this system, but I don't think you could pay me enough to do it. I'd do it. Sure, why not? As long as you understand the system. Thanks, Jonathan. That will be this hat change. Paco! 61 months. Do you have an Artemis hat? I don't. No.
Discovery,
Biggie.
throttle up.
Yeah, I'd do it. Why not? At this point, do you think Starship is going to go to the moon before Artemis? No, not even close. You want an Artemis hat? I'll go buy one, sure. You'd pee yourself?
Discovery, go at throttle up.
Good to know. I also can't believe we're finally here, right, Tori? Yeah, I know. Yeah, of course. Yeah, they have the biggest. Why am I hearing Discovery go at throttle up? That's my resub alert, Jester. People sub to the stream, it plays Discovery, go at throttle up. I was gonna say that the big sub alert that pops up every time that plays, it didn't ring any bells, huh? I actually did go to the post office the other day, guys.
Discovery,
I'm
go
working.
at throttle up.
See, I'm working on we're working on the PO box. That's one of the things I did the other day. Modern, thanks for gifting us up to Asmalok. Appreciate it. This issue could scrub the launch? Yeah, sure, of course, Port. I don't think it will, guys. I think they just need to retorque it. Ha! Joke's on you. I watch with my eyes closed. Oh, yeah. Sorry, I should have been more cognizant of that. Should have. Yeah, Zandy. Oh, I'm sorry. My bad. I shouldn't have been standing there. Wait, I just joined. Is there a current issue with Artemis? The line inside of the mobile launcher that leads to this fueling line right here. Right when no, go back. No. The line that leads up the tower to this fueling line right here, down there, they detected a leak rate and they think that something came unbolted during fueling. They detected over or outside of family leaking rates. Now, don't get me wrong. Once again, I'll say it once, I'll say it again. You flow hydrogen, it leaks. It does leak.
Discovery, go at throttle up.
The rate of leak is what spooks NASA. That's what scares them. You don't want it to leak too much. You leak too much hydrogen, you get this.
Discovery, go at throttle up.
You leak hydrogen, hydrogen likes to leak. If you leak too much, it'll go places that you don't want it to go, and it will find a source of ignition. Like that. Great album cover. Somebody should use that as an album cover. I know about Led Zeppelin 1. Fine. Lance, Pop, thank you very much. If NASA knows about all this, how do they keep messing up? They're not messing up.
Discovery,
This is
go
something
at
that
throttle
you
up.
have to take into account, Cody. You can't be sure that every single one of the million moving parts on this vehicle is going to work exactly right. This is why plan holds are there.
Discovery, go at throttle up.
So when this launches, will the capsule be coming back down in a few days? It'll be out. It'll be about a 2-week mission. Random name?
Discovery,
Yeah,
go
about a
throttle
2-week
up.
mission. Thank you for all the subs and bits, guys. I do appreciate it. Modern Inferno with 5 subs. Thank you. Yeah, Curly. You know what? I'll just take the oil leak thing out of the title for now. We'll put it back in later. We've just gone to full launch coverage here.
Discovery, go at throttle up.
Yo, Red Baron, what's up, dude? 15-month resub. Thank you. That's a lot of nuts. That'll be $8, baby. You want fries with that? I think you cursed Artemis by having leak in your title. I do not leak. You leak. Guys, it always leaks. This is what I'm trying to tell you. Are you not listening to me? Hydrogen leaks. It always will. Physics says it says it'll always leak. All right? That's like saying you want to boil a pot of water and then worry about some of the water turning to gas. Oh, no. If I boil water, it shouldn't turn to gas. No, it has to because physics. Because boiling water, you get water to a certain point, it's going to boil, it's going to evaporate. That's what happens. Anytime you flow hydrogen, the exact same thing happens. But hydrogen doesn't exist as a liquid at 0 or at like 5C and then boil at 100C. Hydrogen exists as a liquid at like absolute 0, almost absolute 0, which is like minus 300C, something like that, right? And then its window for being a liquid, water's window for being a liquid is 0 to 100C, right? Right? That's why that whole system exists. It's based off of water, right? Hydrogen's nominal window for existing as a liquid is like maybe 2 or 3 degrees centigrade. So if you're flowing cold hydrogen through a hot pipe, it is going to leak. It's going to turn to gaseous hydrogen. And why does it turn to gaseous hydrogen? Well, it evaporates the same way that water will evaporate into steam if you have a pot and trying to make top ramen. You know what I'm saying? Now, why does hydrogen leak then? It leaks because hydrogen is tiny. Hydrogen is one of the smallest elements around. Hydrogen and helium, they're super small. right? Hydrogen is extremely small, and it will leak out of literally everything. It'd be like trying to make a boat out of a sponge. It's not going to work. It'll leak. So you're going to have some leaking. It's going to happen. There's no way to get around it. You will leak everywhere. The key is to make sure that you only leak at the rate that you're basically filling at. You're going to boil off some is going to be, some hydrogen will evaporate into gaseous hydrogen. You have to be able to control it. You have to be able to get that hydrogen through a scavenging system away. There's basically a vacuum cleaner attached to every flange on this damn thing. No, not every one of them. There's basically a vacuum cleaner at strategic spots where they think it's going to leak. And that vacuum cleaner, it's creating vacuum. It pulls the gas in. And that's basically attached to the biggest Bunsen burner you've ever seen. There's a purge flame that's about 300 feet or about 100 meters off the pad. And it's literally just a gigantic Bunsen burner. It burns off the hydrogen, and then it has holes in to pull the oxygen in, and it creates a vacuum, and it pulls the gas through. So they're all attached to a vacuum cleaner, but that vacuum is being created by a gigantic purge flame, which is just a big Bunsen burner. Literally the same thing. That's how they get the hydrogen to not pool in the wrong spot and explode. There's literally a vacuum cleaner attached to every one of these lines. And the rate at which it leaks is what they're worried about. If it leaks too much, that means something's wrong. This isn't going to happen. Well, thank you for the vote of confidence. Appreciate it. Is there a mission timeline, for example, booster jettison? About 2 minutes, 2-minute 30, something like that, Stroker, somewhere in there. Is Artemis launching tonight? We are on track for a launch. There are some slight the leak rates are slightly higher than anticipated on a system that's inside of the mobile launcher. It is a ground side system that is part of the system that fuels the upper stage. Gaming jetpack! Thank you very much. They did fuel up quickly, guys. They are ahead of the timeline right now, so this does give them a little ample time to fix this problem, which is why they said send the red team in. Stay for the Kung Pao quotes. Oh, momento. Did they ever say what engine shroud materials are made of? It's Nomex. It's just heat blankets, Mitro. They are not going to fix the problem. What? Shuttle at SRB SEP around 2-minute 30, so I'm not sure if the 5-segment boosters have a longer burn or just a more powerful burn. They do make more thrust, Donald.
Discovery, go at
Which
throttle.
is why I gave kind of an aggregate time. I'm not 100%
Upper stage
sure.
LOX is in replenish. Upper stage liquid oxygen is in replenish. Meanwhile, the launch team continuing to work a solution to an intermittent leak at the core stage replenish valve.
It's always leaking, Health. It's just always leaking. It's the leak rate, guys. Jesus.
Around sending a red crew.
Hey, Nafron, thank you.
Into the launch area, up to the pad, and having them go up and torque bolts.
Well, I mean, Ark, you know, if everybody was just a negative Nancy all the time, geez, we probably wouldn't have to worry about launching expensive rockets and complicated rockets like this. If we're just a negative Nancy, we'd just sit on our couch all day and make stupid comments. Just a thought. I'm negative so you could be all positive. Ah, I see what you're doing. I got you, man. I got you. Well, you just go be negative over there on the couch, boy. Gordon, you excited? Right on, man.
Discovery, go at throttle up.
The couch is big enough? The negative Nancy Arc couch? Negative Arcsy couch? I'm trying my best. I knew you wouldn't let me down, buddy. When you put it like that, it doesn't sound bad. Well, I mean, Ark's there. Ark's a good dude, but also, you know. But also, I don't know about you sometimes. Kind of sucks if now is when it launches and not the 2 times I went to Canaveral, rip. It seems like they should super chill the H2 connections before torquing. Maybe. Do we have a delta angle on those booster struts? They're straight, Dead Crew. The off booster struts are not tilted down like this. They're straight up, meaning that's a pretty damn good indicator that the vehicle's fully fueled. When will they send the red crew? I'm not sure. I kind of shut off Daryl because I was being a jerk to Ark a second ago. So we'll next time Daryl gives us an update, I will shut my mouth. No lettuce update. I will give you an update on the lettuce. The lettuce is good. Lettuce is good.
Discovery, go at throttle.
Street! Tier 2 73 month resub. STS 73, October 95. Columbia flew the Space Lab for the second time. Pretty stacked crew, including Michael Lopez Alegria's first flight. Flight had 6 scrubs before launching. Why would you mention that last part? I'm getting some coffee. You know, go join Ark on the Negative Nancy couch. Go join Ark. Negative Nancy. No. No. Hell asked that question. Did I get the couch from Brazzers? No. The Negative Nancy couch is one of those couches from the 70s that looks like it's a square. You know exactly what I'm talking about. The one that has like the obnoxious wool cloth and you sit on it and it itches. Yeah. That's the Negative Nancy couch. Boom. It's like the principal's office couch. It's like wool and gross. I'm back. Can you give us an update? Lower, they are detecting a out-of-family leak rate on the LH2 fill line for the second stage inside of the mobile launcher. So this thing down here, see this brick thing right here that the rocket is attached to? This is the mobile launcher platform, and it's what's attached to it is obviously the rocket, and then you have this thing, this truss structure right here. That's the launch umbilical tower. So LUT, MLP. Launch umbilical tower, mobile launcher platform. When those two things combine, they become a mobile launcher, or an ML for short. NASA's launch controllers had detected a leak in the upper stage LH2 fill line inside of the mobile launcher. So basically there's a fuel line that goes up here somewhere, and that fuel line goes into this thing right here, and this thing fuels the thing that has the American flag on it. That is the interim cryogenic propulsion stage. The hydrogen fill line goes down here, it goes into the mobile launcher, and then it connects over here to the hydrogen farm, which is that way. There is a leak somewhere ground side on this thing. And don't get me wrong, when I say there's a leak, that means their leak rate. I've gone into detail a little bit of how hydrogen systems work, how you need a purge flame because you don't want hydrogen gas pooling. It's always going to leak. The short story is that stuff, the hydrogen will leak. But if you put a vacuum cleaner basically right on the spots where you know it's going to leak, you're going to have a leak rate. So the rate at which it's leaking. They detected slightly off nominal leak rates on the LH2 fill line inside of the mobile launcher. When you do that and you're filling something and it's working right, and then all of a sudden it's starting to read higher leak rates, that means you have a problem somewhere. Because if it's detecting a higher leak rate, that means the hydrogen gas is not going where you want it. And if hydrogen gas doesn't go where you want it to go, this happens. Okay? This is what happens with hydrogen gas. It will find something. It will find something and it'll explode. Okay? Don't do that. That's the Hindenburg. If you don't know what that is, it didn't end well. Oh, the huge manatees. What? Where are the manatees? So, they are working on a solution, and that solution probably is going to involve sending a team of guys out there to go and inspect said pipe connection and retorque the bolts. That's the other thing about moving hydrogen through pipes. You move hydrogen through pipes. If you have two pipes that are bolted together, right? Those pipes have a flange face, and that flange face will have an O-ring in it, right? Now, I'm guessing about the O-ring part. It might not. It probably does. If it got too cold, something came up, basically what it's going to do is loosen the bolts because everything contracts when you move hydrogen around. So they may have sprung a leak in a spot that they don't know about, or it could be something as simple as just tightening the bolts back down, because flowing liquid hydrogen for long periods of time will freeze the pipe, and when the pipe freezes, it'll contract because physics, and when it contracts, it can literally loosen the bolts. So it might be
T-minus 2 hours,
might be just
44
as simple
minutes
as
and
tightening
counting.
bolts.
Have an update on the situation with the intermittent leaky valve for the core stage liquid hydrogen. The NASA test director just
Seems
briefed
all right, Pasquale.
about getting ready to
happens,
send
dude.
the red crew onto the launch pad. The cause is an intermittent leak on the core stage liquid hydrogen replenish valve. Its location is on a skid on the side of the mobile launcher. As a result, the liquid hydrogen for the core stage is in stop flow,
That's not what you said before.
coming out of replenish, which replaces the liquid hydrogen that is boiled off. And so the only way to fix it at this moment is to send a red crew out to the pad. This is inside the blast danger area and is considered a hazardous operation.
No, Corey, he said that it was the ICPS LH2
Here's the plan.
fill line.
Launch team is going to send 2 technicians
I guess it's the core
with a
stage
safety
now.
lead to compartment AB12. That's on the side of the mobile launcher
Okay, Donald,
to
I got
torque
it. Yeah,
packing
that must be the
nuts.
one that I missed. Nuts.
to resolve the intermittent leak. The techs will take 2 vehicles, drive up the pad surface. They'll exit their vehicles, go up the stairs to the 0 deck,
Hardly.
then
does.
downstairs to the location
Okay.
where the valve is.
It's basically everything
And
that I
then
just
torque
said, but
the
for the
packing
core
nuts.
stage, not that thing.
The red crew says it should take them about 15 minutes to do. Then they would return to their vehicles from the route that they came in on. Now,
Okay.
emergency services, EMS,
Torque
have
the
been
thing.
notified along with Pad Rescue, and they are standing by
Yeah, no
for the
smoke
start
breaks.
of this operation.
Don't smoke if you got him, dude. I wouldn't do that.
And right now, the NASA test director is briefing the launch team on the procedures. HASGAS will be closely monitoring sensors that are with the technicians for
Probably
high
Milwaukee.
concentrations of oxygen, hydrogen.
This kind of, so for the people that are asking, this kind of stuff does happen. It happened during the shuttle missions all the time, dudes. And before you say, I see people in chat being negative Nancy's. You can go sit on the couch. No.
Discovery, go at
And
throttle
then
up.
people say, well, why does this happen all the time? Why does this happen all the time? Can't NASA do better? Yeah, I mean, you're asking NASA to break the laws of physics. That's like saying, oh, can't NASA make a boat that doesn't get wet? Can it make a boat that doesn't get wet? I mean, it's kind of difficult. It's boat, water.
Torque down bolts inside the ML where the valve is has been briefed the launch director. It's been signed off on. And we're awaiting the departure of the Red Crew team out to the launch pad. Stand by for more updates. This is Artemis Launch Control.
Discovery, go at throttle up.
Delta 4 has leaks all the time, Talon. You just don't hear about it. In a second, we'll see some dudes literally drive up to this thing in some trucks. They're going to drive down the crawler way, and they're going to... Oh, there's a shot of the blast detonation area. They're going to go right through that gate. Red team, go! Red team, go! You ever see the back of NASA's moon rocket? On hydrogen? Is there somebody there? What? I don't know, man.
Go at
Red
throttle
team,
up.
go! Red team, go! Anyway, Nico, hey, checking in. LH too much? Yeah, we got a little bit of a leak. Why red shirts? Star Trek has not taught us anything. No, shh. Red 5 standing by. Red October standing by. It's a great movie, man. Get some moon rocks, man. Red team, push B. Push pad B. Push pad B. Go, давай, push pad B. Now that I have my coffee, I'm ready to watch Red Team. Pad A is better, though. Last time I checked, Pad A don't have no moon rocket on it, boy. Yet. Okay, yet. Yo, I think I'm gonna make a run for it, B. Just sit down. It's in progress, though. Oh, yeah, that's the same thing. Yeah, you guys are right. How silly of me. Yeah, sorry, my bad. Now, guys, I want to point out here. You're pretty safe being next to a fully fueled rocket, believe it or not. I know that sounds kind of ridiculous. It's rockets that are being fueled. That is the dangerous part. Now, don't get me wrong. Rockets have all kind of pyrotechnic things, and they're literally explosion factories. They take an explosion and they force it out of a funnel. It is literally a thing that is designed to make explosions and put it in one direction. There's always going to be some risk. But the risk actually goes down when you're near a rocket that's fully fueled. That's why NASA is willing to send a team out there to go and check the systems here. You know, the rocket is dangerous when it's being fueled because you're changing the pressures, you're changing the temperatures, and you're literally changing the molecular structure of the rocket by filling it with extremely cold fuel, right? It's like, you know, if you have a car, you fill up the tank with gas. Car's going to handle a little bit differently because you have a full tank of gas than it does without, right? Because you change stuff, right? Fueling it is the dangerous part, okay? Technically, the upper stage is being fueled. It's still on replenish. Replenish isn't fueling in rocket nomenclature, Hellfish. Nice try. No. Topping is not... Replenish is not fueling. How's the launch countdown? There is a leak on a ground side hydrogen system, Jensen. The leak rate is above expected. NASA's sending people out there. They're going to send the red teams out there to go and inspect the thing that they have the leak detection on, and they're just going to retorque the bolts on it and see if it works. Now, fellas, I want to point out again, they finished fueling this thing about an hour before they were supposed to. They were up on the timeline until this point. So they're playing with house money right now. Or house time, I should say. You're playing with house money. We got plenty of time until the launch window. We have 3 hours. Okay? So there's plenty of time to implement fixes, which is why NASA said, let's send the team out there and see if we can fix this problem now. Tomahawk Tom, 32 months. Thank you very much. At infield, pre-flight complete. All right, cool. Confirmed leak is ground side. That's correct, Nico.
All right, Launch Director Charlie Blackwell Thompson.
No, Jim, not even close.
Just gave the go for the Red Crew team to enter Launch Complex 39B that you see there on your screen.
Why didn't NASA
to work
check this
a
before launch?
issue with a leaky replenish
They
valve
are checking it before launch, Cody. Where have you been?
on the side of the mobile launcher. The mobile launcher is the gray structure that you see there. The Red Crew team is
they're doing what you're saying.
Highly trained group of individuals, 2 technicians and 1 safety lead that will be making entry into the pad to tighten down bolts, the packing bolts on the valve.
They'll be driving up the road right here. And
it is a
going over there.
straightforward job as described to me by the launch team. Once they're at the valve location, the Red Crew has advised it should take about 15 minutes to do the work. So they should be in and out of there relatively quickly. There's no troubleshooting to be done. They have a specific task that they're going to go in there and perform. And then they'll depart the pad.
I'd do it, Nibsor. That'd be sick.
It is a hazardous operation inside the blast danger area. And the launch team will be tracking their every movement. EMS is standing by, along with pad rescue.
I'd be wearing some kind of respirator.
We'll keep you updated.
You don't want to.
This is Artemis Launch Control.
The thing I'd be most worried about, Yankee, is grounding myself out. I'd be wearing some big old rubber shoes. This is as safe as me doing a red ball on an F-22 ejector seat. I don't know what that means, but I'll take your word for it. Switch to Nisv. Anything sounds bad when you call it the blast danger area. Yeah, you're not wrong.
And so the PC sensor
Hey,
would
that's
tell
Doug.
you when you were getting ready to, the propellant was about done.
All right.
So we knew just before they would separate, but the ride was just incredible. You know, it ended up being you felt the main engine start about 6-ish seconds prior to liftoff, and then
he's talking about the
at
shuttle.
T0, boom, we were off to the races. I mean, the acceleration was just incredible, but it was you've seen the videos, right? Yeah. You know, we're just kind of sitting there shaking as we're going up. Yeah, and it's this constant, and I kind of equate it to driving an old World War II Jeep as fast as you can go on a gravel road, bumpy gravel road. That's what it felt like. And for 2 minutes, you just felt like you were accelerating and continuing to accelerate as we're burning off main engine fuel, because as a shuttle, the main engines were burning, of course. And so, 2 minutes and 8 seconds later, you get the big flash in the windows and the front seats, and then the boosters would separate, and then it was just like driving a boat on a very flat, smooth lake. It was just totally different experience once those boosters came off. But we were, just the hard part of climbing through the thickest part of the atmosphere was over, and that's that's the job that those boosters did, and they did them well.
And you mentioned too the like that initial jolt at T0. So how different was that from the last vehicle you flew on? That I think it was either you or Bob actually went. Did we lift off?
Yeah, it was different. Obviously, it was liquid engines for Falcon 9 motors. Thrust was, I think it felt equivalent to some degree, but certainly you didn't get that almost like getting shot off the catapult of an aircraft carrier like the solid rockets were. So it was maybe a slightly gradual acceleration, but you definitely, you felt it. Smoother ride relative to what we had in shuttle, but more G's. That was, the profile was different for different reasons. But yeah, it just seemed like all the rockets, you feel the vehicle groan a little bit as you're climbing out, and you get those same sensations. It's just slightly different because of the different propulsion system.
Yeah,
gotcha. So one of the things that we're looking at for this is there's obviously a lot of flight heritage hardware with the solid rocket boosters.
You bet.
But what is different about their systems, not just the added segment, but what is the difference between the shuttle era boosters and the ones that we have here for this vehicle, hopefully tonight?
Not a great deal of difference. It's a similar propellant. We've tweaked things like that. We've tweaked our production as we put these things together, but they are essentially,
that's Chris G.
If we could have updated things, we updated things, but they are essentially those shuttle boosters, repurposed shuttle boosters. Certainly with one more segment and 25% more thrust.
Yeah, baby.
That's the big difference.
And to the thrust, right? That's obviously the biggest thing that the fifth segment does. Does it alter the burn time appreciably?
Not appreciably.
My understanding is it's the diameter that actually determines the burn.
You bet. I've learned so much working out there. Is just it's a fine art form. Is the duration of the burn and the timing of the burn. But essentially, these boosters are going to burn almost exactly the same amount of time as we did in the shuttle profile.
Cool.
126 seconds.
Nice. And so we've also heard quite a bit about the stack life, right? And I know in shuttle they had this down to a cadence and a science, right? Stack them, get it out to the pad, launch it. But you've been stacked for a couple of years now. And
quite a while. Yeah.
So what were those analyses? We always hear, there are analyses that Northrop did to know that it's still safe to go. But what were you looking at? What's the data that you're actually trying to pull out of there to know you're okay?
Yeah, a lot of it has to do with how the segments go together and the joints and the redundancy within those particular multiple joints that they had between each segments, which obviously keeps the propellant from flowing outside of the cases. That's the way I understand it. Is that's one of the bigger things we have to look at as those boosters sit and it settles. Those joints can be affected potentially. We've been pretty stringent about what our requirements are for how long the vehicle can be stacked, and very conservative for obviously the right reasons. But we've looked at it and we've actually said, hey, we can go through December at this point and potentially quite a bit longer into next year if we need to. Some of it might be temperature dependent on the launch day. So the colder it gets, obviously those joints perform not as well as they do when it's warmer. But we certainly think that there's potential to go well out into into the spring if we need to. But we're going to launch tonight, so let's not worry about it.
We're going to launch tonight. Exactly right.
My God.
We're going to launch tonight. So, we've also heard a lot that there are portions of this vehicle that a lot of the teams are waiting to get the data back to make alterations for Artemis 2 or to know that you're good for Artemis 2.
Interesting.
The boosters sort of strike me as we've done this for 40 years. We kind of know them. But what is the data you're sort of looking for coming back during the flight to know, all the flight data proves out based on the ground tests, and what are you looking for?
That's good questions. I think, the biggest thing with the entire vehicle is you certainly want to collect all the data you can get from essentially as soon as those engines lights 5 seconds before liftoff, all the way to we recover Orion in the Pacific in December. And, certainly pour over all those data feeds that we can get. I think the other thing, for us specifically for the boosters, we know what the thrust profile looks like. We know what nominal performance looks like. We just had a test out in Promontory in July.
We were there for it.
Yeah. Oh, great.
Yeah.
Yeah. And so, just making sure that those numbers look right down the middle. And if they don't, then we have to figure out, okay, why was the performance off? We'll have thrust performance, we'll have burn times, we'll have all that stuff, and we'll certainly understand if we have any specific issues with the boosters from that data. And of course, after the 2 minutes, the boosters are going to end up, unfortunately, we're not going to be able to recover them. It's not designed to do that anymore like we did for shuttle, so we can't look it over. So that data is going to be very important.
And that actually great link to the next question that I've got, because during shuttle you could get them back, you could take them apart, you could look at them, but you have to rely on that data. So all that has to come back to the ground instantly. Are the boosters themselves the ones transmitting it, or are they sort of sending it through?
That's a great question. I don't actually know. Yeah, whether it comes straight from the boosters or it's through the whole data load packets that come back from the vehicle.
Gotcha. But it is a different way of doing it, right? Because you really have to. So were there added sensors? What did you do to sort of make sure those you're getting the data on those joints?
Well, I think what we've had from a heritage standpoint is more than enough for our folks to understand what's going on, and we'll see what we get.
40 years of flight history can give you.
Well,
a lot,
and I think that's that was one of the reasons it was decided that this was going to be the design of the vehicle. We've got that history with shuttle with the main engines and with these boosters. We understand them.
Crews are approaching the blast detonation area.
We can identify where the issues are fairly quickly because we've got such a great amount of flight history.
Gotcha.
In a minivan?
So we've obviously got Artemis 1 on the pad. Artemis 2 is following after months of data reviews and everything like that. So the solid rocket boosters for those, are they basically done and just waiting for NASA to say, all right, good to ship? Or is there anything from Artemis 1's flight that you're waiting to see? Do we need to tweak anything?
I think, the short answer is we've got Artemis 2, all those boosters or the segments and the Artemis 3 segments all ready to ship. So we're complete with all those. I mean, certainly if we see something we don't like, there may be something that we need to address. We will, but we're kind of leaning forward. And as soon as we get the, NASA, hey, send those boosters down, we'll send them down and get it stacked and ready to go for Artemis 2.
Minivans.
Awesome. So aside from that, so we also talked about the increase, the 5 segments, getting that increased thrust. Anything else that 5 segment gives the vehicle over the shuttle 4 segment solids, aside from the increased thrust?
That's pretty much the majority of why they, it's a bigger vehicle. I think shuttle generated roughly 6.5 million pounds of thrust. And it was a 4.5 million pound vehicle. Yeah. This vehicle is a couple million pounds heavier. So it really was just a case of, hey, we need more thrust to do the same thing that shuttle would have done with 4 segment boosters, and that's why we designed it the way we did, or added that extra segment.
Gotcha. So curious, with all the times that SLS has gone up and down the crawlerway with them, and and everything, and obviously we hope it doesn't go down the crawlerway again.
No kidding.
Yeah. No. But you had all those strain gauges on the outside of the boosters. What did you see with that roll data? Did it meet your performance expectations?
Yeah, everything was great. I mean, and once again, I think that's your advantage of having a design that we've got so much history on.
Shot of the launch pad.
To maybe not
and the 2 vehicles at the
wheel
bottom that just arrived.
It doesn't need to be reinvented. We certainly can refine
the 2
it.
technicians.
And our plan is certainly for Artemis 9
and the safety
subsequent,
representative.
Composite booster, so we save a bunch of weight.
This is the red crew.
Really modern technology with
that is specifically tasked to go out, tighten some bolts
going
on the core stage. Hydrogen replenish valve
in the meantime, for Artemis
on the side
we've got
of the mobile launcher.
Hardware, and we're going
it is a hazardous operation. But as you can see from this camera view,
first 8 missions.
Nice.
And I have view of the safety team here. they're monitoring multiple camera views and
I
watching
guess my other question. So
watching the red
you've been
crew
on
as they
them.
do their
so
work.
You helped crews get into the shuttles, right? You
Yeah.
were here doing
Looking
that. I think we were
to,
talking before we
fix
went live. STS
an intermittent
109,
leak.
you said, was your first
Yeah.
one.
Yeah.
So you've seen them launch, but
They
you've also
popped
been
up
on them when
Yeah.
they've ignited.
about
So
an hour ago.
what does it feel like to be back here today? Now, like getting ready to see even more powerful ones in operation.
That's the thing. We've never seen a 5-segment booster or two of them together launch a vehicle. We've got to see one out in
No,
Promontory
not right now.
in July, but this is just going to be incredible. And that very distinct crackle that the boosters make, I'm looking forward to hearing that, and then obviously seeing it light up the night sky. It's going to be incredible.
11 years since we heard it, and a little longer for you since you were on that last one that we
yes,
all
sir.
heard.
Yes, sir. Yeah.
But so I guess for you too, you've had a great career in the
Thank you.
military and as an astronaut, and now you're here. So what is it that you hope that you can now do now in your career to help further our space
Crews are moving
exploration
towards
endeavors?
that now.
I just think, part of it is, it's all about inspiring that next generation. This is, we're going to the moon again, finally. And just to be a small part of that and contribute from Northrop Grumman's perspective, it just seemed like a great fit, and it's an honor to be here. I mean, it just really is amazing to finally be here. I've gone through a couple moon programs in my career as an astronaut, and we finally have one that is going to do it, and it's really exciting.
Yeah. Well, Doug, thank you so much. I mean,
Thank you.
that's what I had prepared for you.
Yeah.
It was wonderful to get to talk to you, and here's
Thanks,
to a
Chris.
wonderful launch of SLS today,
Yeah.
pending that leak resolution, right? Thank you so much, Doug.
Yeah.
I
Thanks,
really
Chris.
appreciate it.
Yep.
And Das, back to you.
Good stuff. Good stuff from my buddies over at NSF, guys. So that was Doug Hurley. Doug Hurley is a former NASA astronaut. He works for Northrop Grumman now. Northrop Grumman is they make the boosters for SLS. Doug Hurley is famous because he flew on the last shuttle mission. He was the pilot on the last shuttle mission, STS-135, last space shuttle to ever fly in July 2011. And the vehicle that replaced it, he was the first one to fly on. DM2, Demo Flight 2 on Falcon 9 in May of 2020. Restored American launches from American soil with American astronauts. He was the commander on that mission. And Bob Benkin, who is actually retiring from NASA too, it was the pilot. So that guy flew Dragon in space, flew the space shuttle multiple times, and now he works for Northrop Grumman working on the boosters. It's pretty damn cool, man. Doug's cool. I'd love to talk to that guy. That'd be pretty sweet. But what's going on here is, let me switch over to the official, back to official here. Let me just make sure that's muted. Go over here. Sorry, professional streamer. The crews are now on the launch deck, which is not far from this camera, actually. Do you know what the boil-off rate is for a fully fueled core stage without topping? I don't know, Jazos. Yeah, it boils. I don't know if hydrogen boils at the same rate that like water boils at. I'm not sure. I'm guessing that even though it's Florida, they aren't allowed to smoke. I would not be smoking near this thing. That is an extremely bad idea. Why aren't we recovering the boosters? Infrequency of flight. SLS is only going to fly once, twice, maybe 4 times a year. It really doesn't make sense. That was from our buddies over at NASA Spaceflight, who are down there covering the launch as well. Yeah, the other thing to take into account is that those SRBs are leftover shuttle SRBs from the shuttle program. They are casings that were reused through multiple shuttle flights, just like the shuttle engines. What's the smoke coming out for the sides again? It's gaseous oxygen that's coming out up there.
Throttle up.
SADS World, the reason why is because, once again, the propellants that are inside the orange part of the rocket, liquid oxygen and liquid hydrogen, they're stored at an extremely low temperature and not extremely high pressure, but at a higher pressure. They're stored at high pressure at a low temperature, so they boil. So SLS is in replenishment mode, which is basically the propellant's boiling off, so they just top it off every once in a while. And the propellants that do boil off, they need someplace to go, so they give it a vent. Now, that up there is gaseous oxygen. You don't want to vent gaseous hydrogen next to your gaseous oxygen, because when those two combine, that's what's supposed to happen down here. So the hydrogen systems go through a purge flame, and then a little bit off screen over there, if they could turn this camera to the right a little bit, you'd see a 3-story tall Bunsen burner that's designed to burn off the excess hydrogen gas. It literally is a big Bunsen burner. That's what it is. It's the purge flame. Has the red team started working the fix? They are out on the pad somewhere. They're on the launch deck. Last time we saw them, their demo, but yep. Yeah, I did see it. Can you estimate the size of these dudes' stones based off of that image? Yeah, they are quite literally right next to the rocket. So they had a little bit of a leak. They're sending a team out there to just retorque the bolts on the part of the core stage replenishment fuel line, or well, just the fuel line. Yeah, we'll see if that fixes it. They're sacrificing the safety officer to the spaceflight gods. I don't think that. Yeah, packing nuts. Yeah, exactly. Is there a constant production of propellant, or is there a fixed quantity of propellant stored at the launch pad? Fixed quantity. You don't produce on site. You don't want your rocket fuel factory next to your rocket launch pad REM. I think the lock makes it feel chilly. Probably a little bit, yeah. What are the chances this still happens at 1? Chances are still high, Brimo. Last time we checked, weather was 90% go, which is good. Nice dish. Do you think they're using hand tools to avoid sparks? I would not be using power tools near a rocket in any way, shape, or form unless it was absolutely 100% needed, Jim. These guys have a couple of wrenches. No joke. What is PGO? Probability of go. No, they were ahead in their fueling timeline, Bree. So they finished fueling about an hour ahead of schedule, so they got about an hour lean time. Once again, this is why planned holds are in the count for stuff like this. Take into account unknown unknowns. They can't predict the future, guys. So you hedge your bets, but even then, you're still gonna get a curveball from time to time. Me realizing that half of the viewers have no idea what that means, you're still gonna get something that you don't expect. Dale, no power tools. So no welding. No. Welding is quite literally a controlled short circuit. You do not want a short circuit next to your gigantic jug of explosive propellants. That's not a good idea, man. Phrasing. Phrase D's. Got him.
Discovery, go at throttle up.
So what are the chances this actually flies? Pretty high at this point. Username, 30-month resub. Thank you. What about duct tape? Duct tape would freeze off. It's a hydrogen system. What if you weld it with a torch? I hate you. I hate you guys. You guys suck. Go to the negative Nancy couch. He said jugs. Damn it, Viking. Professional streamer right here. God damn it, man. Out of all the things, that's what makes me laugh. Why? Why would you do this? Oh God. Don't say that, geek. You don't know that for sure. It's the leak rate out of Family Ivan. It always leaks, remember. Hey, baby. That's the
T-minus 2
boosters.
hours and 13 minutes. We are tracking the red crew, 2 technicians and a safety representative that have made entry to the launch pad and are currently inside the compartment where the
I know,
leaky
Jerry. Yeah, you
replenish
ain't wrong.
valve is. Again, the red crew, which is a specially trained crew to work in
2 hour
and
window,
around
B-Money.
a fully tanked rocket, is inside the compartment area
It's not
where
delayed, guys.
the leaky replenish valve is. It's on the liquid hydrogen side. Their job is to torque down the bolts, the packing nuts on this particular valve, and that is, as I understand it from the launch team, currently in work. Safety team is watching on cameras that are in and around the launch pad. This is not a
Let me at
totally
it. I'll do it.
uncommon operation. The red crew, there's a number of individuals who stand by ready to do work on the red crew who are specifically trained in their areas of expertise when
I'll do it.
they have to put hands on at the launch pad after or during
Nah,
tanking.
Heavy metal, I think you might be sick. Certified for that hardware? Oh,
So this
yeah.
is likely to eat into the launch window.
They're not red shirts, they're red team. Uh-oh. Eat into the launch
An
window a
update
little bit.
on the tanks. We are in replenish on both the liquid oxygen core stage and upper stage. We are in stop flow
More than that, Jack.
for liquid hydrogen on the upper stage and the core stage. And that stop flow, of course, is related to the
I
intermittent
think
leak
so, SWK, yeah. You drop the rocket?
on the replenish valve
there's no
that's on the
gears
side
this
of the
entire
mobile
thing.
launcher.
Shut your mouth.
We saw the red crew go in. The red crew estimates it'll take about 15 minutes to complete the job,
Am I a goon? Yeah, probably a little
and then they're coming right back out. This is Artemis Launch Control.
Alright. Prepare to fast forward. Preparing to fast forward. Fast forwarding, sir. Fast forwarding. We'll stop it. Vertical speed. Go! No, pass this part. In fact, never play this part again. Do you think they'll have some kind of metal insert, rubber insert to avoid metal on metal contact? Maybe. It really depends on what system it is, dude. I'm not going to sit here and pretend like I know what the heck they're working on. I know it's a pipe. And that pipe is somewhere over here. They went inside of the lower part of the ML, guys. Think about the size of the socket wrench they were using and probably in biohazard. They're just in jumpsuits. Knight, we saw them go in. They're just in jumpsuits. What does the process timeline of events look like after launch? Booster separated about 2 minute 30 seconds, give or take. You should get main engine cut off about 8 minutes into the flight. And then spacecraft separation shortly after that. After spacecraft separation, it's about 90 minutes? No, about an hour actually for the TLI burn. I'm staying here until TLI, and probably a little bit after that. I'm not missing the first translunar injection since December of 1972. Screw that. I'm here. I'm here for the duration. T plus 90 for TLI. Yeah, it was 90. Thanks, Banana Time. It's because of the MEO insertion orbit. SLS isn't going to go into a parking orbit in low Earth orbit like Apollo. This thing is shooting that Orion capsule to 1,000 nautical mile by 20 nautical mile insertion orbit at main engine cutoff. It's going big. Of a man-capable vehicle. Yeah, Core, that was the implication there. Maybe I'm not going to work tomorrow. This thing will not be making TLI until 3 a.m. Ask me how many fricks I give. What is this launch for? Testing out our deep space capsule, Rave Wolf. This one's going to the moon. See that thing up at the top, the white part? She's going to the moon, baby, if she launches. First time in a long time. How many frickle fricks? Snickle frits. What?
Discovery, go at
Yeah,
throttle.
Bruno, I think you might be sick. I think you're coming down with something. You got the bifida. The anal bifida? What? You're sick. Colin sick. Watch the launch. Trust me. It's really cool. What? Nothing. Bifida? You got the bofida? I think you might be right. It's just it's a quote from Dukes of Hazzard, man. Sorry. 3, 2, 1, go!
T-minus 2 hours
Discovery,
and 7
go at
minutes and
throttle.
counting.
Nice, Jack. There you go.
We are currently
90 minutes, Lenprod. Paper
tracking
City.
work done by the Red Crew. Currently out at the launch pad, a specially
Oh.
trained crew,
Red team,
torquing
go!
down some bolts on a hydrogen
I
replenish
saw it, Jack.
valve.
Yeah, no, we saw it on here, dude. Where were you?
The safety team has eyes on it. They're currently doing that work. I want to make a programming note for you. Currently, if you're watching NASA TV's main channel, we are now going to begin the special launch broadcast that we have planned. Meanwhile, over on the NASA television media channel, we will continue with operational commentary. Again, we're getting ready to start a launch broadcast, a special launch broadcast on the NASA TV main channel,
Fine. Sorry.
but we will maintain operational commentary on NASA TV's media channel.
Yeah, we're sticking with this. We don't need to watch.
Please stand by for that. This is Artemis Launch Control.
Okay. We're gonna. I don't want to do that. I don't want to listen to the cast where people talk to me like I'm a 5-year-old for the next 3 hours.
TV's media
Even though
channel.
I mean, I'm not a 5-year-old, but maybe 12, maybe. Okay. Yeah, here we go. Let's go over here. There we go. "13 in May. I'm 12, and what is this? You're laughing at nuts joke." I'm not. You know what, Micho? The truth of the matter is that I'm not laughing at nuts jokes. It's a preemptive thing because I know someone's going to make that joke. So if I make the joke, chat won't make the joke because chat doesn't do things that are cool that the streamer does, because what the streamer does is not cool. So I can either make those jokes preemptively about it and have people not in chat not make those jokes, because what I do is not cool because I'm the streamer. It's like when your parents want to play Pokemon with you. It's just weird. That's just strange. Oh yeah, I think Chimpokemon is Chimpokerific. I got Shoe. That's my favorite one. You know, or you guys will say what you're saying, or I could not make the joke and just have my chat just devolve into mindless internet dribble. Hello? Hello? Yeah, it's alright, Crash. I swear I did this like 2 days ago, 62-month resale. Well, you got part of it, right? Who's on first? What's on second? I think Chimpokemon is Chimpokerific. I got Shoe. Yeah, that was a vent.
"50 years after we last left footprints on the moon, NASA's Artemis 1 is our first bold step towards getting us back there and pushing us farther than we've ever been before."
Whoa! Ow!
Of landing a man on the moon
And returning him safely to the Earth.
Tranquility Base here. Eagle has landed.
Roger, Tranquility. We copy you on the ground. A bunch of guys turning blue down here. We're breathing again. This is actually pretty good. I like this.
You are looking at the world's most powerful rocket and Orion spacecraft live on Launch Pad 39B. Artemis 1 embodies the hard work of thousands across the world determined to explore for the benefit of all. Welcome, and thank you for joining us live at Kennedy Space Center, where the energy here is palpable as we attempt to make history today. I'm Megan Cruz, and this is NASA astronaut Kayla Barron. Kayla, great to have you here again.
Hey, she just came back from
awesome
space.
To be here tonight.
Well, some of you may know this, but Kayla served as a mission specialist for NASA's SpaceX Crew 3 mission. It launched to the International Space Station in November of last year, and she lived and worked there for about 6 months.
I
Today,
just said that.
I am thrilled to have her here with me to talk about this rocket behind us,
Yes,
illuminating beautifully the night sky here in Florida.
Yeah, it's so awesome to be here tonight. When I first walked up and saw the view from the desk here, I was just blown away by how close it is and what an awesome view it's going to be when we get to launch time.
Yeah, it's a magnificent view, and I know you're especially excited about this because if we launch today, this will be the first launch that you actually see from the ground.
Exactly. I've never been able to come see a launch in person, except for my own, of course, but that's a little bit different perspective.
Very different, yeah.
But to be here for the world's most powerful rocket and the first test flight of Orion and
There's
SLS
the Bunsen
is
burner
just
that
amazing.
I was telling you guys about.
So our 2-hour launch window opens at 1:04 a.m. Eastern Time. So Kayla, tell everyone, why are we returning to the moon?
We are returning to the moon to learn more about it. The moon is a perfect place to learn more about our solar system, how the moon formed, but also how the Earth and the rest of our solar system formed. And we know so little about it. There's a lot to learn by returning there and doing some awesome geology work, but it's also the perfect proving ground for our continuation, exploring further into our solar system and eventually going to Mars.
Right.
We need to test all the operations concepts, all the equipment, habitats, rovers, suits, all of these things. And so it's the perfect place to test all of those things out and learn the things we need to do something that's almost hard to wrap your head around, going all the way to another planet.
Absolutely. Really ambitious goals, and it all starts here with Artemis 1. So Artemis 1 is the first flight test of NASA's brand new Space Launch System, or SLS rocket. It's the world's most powerful rocket and will send an uncrewed Orion spacecraft farther around the moon than any of the Apollo missions before it. Artemis 2 will be the first crewed mission around the moon, and then Artemis 3 will use a brand new human landing system to bring astronauts to the surface of the moon. Future Artemis missions will dock to Gateway, NASA's lunar orbiting space station, before descending to the moon. So Kayla, what must we demonstrate with Artemis 1 before we put astronauts on board for those future crewed missions?
This is our first integrated test flight of the rocket, the Space Launch System rocket, and Orion, the capsule that crew will fly in on Artemis 2. And so it's really important for us to put all of those systems together and actually send them to do a mission, test all those systems in real time in concert together. We do a lot of testing before we get to this moment, before we get to launch day, but it's not integrated, and we're not actually putting the systems under all of the real world stresses they're going to see. So we want to see the rocket perform, we want to see Orion make it around the moon, go super deep into space, and then come home and successfully re-enter. So the heat shield actually has to withstand the fastest and hottest re-entry we've ever seen in human spaceflight. So that's a big thing we want to see. The heat shield perform successfully, and then of course recover the vehicle, test all of that. So it's a lot, but it's the important first step before we put crew on the vehicle. Yeah, lots of eyes on this one for sure. So tanking of the rocket began at 4:30 this afternoon. NASA's Daryl Nail is inside with the launch team and has some information about an issue they're currently working.
Right, Megan, the launch director gave the go for tanking shortly after 3 p.m. this afternoon, but as of right now, there is a red crew as they are named, a specially trained team of individuals out at the pad, making an unplanned change to a replenish valve on the liquid hydrogen side. There are 2 technicians and a safety representative that are right now working inside the mobile launcher. It's in an open air area that has a replenish valve that goes to the liquid hydrogen side of the core stage. Now this happened roughly earlier this evening, probably about an hour ago, when a leak was detected at the core stage liquid hydrogen valve by the launch team here inside firing room 1 at the Launch Control Center. Unfortunately, the team here was unable to remedy the leak remotely, and so it became necessary to send a crew of individuals called the Red Crew out to the launch pad to make a hands-on fix, so to speak, to that valve.
Really
what they're doing is they're torquing down bolts.
Just send it.
That are on the
Horner,
valve.
the last time they did that, we lost 7
by
people. It's
torquing
not.
these
Don't
bolts
do
down,
that with rockets.
They'll get a
I
better
understand
seal
the sentiment,
on that replenish valve,
do that with
and that
rockets.
should remedy the leak.
It's a bad idea.
The leak was detected by the hazardous operations team here inside the launch control when the percentage of hydrogen went above 1%.
Yeah.
Now that's significant for this particular area because it is an open air location. The skid valve that runs the liquid hydrogen.
I'm going to switch this over to 4K.
Into the core stage. And 1%. We had reached replenish. That's significant for this particular area because it is an open air location. The skid valve that runs
it's 4K, but all the
liquid
cameras
hydrogen,
are still in 720p at 60.
Into the
but
core
look at the NASA
stage.
logo. That's a crisp NASA logo.
We had reached replenish when this leak was detected. Over on the liquid hydrogen side, of course, there's 2 tanks on the core stage, liquid oxygen and liquid hydrogen. Both had been
that's different, silly. Don't do that. Don't hit that button.
When this leak was detected. Currently, liquid oxygen is topped off and stable in replenish, but the liquid hydrogen is in stop flow at the moment, which will prevent them from proceeding forward with a launch until that leak is remedied. Again, this Red Crew is inside the area, inside the blast danger area, working inside the mobile launcher, torquing down those nuts that are associated with the replenish valve for the liquid hydrogen side of the core stage.
Don't do it.
Of course, we'll keep you updated on the operation. In the meantime, I'll send it back to Megan.
Thank you for that update, Daryl.
Okay, we're gonna fast forward. Prepare to fast forward. Preparing to fast forward. Fast forwarding, sir. Fast forwarding. Bid rate is 8,000 for partners. Oh, I see you like saying false. What the hell? Hurricane. See you like saying false things. It's capped at 6,000, dude. That wasn't Nicole. That was Hurricane Ian. Nicole went around the Cape like that. Okay, we're caught up.
Leo Martin at the Kennedy Space Center Visitor Complex, and finally Brian Cizik with the U.S. Space Force monitoring weather. With 1 hour, 54 minutes until liftoff. How are we looking, Brian?
Good number.
And you showed we certainly had some interesting weather here in East Central Florida over the last several months, but I'm happy to report we're not looking at any type of satellite imagery like the ones you just showed. Overall, weather is looking quite favorable as we head throughout the countdown and into the launch window. So here's what we're looking at right now, really just one area of concern. That's these upper level clouds that are moving in. So there's a cold front in the Gulf of Mexico right now. That's producing some showers in the Gulf, but those are not expected to get to us by the launch window. But the upper level winds are bringing in some cirrus clouds that are moving in. Now they're high enough and thin enough where they're really not going to be a concern For it to be a thick cloud layers rule violation, they'd have to be a lot thicker and a little bit lower in the atmosphere in order to hold a charge. So that's what we're looking for in these lightning launch commit criteria, not just natural lightning, but rocket triggered lightning potential, as some of these clouds can hold a charge. A rocket can actually induce a lightning strike in an atmosphere that's not strong enough to produce a natural lightning strike. So that's really what we're watching. But right now, weather is go. These clouds, as I said, are high enough and thin enough where they're really not going to be much of a concern. But we are going to be watching it. My colleagues Melody Lovin, Mark Berger, and the rest of the launch weather team will be watching this very closely as we head closer to T0. So let's take a look at the graphic. The latest briefing, 90% go. Really the only concern being the thick cloud layers rule, and a very small concern for the cumulus cloud rule. But overall, the weather is looking favorable. As I said, right now, weather is go. Those clouds are high enough and thin enough where we do not expect them to be a concern. So I'm happy to report a very favorable launch forecast as we head closer to T0. Megan, back to you.
Don't you just love hearing 90%?
Yes,
you know, that's wonderful, especially here in
odds.
Florida. You know what I mean? Weather can really be tricky here in Florida. So 90% is perfect. Now, Florida's Space Coast has been the primary launch site for NASA's crewed missions for the last 6 decades. First Apollo, then Shuttle, the Commercial Crew Program, which Kayla flew as a part of, and soon Artemis. Let's go now to NASA's Jasmine Hopkins.
Thank you so much, Megan. We're here in the Launch Control Center amid all the excitement in Firing Room 2, and I'm so glad right now to be joined by our Kennedy Space Center Director, Janet Petro, and our Deputy Director as well, Kelvin Manning. Thank you both for being here.
Thank you, Jasmine.
Hi, Jasmine.
We are so glad to have you. This team has overcome a lot to get to today. We are no stranger to storms on the Space Coast. We overcame Ian, and then Nicole. Janet, how did we embrace the challenge?
That's my line, Jasmine.
Yeah.
I got to say, I couldn't be more proud of the team out here. Everything we did to get to this point, and then to have those 2 storms thrown at us at the last minute. Nicole, all the evacuations. As you know, one time we remained at the pad, and the other time we had to roll back to the VAB. But I got to tell you, across the workforce, whether it was our program people, across the agency, our institutional support organizations, they all came together and worked as a team. And so here we are tonight, looking forward to a great launch.
Right, we're a very strong team, and we have been at this for years, for decades. We started off during the Apollo program, but now we've evolved into what we're calling a multi-user spaceport. Kelvin, what does that mean?
I like that.
So when we were getting ready to retire the space shuttle, a lot of people thought we were going out of business, literally shutting down. But our leadership team, we had a vision to create what we called a multi-user spaceport to become the world's premier government and commercial spaceport. And so that's happened over the last 10 or so years, probably a lot faster than we thought it would. But right, if you would say, you ask us, well, what's the future look like? I'll tell you, we're just getting started.
Right, the future is very bright for us, and this is a really big day for NASA. I mean, Artemis launch, but an even bigger year for Kennedy Space Center, the Diamond anniversary, our 60th anniversary. Janet, how have we commemorated that big milestone?
Oh, we've had a whole bunch of celebrations all along this year. As you know, Kennedy became a center back in 1962, as you said. We've been celebrating all year long, and I can't think of a better way of culminating our Diamond anniversary with a launch of the Artemis for the Artemis generation later this evening.
Right, that is so exciting. And what does it mean for both of you to be leading the center at one of our busiest cadences we've ever seen? We've had over 40 launches this year alone. What has that been like?
We're gonna get past 50 tonight, I think. But for me, I'm incredibly honored to be leading this team. It really is all about the team and the workforce. We have such a highly skilled, a highly dedicated, a highly motivated workforce. We have an incredible mission, and we all come together and embrace the challenge and make things happen.
Right.
Yeah, it is a privilege to work here, and it's not about us. Like Janet said, it's about the people.
It really is. It's about this great team. Janet, Kelvin, thank you both so much for being here tonight. We really appreciate it.
Thank you, Jasmine. Go Artemis.
Yes, go Artemis.
Go Artemis.
Absolutely. Megan, back to you.
Great to hear from them. So 1 hour and 48 minutes and counting till our 2-hour launch window opens. We heard Dale report out that there is a team at the pad working an issue. So why don't we go back to him now to see if he has an update for us.
Yeah, Megan, now continuing to track the Red Crew's work at the launch pad. This is a specially trained team of 3 individuals, 2 technicians, 1 safety representative who are currently right now inside the mobile launcher at the base of the launch pad. They are doing work on a replenish valve, currently torquing down the bolts in order to remedy a leak in that replenish valve that was detected a little over an hour ago.
Hang on, Jack.
Now this is significant because currently with a leak, they have had to go into what's called stop flow on the liquid hydrogen tank of the core stage. Normally, under replenish, they continue to flow liquid hydrogen into the tank as it boils off in order to maintain a level of around 100%, but that has been in stop flow, and so at this moment we are slowly losing liquid hydrogen in the core stage hydrogen tank.
Yeah.
The Red Crew went in and is currently working a little longer than expected on the issue. It was estimated that it would take 15 minutes to do the work, but as we're now finding out, the Red Crew is torquing down the bolts and then backing out of the area and allowing the launch team to cycle the valves to test to see if they've got that leak fixed. So as they do this, we understand they will cycle this work, go in, cycle the valves, torque them down again if it continues to leak, and then back out and test the work. And this may continue until they have it fixed. The Red Crew going onto the launch pad isn't a totally uncommon occurrence, certainly new with the Artemis program.
I love Daryl's commentary,
work like this was done in previous space programs. The Red Crew is specially trained for this work. They are accustomed to working around in hazardous operation, especially a fully tanked rocket. Again, we are tracking Red Crew's operation out at the pad. It's expected that this will eat into the launch window, which currently we have liftoff at 1:04 a.m. Eastern Time, but the window runs 2 hours to 3:04 a.m. Eastern Time. Again, monitoring the Red Crew's work. We'll have more updates for you a little later on. For now, back to you, Megan.
Thank you, Daryl. Some quick programming notes. For the first time ever, we are broadcasting a launch in 4K. You can watch it on NASA's YouTube channel or check your local provider to see if you have NASA's UHD channel. The audio of our broadcast is also available on the local amateur VHF and UHF radio frequencies you see at the bottom of your screen. So if you're here along the Space Coast and interested in that, make note of those frequencies now. Or you can watch today's launch with live commentary in Spanish. That broadcast starts at midnight on NASA en Español's YouTube page, which we're showing you now at the bottom of your screen. Now, Kayla, why did NASA choose the name Artemis for our return to the moon?
Well, in Greek mythology, Artemis is the twin sister of Apollo. So it's really a connection back to the Apollo era, the amazing things we did as part of the Apollo program. But we wanted to give a nod to the future. You know, it's a new set of missions. We're with new objectives. So it's a connection to the past with an eye towards what we might do as part of the Artemis generation.
Yeah, let's talk about what those future ambitions might be. I mean, landing the first woman and first person of color on the lunar surface. That is a worthwhile ambition.
Oh yeah, absolutely. I think we've come a long way since Apollo in so many ways in the space program, but one of the ways we've evolved is our astronaut corps more closely reflects the nation it represents now. So those crews will be more diverse, and we think those diverse perspectives, not only in our astronaut corps, but our larger team, only make us a stronger one.
Yeah, all right. Well, coming up, we are going to hear from some of the Apollo astronauts and learn more about what we will accomplish for humanity by going back to the moon. We'll meet some of the women shattering glass ceilings to bring Artemis to life, including NASA's first female launch director. We'll also show you the Space Launch System up close and what happens when the cutest group of visitors gets the surprise of a lifetime. Plus, we'll take you around the world to show you how people are marking this historic mission. And Kayla and I will also take your questions live. You can send those our way by using the hashtag Artemis. We already have some questions from some celebrities. I know you're going to love these questions. So you're going to have to keep watching to find out who sent those in. And we also invite you to share your moon-inspired content using the hashtag NASA MoonSnap. Here's a sample of some that's already been sent in. This one's beautiful. The flower in the foreground there.
All right. Hey, guys, where's the media feed? Where's the straight media feed? We gotta, yeah. They're torquing the bolts right now, and these people are talking about flowers.
Beautiful. It's been really cool to see all.
Thanks, Banana Time.
Oh yeah, really creative, and we're going to compile as many as we can.
All right, I'm gonna switch this over to the media feed now. The media feed is back to 720p at 60, but I don't care.
Yeah, we just saw the red team give a thumbs up to the camera as they are doing their work out at the launch pad. Currently, they're torquing down some bolts to the specification required in order to try and stop what has been described as an intermittent hydrogen leak in the area. It went above the 1% threshold, and so that is a violation of the has-gas limit in that area. The team continuing to work. As you look at the rocket on the pad, they were called out to the pad about a half hour ago, and they appeared to be making their way, at least have stepped back from the area of work. The way that the workflow has been going is they torque down the bolts, step back a little bit. The launch team then cycles the valves to check to see if the leak is still there, and then they come back in, and this has happened a couple of times, and start torquing the bolts again.
Yeah,
the rocket was nearly fully tanked. The core stage was in replenish for both hydrogen and oxygen. The upper stage had nearly been finished when the leak was detected, and the countdown, though it is continuing, the rocket, the leak had to be addressed in order for the launch to proceed. The replenish puts the hydrogen back into the tank after it boils off, and so currently we're in a stop flow which no longer allows a replenishment of the hydrogen tank, and that would not allow us to have a launch without those tanks being in total replenish, and also in a vented configuration, which has also been put on hold. I'm sorry, not a vented configuration, but rather an engine bleed has been stopped. And so that would need to continue as well in order to get the engines conditioned for launch. That's the latest here from Firing Room 1 at the Launch Control Center. Megan will send it back to you.
It's got an Orion capsule up there, Anthony. Yep. On what part of the rocket is that leak at? It's not on the rocket, guys. The leak is ground side. Here. It's a ground side leak. Check it out. Daryl, your mic's still queued. Yeah, there we go. Yeah, see? They're working on, these are valves right here, fuel flow valves. They're just working on torquing stuff. Now, you know, I know people are going to say, like, oh, what do you mean? What do you mean? You expected a leak? Dude, this happens. This stuff happens. You're always going to have unknown unknowns. It's the first time you put this rocket on the... See, I told you his mic was still queued.
See if they got movement. So the valve's not moving, the valve's like frozen, or?
I told you it was hot,
so the nuts were loose, like visibly loose. But, okay, all right. Okay, so copy that. Thank you. Thank you.
Well, that's good news. Valve wasn't frozen, just the bolts needed to be torqued.
Are they done?
Are they done? I don't know. Wait, he can't hear me. Visibly loose bolts isn't good. Yeah, I mean, yeah, of course. There we go. He cued the mic off. I don't think we were supposed to hear that. Yeah, that's what hot miking is, when you're not supposed to hear it. It's like that guy in Discord that leaves the mic on and you hear his TV in the background. Well, actually, from what we heard from Daryl there, he said there was visibly loose packing nuts, which is that's okay. That's fine. Just torque them back down. Fueling hydrogen contracts metal and it can detorque bolts. That does happen. And before you say, well, what do you mean the bolts come under? Yeah, that's not a NASA problem, guys. That's a physics problem. That's a physics. What do you mean the airplane stopped flying when the wings fell off? Yeah, that's generally what happens. This is a physics problem, man. What do you mean? What do you mean the wings fell off? What do you mean? It should still fly. No, hydrogen leaks. It happens. Stuff gets detorqued. This stuff does happen.
T-minus 1 hour and 38 minutes and counting. We have an update now.
It'll freeze the Loctite.
Get an update from Launch Complex 39B. The red crew has completed their work at the pad, tightening down some bolts that seal a liquid hydrogen replenish valve on the side of the mobile launcher. I want to correct something that I said earlier, and that is that they are not leak checking it in between torquing the bolts. They are just cycling the valve in between torquing the bolts to make sure that the bolts are secure.
Yeah.
Again, the work that happened was tightening down the bolts on a leaky replenish valve on the liquid hydrogen side that feeds the core stage. And they cycled that repair, cycled the torquing of the bolts as the launch team cycled the valves. The work is complete, and the red team is on their way out of the pad. They're specially trained to work inside the blast danger area. There are 2 technicians and 1 safety representative now headed out of the mobile launcher.
Okay, that's good news. Shutzy, do you think they would automate this? You shouldn't really, in systems engineering, you don't want to automate something that you're not sure
this is Artemis Launch Control.
Not work, dude. That doesn't make any sense.
Discovery, go at throttle up.
6 years, what a day, right? Tier 2, 72 months version. Thank you, man. You guys, that's what I mean. Oh, there they go. Guys, this stuff happens. That's something that you got to understand. Hydrogen leaks happen. It happens. This stuff happens. It untorques bolts. This is just dealing with hydrogen, man. And it looks like they dealt with the problem. And we should be... I mean, if they're leaving and they cycled it, it should be good, dude. Let's see. Yeah, they caught him on camera. Yep. All right, you can see over there on the right, the red team crew, a safety officer, and 2 technicians are leaving the pad. I think it's going to work, Hellfish. Yeah, guys, if you're wondering, everybody, so if you're wondering why, like, oh, why does SLS have all these problems? Look, you guys, they had these problems with Apollo 4 and Apollo 6. Apollo 6 almost broke on the way up. They had these problems. Apollo 11 had a hydrogen leak right before they went to the moon. Straight up. This stuff happens. This is what happens when you try to go shoot for the moon. It's a different level of difficulty, dudes. Wait, you're playing in the big leagues. Low Earth orbit in terms of rocket science is minor league stuff. BLEO is major league. This is the hardcore stuff right now. This gets complicated very, very quickly. You're going to run into unknown unknowns. How you adapt and how you react really shows whether you want a flag up on the surface or not. You know what I mean? It really makes a difference. You really got to be careful with this stuff. You can't screw around. So if the bolts are leaking, send the guys out there, retighten them, and let's try again. But you really have to be deliberate, and you have to be confident in what you're doing. If you're not, you will fail. It's just another data point. That's right. Falcon 9 first stage never has hydrogen leaks. Did have helium leaks that one time. Adrian, you remember that? So did they fix the problem? Well, we got to check, Cody, but you got to be careful. Yeah, Shutzy, but there's these things called valves and stuff, unless you want to weld the whole dang thing together, in which case now you're screwed, because when it goes to contract, it rips itself to pieces. Thermal expansion and contraction is a big deal when you're using liquid hydrogen. Oh, Daryl's... no, he cued his mic on and off. Come on, EJ, it's not rocket science. Yeah, something like that. Yeah, guys, there's a lot of stuff. Like I said, this ain't a NASA problem. This is a physics problem. Apollo had the same problems. The shuttle had the same problems, because when you're going out to the moon, you need the performance of hydrogen, unless you want to do some refueling missions, in which case methane makes sense. And now, don't get me wrong, there are other people that are working on that. Maybe we'll figure that out someday. But right now, it's still the best way to do it. You go with what you know. Drink list for the night. Coffee. It's not brain surgery. ETA on the launch. Launch is scheduled for 1:04 p.m. Eastern Time, about 2 hours from now. This little bolt torquing escapade here might push into the launch window a little bit, but we're still, as of right now, we're 90% go for 1:04 a.m. Eastern Time. I know, I see chat going off out of the corner of my eye. I said p.m. the first time, sorry. 1:04 a.m. Oh, yeah, that's right. Sorry, I misspoke. Shouldn't have been standing there. The launch window is 2 hours. Why do they have to launch in the middle of the night? I know that's the next question. The moon has to be in the right place. That's kind of important. If you're going to the moon, it has to be in the right spot. You go to try to shoot for the moon and miss, you're not getting the capsule back. I'm pretty sure that's a mission failure. Yeah, the moon has to be in the right spot. That's why they're launching in the middle of the night. But why male models? Yeah, everyone knows the moon is only out at night. Duh. Yeah, I know. How stupid of them. Why doesn't NASA just move the moon? It moves by itself. You don't want it to be moving, Waz. Ideally, you want it to stay still, but we can't make the moon stay still. It's just got ants in its pants, you know? It's got the heebie-jeebies in its pants, just moving all the time. It's damn moon. We gotta go catch it. You know what I'm saying? Ah, yeah, Jarl, there you go. What happens if they land on the moon only to sink because the Valvita is too hot? Well, just land on the moon at night. Yeah, TJ, this stuff happens. It gets complicated. Thank you, Kerbal, for your understanding of all this. Yep, it certainly does help visualize it, doesn't it? Let's move the moon to low Earth orbit. I don't think that's a good idea. When it launches, can you swear? You can swear at your computer. How's it possible to retighten the bolts at minus 500 degrees at that temp? Are the bolts and nuts very brittle? Carefully, Valiant. Seriously, careful. That's it. Yes, they absolutely are. That's what I mean. You over torque it, you'll crack the nut. Yeah, you got to be very careful. This is launching at 1 p.m. Vietnam time. So I technically wasn't wrong, Forlorn. Yep. Yeah, Valiant, this is what I mean. You got to be careful. Hydrogen is a pain in the butt, man. We're approaching absolute zero with liquid hydrogen. It's really cold. 500 minus 500 F.
On the operation out at the pad.
Update.
The work is complete and the red crew has departed the BDA. Again,
blast detonation area.
The red crew that was out at the pad, torquing down the bolts to a leaky core stage hydrogen replenish valve.
That's right, Donald.
Has been complete, and the red crew has departed the blast danger area. The team will now start checking the valves, those that hydrogen valve.
Adrian, would you do it? I'd do it. That'd be sweet.
To determine if the leak has been fixed. A discussion will now take place on
Hydrogen
what
is
to do
really
about
low
the
ping.
requirement for a
How about that?
90-minute engine bleed with liquid hydrogen. That was interrupted when the core stage replenish went into stop flow as a result of the hydrogen
let's do
leak.
it, man. You and me, buddy.
Again, a discussion about how to manage the 90-minute bleed will be happening, and we'll give you the latest on that in a moment. For the meantime, we're at L-1 hour and 28 minutes and counting. This is Artemis Launch Control.
Preparing to fast forward. Prepare to fast forward. Fast forwarding, sir. Fast forwarding. Weather is 90% go. Can you shorten the bleed time? No. No, Dak. No. You got to thermally condition the engine for, well, a bunch of different reasons. You don't want to flash freeze the motor. That's really, really bad for it. The other thing is that the bearings on those RS-25s are designed to operate at the temperature, at really low temperatures. They're cryogenic bearings. You have to operate them at low temperature, or else they don't work correctly. If you don't get the engine bleed temperature correct, you could spin a bearing on the engine. Spinning a bearing on a car motor is death for the engine. If you spin a bearing in the turbo pump on one of these, on one of the power heads for the RS-25, you're that's not good. You can't skip engine bleed. Don't do that. That is bad. I'm in danger. Yeah, exactly. When will then be now? Soon. Still think about it when we saw the static fire 0.75 miles away. That would have been bad if it almost sixed. Well, we would have had one heck of a show, Atran. I think that we might be deaf. What are the towers on the sides for? Lightning. Jax. Yeah, lightning. You don't want lightning striking the rocket. That actually is the reason why the surface electric field rule exists. The surface electric field rule is a range operational criteria to basically make sure that the rocket launch does not trigger a lightning strike. Meaning, don't make the rocket the lightning rod. It turns out that when rockets get struck by lightning, it can arc down the plume and ground itself on the pad. And if that happens, that happened once. It was not good. I was on Apollo 12. Apollo 12 got hit by lightning a little ways after liftoff. The lightning arced down the plume of the rocket, down the flames, and hit the launch umbilical tower. And it almost scrambled the Saturn V's brains on the way up. They had to switch to the secondary power systems, the auxiliary power systems on the signal condition electronics. ECOM, try SCE to auxiliary. SCE to aux. What the hell is that? Switching the signal condition electronics basically switched to the secondary power systems that weren't affected by the short. And thus the surface electric field rule was generated. Do not have the rocket launch in a condition where it could artificially trigger a lightning strike. Yeah, surface electric. That's very important. And that's why those lightning towers are there. Because the lightning towers make it so they'll get the lightning before the rocket does. And this is designed to ground out. There are huge resistors at the bottom of the lightning rods. They're gigantic. They're big resistors. It's basically a big surge protector. TLDR, lightning is bad. What's the cargo? This is launching an Orion capsule to a distant retrograde orbit around the moon dark side to bench test Orion and SLS. There's nobody on board, but it's going to be a sweet mission. First time NASA's done a moonshot with a crew-rated craft since 1972. Now keep in mind, this is the test flight. There's nobody aboard. Daryl's still hot micing, by the way. I can hear him. It's an expensive bench. Yeah, the mobile launcher is those are expensive. Launch pads are more expensive.
Yeah, that's right,
than the
Megan.
rocket.
We're inside the firing room number 1
My
here at the
name's
Launch
not
Control
Megan.
Center at the Kennedy Space Center. And currently we have an update on that red crew, which went out to the pad to torque down some bolts on a leaky hydrogen replenish valve for the core stage. And that update is that the red crew has departed the blast danger area. They have completed their work. They got the go at 10 p.m. this evening, 10 p.m. Eastern Time, to go out and conduct work that took roughly an hour from the time they were given the go till the time they left the blast danger area. The technicians, 2 technicians and 1 safety representative, did the work out at the pad on the replenish valve. And now that they are on their way back, the team is now examining the work and whether or not that leak is still there.
For sure.
What we do know is, you may have heard me mention that this put the liquid hydrogen tank into stop flow, and as a result also stopped a required 90-minute engine bleed for the liquid hydrogen side. Teams have come to the conclusion that only a 45-minute bleed is required at this point. They can resume the bleed at the point that they left off.
Okay.
And it'll be enough to meet that requirement.
They think it's good enough
for launch. You're looking now at a graphic where we're tracking the core stage fill rate. We did this earlier this evening. Took about 4 hours and 20 minutes to fill the core stage. You can see on the left that the core stage liquid oxygen is at 100%. That's the same for the upper stage, and both are in stable replenish. As you can look to the right, though, you can see that we're at 97% for liquid hydrogen. The reason for that is because when we went into stop flow, that means that the replenish was no longer refilling the tank, and that liquid hydrogen was boiling off and draining some of the capacity out of that particular tank. So we've lost some liquid hydrogen. The plan is to resume, of course, the filling of liquid hydrogen, which goes into that into the liquid hydrogen tank on the core stage and then vents out on that flare stack that you see to the right, where excess hydrogen is burned off. That's the latest here from Firing Room 1. Megan, we'll send it back to you.
My name's not Megan, Daryl. Okay, so they opted for a 45-minute bleed. The reason, now don't get me wrong, I literally just got through saying that you have to bleed those engines, you have to thermally condition them. Guys, I want to be very clear. Charlie Blackwell Thompson is the launch director for this mission. She's not shooting from the hip, okay? These decisions are based off of the data that you're reading. You have to trust the data, but you also have to verify that the data that you're being fed is correct. If they can verify that the data is correct, and it seems like they are, they're going to go for a 45-minute bleed. The reason why is that the engines are already chilled down. But they started to warm back up when they stopped replenishment on the core stage, okay? They stopped replenishment, so the engines are probably at temperatures that are above a threshold for that requires a minute or hour and 30-minute bleed time. If they're going for the 45-minute bleed time, that means that it'll only take 45 minutes tops maximum to get the engines back to the nominal temperature that they're needed for operation. What's the nominal temperature for them operating? Minus 493. I think it was minus 493 Fahrenheit. So that's almost absolute zero. These engines need to be cooled down so the hydrogen, the liquid hydrogen that goes into them, doesn't evaporate when it goes inside of the motor, right? You don't want your liquid fuel engine to have gas going into it. That's not what's in the name, liquid fuel engine. You don't feed gas into the liquid fuel engine. That's bad for it. That makes it explode. Not in the way that you want. There's 1,000 ways to get the rocket engine to explode, but there's only one way to get it to explode in the way that you want, because that's what rocket engines do. They make an explosion and they shoot it out of a funnel. There's a lot of ways to get it to explode in all directions, but there's only one way to get it to explode and go through the funnel. You want it to go through the funnel. Part of that is conditioning the engine. so you don't flash freeze it. Because if you have evaporated hydrogen going into the liquid fuel engine, the engine could basically dry fire. It's not called a dry fire. You could get cavitation inside of your power heads. You could get cavitation in the combustion chamber. You could get ullage gas ingestion. That could create combustion instability that lowers the chamber pressure, and basically the rocket sputters out and explodes. It could create a hard start scenario, which the rocket sputters out and explodes. You could spin a bearing in the turbo pump, in which case the rocket sputters out and explodes. Yeah, there's a lot of ways that this can go wrong, but there's only one way that it can go right. So you want to make sure that you give that thing the best possible chance of going the right way. And part of that is making sure that those engines are down to the operating temperature. They got to thermally condition them so they don't freeze, they don't shock freeze them. That's really important. The other thing that you got to mention, or the other thing that you got to remember, is that these engines are designed to work at an extremely low temperature. Just like a car, when you start a car engine up, you want to get the engine up to operating temperature. You don't want to start a car when the engine is cold and jam on the gas. You'll break something for the exact same reasons. But in the other direction, engines have to get hot to work. These rocket engines need to get cold because the propellants you're feeding them are really, really freaking cold. That's really important to understand. If you try to start a shuttle engine at ambient temperature, it's not, that's bad. That's like trying to start a car engine with no block heater when it's really freaking cold out, turning the key and putting your foot to the floor. You're going to break something. Something will explode. That's kind of just how physics work. Something will pop. So you got to make sure that it's down to it operates at that low temperature. That's really important to understand. What happens if within the engine the technicians examine and discover that the lid for the salami pre-pump does not meet tolerance? Well, the salami lid is designed to not fit. Yep. I accidentally clicked on NASA's stream and saw them typing in chat, and I thought, holy cow, NASA's in EJ's chat hanging out. Yeah. Nice. Cavitation is bad. Yeah. That's a little basic stuff on propulsion. There's a lot of rocket engines are explosion factories, but you ideally just want the explosion to go in one direction. But I will say it's very easy to make the explosion go in multiple directions. That's not what you want. That's bad. Is cavitation ever good? I'm sure on some planet, cavitation inside of the rocket engine is really good, but your weak link is that this is Earth. Hey, Chappie, what's going on? Speaking out of experience? No. Maybe? Look here, negative Nancy, enough with the ways that could go wrong. Or off to the couch with you. You can't banish me to the couch, that's my job. I'm the couch banisher. I'm the one who sends people to the couch. I'm the one who knocks. Can I get a link to the stream you're using? Of course. Boop. All right, I gotta go take a piss. I'll be right back.
Go and throttle up.
Oh, Hokey gifted a sub to NASA. All right. May I go to the couch? No, the couch is reserved for people that are jerks. I'll be right back. 1 second.
minus 1 hour and 13 minutes. The range has just advised the NASA test director that one of their assets required for launch is down.
What's up?
And so at the moment, the range is no-go due to a lost signal on their radar site. Again, the range has advised the NASA test director that one of their assets required for launch is down. And so as a result, the range is no-go at this moment due to lost signal on their radar site. The range is working on the issue. NASA test director has asked the range to keep them updated. And we'll do the same. This is Artemis Launch Control.
Damn it. No, we didn't scrub. So the range
update on the core stage liquid hydrogen replenish valve. Work is complete.
Please.
Red Crew team is back. And we have resumed flow into the core stage
now that's
LH2
good news.
Tank. Again,
let's go.
We have resumed flow into the core stage LH2 tank. Meanwhile, the team is working to get
that flow.
The upper stage liquid hydrogen configured to resume the fueling operation on that part of the rocket. Stand by for more updates.
Oh boy.
This is Artemis Launch Control.
Crowd shots. Oh boy. I love those. Yes, I come for the crowd shots, Chad, I swear. NASA's probably talking to those people, if I had to guess. They're probably interviewing the crowds, asking people how hyped they are. Are you excited to be here? No, not really. I'm retorquing the bolts on my chair because of hydrogen flow problems. Okay? There we go. She's all fixed now. Good thinking. Yeah. Nice shirt. Thank you, Spoon. Yeah. Yeah, well, it's technically methane flow, yeah. Yeah, see, we really needed to torque that thing down, you know. It's important. Snap-on? No. What did you torque them to? 154 liter Newton pounds per torque. What? Did the chair give consent? I gave it 2 Ugga-Duggas, all right? Exactly 12. No, about 350. About 350. I can't hear you. You're trailing off. And did I catch a 9er in there? What are you, using a walkie-talkie? Nah, it was cordless. I love you guys. It's the best. I love it. I can't hear you. You're trailing off. What did I catch? A 9er in there? You calling from a walkie-talkie? That's way too much. Perfect. Speaking of torque, what can cause the Satsuma to not even have power even though it's wired and has a new charged battery? Wire short can do that. Wire short will make the car not work. Is that kilofeet Newton meter? Yes. Shut up, Richard. What's that coming from Mike? Aerojet Rocketdyne expert up next to tell us about the RS-25 expert. Oh, or RS-25 engines. Very nice. Yeah, of course, Airborne. Jovian, we're looking good. The stage is in replenish mode, and they are basically finishing up fueling here. They got to rebleed the engines. They put them on a... They're going to put the engines on a 45-minute bleed cycle to thermally condition the engines, make sure they're at the right operating temperature. The operating temperature in this case is the temperature of liquid hydrogen, so extremely freaking cold is the plain English way of saying that. The range is having problems with their tracking equipment. The range is... one of the range antennas is not working correctly, so I'm going to assume the range is going to do range things and fix it. They do have plenty of tracking antennas out there. I've seen them. There's a lot, so they might switch to another one. They might try to fix it. Either way, the range is having trouble making a connection to the rocket, but we don't have any update on that just yet. Right now, the range is what's holding this up. No way they would scrub because of a range issue. Oh, they absolutely would scrub because of a range issue, Dina signed, but we don't want that bad juju, man. We don't want that bad juju. Daryl, hit me with those laser beams. Daryl, don't call me Megan. I swear. Sometimes they do that, Yankee. You'd be surprised. Sometimes that does fix things.
Yeah, thanks, Megan. And so we get an update for you now. The red crew, of course, completed its work on torquing down the bolts for that replenish valve on the core stage hydrogen side. And now we are back in replenish for core stage hydrogen, which is good news. The team now looking to work on that upper stage, and we understand for the update to the NASA test director, they just informed the NTD that they can start getting back the flow on the upper stage as well. It went into a stop flow roughly around 10 p.m. Eastern time after a leak was detected. You can see the core stage status there. The liquid oxygen side is in stable replenish, both for the core stage and the upper stage of the rocket. Over on the right side, you can see we've lost some hydrogen since going into a stop flow that allowed some liquid hydrogen to boil off during about an hour or so while a red crew was sent out to the launch pad to make repairs. Now, the hydrogen bleed for the engines was reestablished, and it looks like the team is back on track to recover that after a stop flow halted the bleed. They are required to bleed that liquid hydrogen through the RS-25 engines for 90 minutes, but they're picking up where they left off, and that appears to be on track. In the meantime, we've had an update from the range. And the range has informed the NASA test director that currently at the moment, if we were to launch now, they are no-go due to the loss of signal on a radar site. That's currently being worked right now. Again, the range advising the NASA test director that they are no-go. The range is not clear for launch until they remedy that issue on their radar site. And so we're also tracking that. In the meantime, we started this at 3:23 p.m. Eastern Time. Got the core stage tanked in about 4 hours and 23 minutes, and now looking to get everything back on track to try to make that launch window at 1:04 a.m. Eastern Time, which has a 2-hour window associated with it, all the way to 3 a.m. Eastern Time. That's the latest from the firing room. Megan, back to you.
I don't know. Gosh. Yeah, Grav, that's true. Not having backup radar seems ill-advised. They have a backup radar. They're gonna try. Look, standard troubleshooting. Your antenna goes down. What do? What's the first thing you do? Switch to the backup? No. Try to figure it out, fix the problem, and if not, if that doesn't work, then switch to the backup. There are plenty of range antennas out there, guys. Trust me on this one. I could show them to you on Google Earth if you want to see the exact antennas he's talking about. Thanks, Megan. My name's not Megan. Those range antennas are on the south side of Cape Canaveral Space Force Station, right? There. See, there's a bunch of them over here, but those are the ones we're talking about right there. How do I know? That's the range control center. See the place that's walled off like a prison because they don't want anybody getting in there because this control center has the power to terminate every single rocket flying? Yeah, that's the range. There's your antennas. There's 2 of them. See what I mean? Right now, one of those antennas is pointed this way. It's pointed all the way up here to try and get a telemetry lock on pad 39B with SLS on it. This is where SLS is. Why don't they have 4 or 12? Guys, got to remember, one of the things that kind of is a bottleneck right now is not, putting rockets on the launch pad and launching. The range has to be there for every single launch. The range systems were only designed to launch 5, 6, 7, maybe 8 times a year. There's been 70. Yeah, so they're working on upgrading the systems, but they can only go so fast. You don't screw around with stuff like the range. You don't just upgrade it, because if a rocket does go off course and this upgraded system doesn't work, you're going to have a bad day. Got to be careful. Range does not screw around. Range guys are like the most stone-cold melon farmers I've ever seen. It's like the kind of guys that never smile. They're just like, that was enjoyable. Did you enjoy the rocket launch? Yes. The rocket did good things, and I'm happy. Yeah, don't screw with the range guys. They don't mess around. Those range guys are super serial. They're perpetually angry they didn't blow up a rocket. Indeed. Hey, I'm like that. Yes.
Discovery.
JG, let's go big rocket. Yep. So we got good news. There was a LH2 flow valve down on the bottom of the mobile launcher that did have a little bit of above expected leak rates. They literally sent some guys out there and retorqued the bolts down on that valve, on the flanges on the valve, and now it works. So SLS has gone back into engine bleed and LH2 LOX on core stage and second stage, or core stage and third stage, I should say, topping, which means, yeah, they're gonna get this rocket to 100% fueled, and once they go into LH2 topping on the ICPS and the core stage, we're good, man. We got a full tank of gas. It's dark out, and we're wearing sunglasses. Right now, the problem is with one of the range antennas. The range is not getting a good telemetry lock on the vehicle, which is annoying because SLS is working correctly right now. That kind of sucks, but give them a few minutes to lock it down. Range telemetry lock. Power, not signaled. Very dangerous. Very. We're all fine here now. How are you? It's boring conversation anyway. Not everything is dumb on the official stream. They're showing instruments inside the capsule right now, for example. Por ejemplo? See? Okay. You got that big rocket energy. Hey, Neb, what's going on? Excelsior. That's right. That's right, Epic. Yeah, Chappie, you're going to run into problems. How you deal with those problems separates the people that go to the moon and don't. Let me put it to you like that. How many time units until takeoff? We should be about an hour. Should be about an hour and a half out. That is if the range gets their antenna problems fixed. I know you're kind of busy, but I made you SLS emotes. Oh my God, you did. What emotes did you replace, Bree? Yeah, there you go, Yarrow. Yeah. Not enough range, Hellfish, where this thing is going, I don't think.
Go at throttle up.
No channel points? I do have channel points.
Discovery, go at throttle up.
Why is NASA exploring multiple vehicles to the moon? Is the only thing better than having one rocket that gets you to the moon is having two. What's that nearly? EJ, when you say retorque the bolts, I recall that scene of the Russian cosmonaut in the movie Armageddon where he takes the wrench and smashes some equipment. American components, Russian components, all made in Taiwan. Oh, well, we should just use that then, Hellfish. Why didn't they just use that in the first place? You had 3 slots, so I didn't have to replace anything. Oh, I love you.
T-minus 56 minutes and counting. We have an update now on the range.
Okay, here we go.
Stand by. The range is updating the NASA test director at the moment. Again.
Yeah, danger.
Okay, we're back in core stage topping for liquid hydrogen. Fast fill is complete. Again, back in core stage topping on the liquid hydrogen tank.
Okay, so I guess we don't have an update, huh?
And the update on the range. The range safety officer reporting to the NASA test director that the problem they had with access to the data from their radar site was a bad Ethernet switch. Again, the problem with the radar was actually a bad Ethernet switch, and the range is currently working to change it out and re-verify it.
God damn it.
Range reporting that it should take about 70 minutes to perform that work.
What? To change a switch? Who's your IT guy? Are you kidding me?
This is Artemis Launch Control.
Oh, God. I'm just kidding. It's probably a lot more complicated than just moving a little Netgear switch, am I right? But still, though, why is he calling it Ethernet? I know, Persian. I know. Networking is not that simple. It never is. But also, sorry, I couldn't resist making the joke. What's an Ethernet mean? 70 minutes is still before the launch window opens. Can you see my last? That's a good joke, man. Put the Geek Squad shirt back on and get down there. I'm in. It will take 3 hours to turn it off and turn it back on. Yeah, King, they'll be ready in time. Call Best Buy. Geek Squad is quicker. Damn it. Bottom left. Oh yeah. Oh, look over there. There's your hydrogen ice, your hydrogen flow valves right there. Those are the valves over there on that screen that they retort. Good eye. They have in-house IT guys, yes. Yeah, see those pipes? Those pipes aren't painted white. That's ice. That's ice on the pipes. Look at that. It's just caked in a layer of ice, dude. Yeah, well, yeah, Gwen, yeah, don't get me wrong. Where's Rocket? On the launch pad? Some bonehead in chat made me change my hat with the stupid channel points that I hate. Yeah, see? That's the valve that they had problems with, dudes. See it over there on the left? And dudettes. It's important. I don't know, Aqualux, whatever. Now, you're looking at now. Oh, no. Oh, wait, we got to change the hat twice. Thanks, JuiceBot. Damn it, now I got to change it too much. We got to cycle around, damn it. How many was that? That was 4. Okay. 1, 2, 3, 4. Go Sox. This will get changed very quickly. That one never lasts, man.
Discovery, go at
That one never lasts. That one goes so quick. Nobody likes the Patriots hat. I'm sorry, that makes me laugh. That's really funny. As a Lowly Jacks fan, oh hell no! Jugs. Wait, what? Yep, there's your Bunsen burner over there. Pat's cap is okay? Right on. It's okay, we have your quarterback now. Worked out pretty good, Zen, didn't he? He's pretty cool, right? Yeah, there's a reason why we like that dude. Well, Pepper, you're like, no, get rid of the Patriots cap. Time to play some VAB music over this. Jeez. Yeah, Elf, the range is having a problem with their tracking antenna. Literally networking problems with it. They traced it down to a bad Ethernet switch. I'm not even kidding. That's what they said. 4 had too many. The lesser known chapter, Too Fast, Too Furious. Yes, Dr. J. Yep. Ethernet. Would you wear an Astros hat if I sent you one? No. 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 Hell no. Hell no. Bad Ethernet switch. What did you hear? Ethernet. Yeah. Why did you call it Ethernet? Earthernet. What year is it? Shut. That's pretty much, it's a switch, but yeah. Mm-hmm. Ethernet is actually the technology used in the LANs. Oh, yeah. Thanks for the update. No, I don't want that, T-Man. I don't want that at all. What's the current one? Asteroid Day. B612, baby. Why is there a flame? It's a purge flame that's designed to burn off all the excess hydrogen gas, Lid. I would shake my head at this, but after 30 years in IT, yeah, dude, it happens. It's Murphy's Law. It happens, dude. Oh, geez, Slackster. Glad you're all right. Yeah, guys, I'm just going to go ahead and say C last is not going to work with this many people in the chat, dudes. I'm sorry. Where did you get that one? B612 gave it to me. Yeah, Rev. Ethernet switch, dude. Damn it, Blue. That's not what's going on. Yeah, Poison, it's probably a little more complicated than that, but I can't tell you how. Oopsie. Yeah, right. Ridiculous. We get our stuff right and the range goes down. Hey, what doesn't kill you makes you stronger. Your time for revenge is at hand.
Discovery, go at throttle up.
Hey, Psycho. Thanks, buddy. All right. Fellas, I'm putting a memorandum on hats. I want my worm logo hat. They said they were replacing the switch, Illness. Sorry, Dr. J. Yeah, I'm not. Where's your other worm logo hat? It's in the shop. More a mammogram. Yeah, we'll just call it a mammogram, Jamie. Wait, no, that's something different. Yeah, Adventum, I'm ready, dude. They were solar panels. Do you think this is the most significant launch you have covered? This is up there with DM2, absolutely. Why is there an excess of hydrogen in the first place that makes a purge flame necessary? Archer, that's a good question. The propellants are boiling. They're boiling. You have high pressure inside of the tanks and extremely low temperature. You need an extremely low temperature for hydrogen to exist as a liquid. And because it's at high pressure, low temperature, and it's really freaking cold and, low temperature, it's going to boil. That's just how, if you want hydrogen as a liquid, you're just going to run into that. Because it's boiling, it's going to create hydrogen gas. That's just how it's going to work, man. There's no way to get around it. It's always going to leak a little bit of hydrogen gas because the propellants are always boiling off. Liquid oxygen does the exact same thing. That's why you see this little vape thing going on up there. See that? That happens. That's why. So there's the system is in constant circulation, but it is an open loop circulator because there's really not that good of a way to take that hydrogen gas and recondense it back into hydrogen. That takes a lot of energy to do it, to the point where it really doesn't make a lot of sense. Now, SpaceX has done that with methane. They recondense the methane so they don't need a purge flame. But, yeah, with this particular rocket, they're using a gigantic Bunsen burner. And that thing scavenges all the hydrogen gas, or has gas, as the industry calls it. It's hazardous gases. It scavenges it and it goes to the flame. No, we're not doing that. How far is this camera from the rocket? This is a good ways away. When's the proposed launch of this? Bruce, we're currently targeting a launch in about an hour and 10 minutes, but they might not make that window. It's probably going to be a little bit after that. They're still targeting 104. They haven't announced otherwise. So, how long do you want hat cooldown at? An hour. I'd say around 2 is your guess. Yeah, the range has to take a second to get their stuff straight, and they got to do an engine bleed on the engines. They need to thermally condition the motors and get the motors down to the right spec. She asked me, guys, not you. How big long is the launch window? Launch window is 2 hours long, so we're well within the window. Absolutely. Turn captions on. No, I'm good, thank you. Could you explain how space junk in orbits affects launches? Is there coordination for certain windows to launch? Or is there not enough junk out there to create problems? That's what Radidex, that is literally the reason why Space Force exists. Space Force has space control squadrons, and those
T-minus 42 minutes and
they're
counting.
designed to track the debris. That's the only thing that they do.
Get an update now.
And they do coordinate
the liquid
launches
hydrogen
around
loading operation. The upper stage is now in fast fill.
Good.
Again, the upper stage of the rocket is now in liquid hydrogen fast fill, currently at 58% filled.
Good.
While the core stage liquid hydrogen is in replenish. Again, the core stage liquid hydrogen is in replenish.
It's good news.
On the liquid oxygen side,
I don't know,
both
Joe.
core stage and upper stage are in stable replenish. Update on the range. The range informed the NASA test director that they will need to take a little bit longer to verify the replacement of an Ethernet switch, which cut out data that they were receiving from a radar site. We're looking at about 50 minutes left in work that the range is doing to replace that Ethernet switch.
Ethernet.
This is Artemis Launch Control.
Ping-T radar.nasa. Maybe that'll work. Rip Ethernet. That was fun while it lasted. Ah, yes, mister. I think that's right. That sounds right to me. Yep. So, seriously, guys, the range, who is basically like if we were going to, like, kind of attribute it to planes, air traffic control. That's what the range is in spaceflight. They're space traffic control. They basically are in charge of the corridor in which the rocket ascends in. It is a flight-restricted zone, unrestricted all the way up. Unrestricted ascent for the rocket all the way up. Up into space. The range is having problems with one of their tracking antennas because an Ethernet switch kicked the bucket. I'm not even kidding. Yep. The range right now is literally calling the IT guy to fix the switch. I'm not kidding. That's what happened. I can't make that up. Like, that's what he said. That's what they said. You know? Oh boy, dude, it happens. That's right. Range cannot range. Send help, dude. They're on the line with tech support, man. What was the goal for the Artemis mission? To return humans to the surface of the moon? And what's your best guess for reality? It's to learn how to live and work in deep space, Storm. That's the big reason. So we could prepare for a Mars mission. Some intern is driving down to Best Buy. Yeah, Best Buy might be closed. It's 5 till midnight. Yeah, the Geek Squad late shift. I'm pretty sure they have in-house tech support. Grab Shark. Thank you for the raid. Maybe an overnight shipment of Ethernet switches from HIMS. I would not use for range tracking. I would not use those. Can you imagine if this happened during Apollo? Yeah. How long is the launch window? We got a 2-hour launch window. Right now, there's still go for a launch at 1:04 a.m. Eastern Standard Time. But we're probably going to eat into the launch window a little bit because the range is literally having networking problems. You can't make this up. I'm trying to say it without a straight face. They couldn't get a telemetry lock on the vehicle with their radar because of the networking switch. The switch is broken. So they're swapping it to a good switch now. They literally IT work. Literally. That's what's going on. I'm not even making that up. Like, I can't say it without a straight face. That's what's going on. Get the IT guys. Oh, God, that sucks, Cortex. Daryl's mic is queued. This is funny because switches just don't break.
Yeah, we've had a couple of issues that the launch team has been working, and we have an update on both of those. First of all, is the leak, the liquid hydrogen leak in the replenish valve out at the mobile launcher. We understand from the launch team that leak has not recurred. The work that happened out at the pad is that the red crew and the work that they did out there remedied the leak. That's good news. And now the liquid hydrogen tank on the core stage is back in replenish at this moment. And the upper stage of the rocket, liquid hydrogen side, is in fast fill. You can see from the graphic there that we are back up to 100% over on the liquid hydrogen side on the right hand of the screen. On the left hand of the screen, you can see we have been in stable replenish for liquid oxygen. Now, with regards to the range, they reported that they had an issue to the NASA test director with their radar sight. Later found out that was actually a bad Ethernet switch that was cutting out and not providing them the data.
See?
The range reported that they will swap out that bad switch, and they're currently working on that. They advised at the time, about a half hour ago, that it would take them about 70 minutes.
Right, demo.
Or about 25 minutes into that work. They did just recently update the NASA test director to say that it's going to take them a little bit longer because they're going to need to re-verify this Ethernet equipment once they have it installed. Again, that work is ongoing, but at the moment, if we were launching right now, the range is no-go as a result of that bad Ethernet switch. The Dolly Lou file, which helps steer the Space Launch System through the upper atmosphere, has been uploaded to the rocket, and so we're good to go there in terms of other configurations that are ongoing. But we are continuing to monitor communications of the launch team about holding to the top of the window, currently slated for 1:04 a.m. Eastern Time.
What up, awesome?
But we do have 2 hours, and we have yet to see whether or not the launch team is going to be able to make enough adjustments in order to hit the top of that window. No slip yet, but we're monitoring their work, and we'll give you an update when we have it. Back to you, Megan.
Guys, you'd be surprised how you could have an insanely complicated system like an LH2 feed and fill and drain system, and you just got to torque down some bolts to fix it. But it's an extraordinarily complicated system. You'd be surprised how often that stuff works, but how often something dumb like a switch going down or like a valve not being thrown, you'd be surprised how often that happens. That happens a lot. Dude, it really does. That is stuff that happens. Like, there have been times where like ULA has gone to launch and they're like, oh, we didn't power cycle it. So they literally turn the rocket off and turn it back on again, and it works, and then they send it and it flies. Like, dude, you'd be surprised. That stuff does happen. They're a complex part and they're fundamental parts. Need both. That's right. Dude, this stuff does happen. Why don't they have redundant switches? They probably do. Box. It seems like they have a redundant switch, but it's going to take a second to switch to the redundant switch. Yeah, dude, you'd be surprised how often it's stupid things like this. It's always one tiny little thing. It happens. But we're still on. That's why we have a little bit of a nominal launch window. No, if they had, it's automatic. Okay, sure. I'm just repeating what he said, but I guess what he said is wrong, Fladgate. Yeah, interesting, Celtic. Yeah, I mean, I guess, yeah.
Discovery.
Carly, get the sub to Linus Tech? Oh, word. I mean, that too, Jackal. Guys, I called for help. It's okay. Call Linus.
Discovery, go at throttle up.
They're going to do something very similar to this, Ivan. You go with what you know with spaceflight. That's important. Yeah, Big Bo, I'm with you. Scruffy Wookie, thanks for always being my go-to for launch events. You're the best. I try, Scruffy. Thank you. Thank you for choosing me. I really appreciate it. I think he was just gifted a sub. I don't think Linus is here. This one's not going to land on the moon, Lade. This is a mission that's going to be similar in function to Apollo 8. They're going to send the capsule remotely out to the moon, have it sit out there for a little while, and then it's going to sit out there for a week and then come home. All remote control. The next SLS is going to have people go to the moon, that's Artemis 2. That should be happening in about 16 months. Why does it take so long? Well, you have to review all the data that thing offloads. They want to review this mission, go over every single piece of data with a fine-tooth comb and maybe even an afro pick, and make sure that the rocket performed as expected. It takes a lot of time to review those numbers. 16. Okay, 16. Beginning of 2024 is when Artemis 2 is scheduled to go off. That's 12 months away. Man, when you say it like that, that really sucks. When you say it like that, well, how did we get here? What year is it? They're not in a hold. Devious. It's going to go into a plan hold in a little bit. 16, actually 60. Why is Artemis 2 going to take 60 months? SpaceX could have made this mission with half the budget. You think, Sniper? You really think Starbase is short of being a multi-billion-dollar operation? You really sure? I doubt that. I doubt that very much. There's no new launch time right now, Cody. It's still planned for 104, but it's about an hour from now. But they'll announce a new launch window unless because the range is probably going to take a second here. Be patient. When will they start bringing back moon cheese? At least Artemis 3. Did they make you switch mugs too? No. What's wrong with my mug? My mug is fine. This is a great mug. I'll wait for moon milk. Moon milk? Ugh. What's the current status? Vasia, you really want to know? The vehicle is topped. They're fast filling the second stage right now. Core stage work. They had some leaking on the mobile launcher, and they sent some guys out to the pad and torqued the bolts down right next to the tanked rocket. They fixed a fill and drain valve on the mobile launcher. SLS is working as intended. And then the range lost telemetry lock with one of their antennas. And the range did some troubleshooting and figured out they literally have a bad Ethernet switch. And they are swapping the switch out and verifying that it works. I'm not making that up. the range is what's holding us back right now. SLS is working perfectly. Why isn't there any ice on the core stage? That's what that orange stuff is there for. Funky Flex, the orange stuff is called SOFI or SOFI, spray on foam insulation. It's basically a giant koozie for the rocket. You know, you have a cold snack, and then you put it in that foam koozie that keeps the thing nice and cold. That's literally that. It's the same thing. It's not exactly the same thing. It's the same idea, I should say. That's why they paint the rocket orange, because it's not paint, it's insulation. And the insulation prevents ice from accumulating on it. Now, the original reasons why they did that is because they didn't want ice coming off and hitting the space shuttle when it was on the side. Now, obviously, there's no space shuttle attached to the side of this rocket, right? There's no shuttle attached to the side. But if you insulate your hydrogen, you can actually get more performance out of it, because insulating the hydrogen keeps it in liquid form for a longer period of time. So you get really good performance if you decide to make a shuttle-derived launch vehicle like this and go to the moon, which is why they still have it on there. Cold snack is not my... I didn't come up with that. That's a Vice Grip Garage thing. Calls it a cold snack. We need an SLS koozie. That would be pretty cool. We need the koozie to look like... We need the koozie to have, like, SRBs on the side, though, Pie Guy. I wonder if they end up scrapping the SOFI down the road. I don't know, Demo. Would you... I wouldn't trade the propellant performance, dude. But maybe. Who knows? So many normal fixes for such a complex rocket. Wrench on some bolts, replace the networks. Dude, I'm telling you. This is what's cool, guys. A lot of people are sitting here and be... You know, I made a joke about the... Oh, it's a switch? Oh, my God. Who's your IT guy? You know, oh my God. You got to torque bolts down? No. Guys, you don't understand. NASA is transparent about this stuff. They will tell you what's going on. This is stuff that, you know, for the people that never watched a shuttle launch, the people that never saw an in-house NASA rocket fly. So, like, if you never saw Gemini, Saturn, you know, the space shuttle, this is what NASA does. They tell you what's going on. It's really, really cool. But let me tell you this. The commercial launches, they don't want to show people that they're, you know, they don't want to show people that they're messing up, right? And so they don't really show this. They don't really talk about this stuff as much. The closest thing that we've gotten to this level of transparency is SpaceX with the Starship missions, where they crashed a couple of starships, and we heard from Elon on Twitter what was going wrong with it. But this level of transparency, this is why this is such a treat. Because you really get to see, this is one of my favorite things about covering NASA launches. You get to see how often it's something dumb. This happens way more than you think. Way more than you think. Like, this happens a lot. Stuff like this, torque the bolts down, you'd be surprised. It's always something like that. How's the launch looking? The range, Drummer, the range is currently down right now because they have a bad Ethernet switch going to the tracking antenna. No, I'm not making that up. I know, Sleepy, right? Don't forget the security needed to access the switch in the first place. It's going to take a second, Belt Box. It's not as simple as just unplugging and plugging back in. You know, it's standard IT stuff. You got to test it. That's important. What is that, Jay? Me out American Trust. Texas came out. Boca Chica's in it. At the end of the road is an RV with a security guy questioning a woman, and no joke, a dude who looks suspiciously like Das. I have to link a picture of this. Oh, cool. Yeah, exactly, Epic. That's kind of the reason why. Yep. How much excess fuel is there needed to reach orbit? Is it just enough? There's plenty of extra fuel for operations. No, there's just enough. There's what you need within a nominal amount, Moose. If you're talking about the nominal amount, it's not much. Jimmy tripped over the surge protector. That's what happened with the switch. I believe that. Sometimes that happens. And this is what I mean. You're gonna get unknown unknowns. Do you think anybody had range bad Ethernet switch on their bingo card this morning? Hell no. Not a chance. This is what you deal with. You get curveballs. Deal with it. This is big league spaceflight, baby. Let me know if the link gets eaten. Jay, I can see the link. What the heck? This is an American Truck Simulator? Let me see. That's freaking DOS. That's DOS. I gotta send this to him. Jay, I'm gonna send this to him if you don't mind. Okay, I sent a message to him. We'll see if he replies. He's running the NSF cast right now, so he might not reply. That's very strange. But yeah. Oh, yep. Dude, he responded. No, he replied. He thought it was funny. Dude, Jay, you're right, man. It looks like, dude, it looks like him. It really does. It looks, it's kind of weird, man. Was AFK. Did you just message Linus? No, I messaged DOS. Awesome. Oh, nice, Muck. There you go. Quick question. What happened to Apollo 11? What do you mean? They landed on the moon and then came back. And it was successful. And it was awesome. That's what happened to Apollo 11.
Discovery, go at throttle up.
That's cool, Thomas. Right on. I would... Would it be okay if you explain the payloads on this? There's an Orion capsule and an upper stage called the ICPS. Indiana. Yep. So NASA's gonna use this big rocket to send the Orion capsule out there, and they're gonna park it around the moon in what's called a distant retrograde orbiter, DRO for short, and it's gonna spend a week out there and then come back. They're testing the capsule to make sure that the capsule works, and they're also testing the rocket. If you're gonna test the rocket, might as well put a payload up there and test that too. Lev, gifted 5 subs. Thank you very much. I was AFK. Did you message Elon? No. 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 I don't know Linus. There is also some secondary CubeSats on there that are going to get shot out at the moon. Yeah, absolutely. What meme is this? I was AFK. I was AFK. Did I message you? Is this, what meme is this? I straight up don't understand this meme. Wait a minute. God here, did you message me? Sometimes. What is this meme? God damn it. Stop doing that. New phone, who this? I don't understand. Wait, chat, I was AFK. Did you just message me? What? Chat, isn't it past your bedtime? I was AFK. Did you just message Brady? What?
Discovery, go at throttle up.
Somebody gifted a sub to Jeb Kerman. Please change the subject. I'm so confused. Hold on, I was AFK. Did you change your hat? No. This is why we don't have nice things. I'm back. Sorry, I was AFK. Oh. Oh, okay. All right. Someone redeemed a hat change? Yeah, that was Elwood. I changed the hat. Yes. Nice, Muck. There you go. I'm back. Sorry, I was getting eggnog. I'll be right back. We're still going 2020. I'll be right back. I'll be right back. Chat. I need to. I'm so confused. I need to reset. I've been streaming for too long. I call the Bondulins. I'm having a stronk. Fame's non stronking the Bondulins. Why? Bond names the James. I'm leaving. Okay, I'm really leaving. I'll be right back.
Discovery, go at throttle up.
T-minus 14 minutes and counting. We have an update now on the upper stage of the Space Launch System. Currently at 75% filled. We're in fast fill for the upper stage, and currently it is 75% filled for liquid hydrogen. We're in stable replenish for the core stage, both liquid oxygen and liquid hydrogen. And that includes the liquid oxygen on the upper stage. Stand by, we're getting an update from the range on their issue. I'll be right back.
Hey guys, sorry I was AFK. Did you message me? Did you shave? What? No? I don't know what's going on. I don't know what's happening here. Incoming range updates, by the way. Why is this happening? Why is this happening? Forrest, why is this happening? Why is this happening, Forrest? Because of the flamingos, Pie Guy. Why is this happening? What's that fire there? 404. It's a hydrogen purge flame. Got to get the hydrogen away. And hydrogen gas likes to explode. So they make sure they direct it to a designated burning area so it doesn't explode over there. Yeah. Of course, when the rocket engines go, then you want it to be over there. But right now, you don't. You want it to be over here. Does that make sense? It's just a purge flame. It's basically a giant Bunsen burner. And it uses vacuum like a Bunsen burner to pull the hydrogen gas away from the vehicle. You don't want that. Hydrogen. Hydrogen gas makes that. You don't want that. Yep. Don't want that. Adam, I think so. No problem, Indiana. Got you. Yeah, it's a purge flame, dudes. That's all. You got to get the hydrogen away somehow. Ark, why are you not on your... what, Sneaky? When will then be now? Soon. Is it wrong to say I want to see it go boom? Well, we all do penalty box, but I just want to see it go boom in one direction, not all directions. To be fair. I was AFK. Daryl, what did I miss? Daryl, I was AFK. What did I miss?
Yeah, Megan, we actually have about 10 minutes before we go into a half-hour hold. That half-hour hold is part of the L clock, and what you see on your monitor right now, I believe, is the T clock. So in about 10 minutes, we'll hold for a half hour, and currently the launch team is trying to evaluate how much of a delay may result from some issues that we've been facing over the past hour. Just to recap those, we had a leak in a replenish valve on the mobile launcher that feeds into the liquid hydrogen core stage tank. That's been resolved. The leak has been fixed, and we're moving forward. Currently, the upper stage of the rocket for liquid hydrogen is roughly 78% at the moment. So that is tracking. Progress continues there. The core stage has been topped off.
She's good, man.
And now both liquid oxygen and liquid hydrogen are 100%, along with the upper stage of the liquid hydrogen side of the equation.
That's the good news.
We're just waiting on the complete tanking of the upper stage liquid hydrogen. Now, with regards to the range issue that we had, we just got an update from the range, the 45th Space Wing officer reporting in to the NASA test director that the Ethernet switch has been replaced. This problematic switch took down their ability to see radar from one of their assets, which is key in getting acquisition and signal for the flight termination system if it were to be needed. Of course, this is a critical system that has to be tested before we can launch. So at the moment, we're looking still at a 1:04 a.m. Eastern Time launch. But it is pretty clear from the work that is ahead that it looks like we're going to slip into that window. How much exactly We don't have an accurate calculation from the launch team as of right now.
For the raid. I
but
appreciate
of course,
it.
we're anticipating that. So for the moment, you see on your clock now, we are in the T-minus 10-minute hold.
Yep,
we
holding.
just entered that. And now, roughly, we're looking at 28 minutes to resume terminal count. The launch team will assess what work needs to be done, how that syncs up with the range getting back online with their equipment, and then we should have a new T0 for you soon. That's the latest from Firing Room 1 here at the Kennedy Space Center. Megan, back to you.
My name's not Megan. So literally the Air Force had a bad switch. That's the range tracking equipment, guys. That's the radar that tracks the rocket on the way up. If something goes wrong, they can send the self-destruct. So if the rocket veers off course, they'll hit the self-destruct button. It might be out of order because even in the future, nothing works. No. So, dude, literally bad Ethernet switch. You'd be surprised how often it's something dumb like that, but they won't tell you but NASA has to tell you. So, yeah. Oops. Anyway, I'm really important. Thank you very much for that raid. Guys, if you like Rule 8 stuff, I don't talk about politics here. My Rule 8 is my rule against doing that. We don't talk about it. We only talk about space policy in here. But IRI is a politics streamer. Good buddy of mine. Yeah, I mean, we haven't talked in a little while. Pandemic do be like that, though. But it's good to see it, and thanks for thinking of me with the raid, dude. I really appreciate it. Guys, you're looking at the Artemis 1 rocket here. Artemis 1 is a Space Launch System rocket, or SLS rocket. And that top part with the NASA logo up there with the pointy bit, that part, Ethernet switch willing, is hopefully going to be taking off for the moon in, I don't know, hour and a half, something like that. This will mark the first time NASA has done a moonshot with a human-rated craft, if it goes, since December 1972 on the
Discovery, go at throttle up.
Apollo 17 mission. Joe Simba! Thank you for the 5 subs. Red 8 with a 91-month resub. Thank you, guys. I do appreciate it. So, thank you very much for the Raiders. All right, thanks, man. It's good to see you, dude. It's been way too long. Just take all my bits. All right, I will. Yeah, Forlorn, that's right. They just made it 50. Yeah, just a shade under 5 decades.
Discovery.
Yeah, a lot of people go to college for 7 years. Yeah, I know. They're called doctors. Orcus Monkey, 13-month resub. McDuff with the 8er. Thank you. Yeah, the Ramon went to the clinic today. Yeah, that's right. Is there a larger rocket?
Discovery.
Is this their larger rocket since Saturn V? This has more liftoff thrust than Saturn V, yes. Yeah, Blue, you're flying along, and all of a sudden the range in the back seat says, we don't got to lock on the rocket, Daddy. Not now, damn it. Range safety. I can't stop. Sorry. There's a cliff. Oh my God. Sorry. All because you wanted to save a couple of extra pennies. And all the people that came in from IRI are like, who the frick is this guy? I'm leaving. Bye. That's fair. That's fair. What's the TWR at liftoff? Should be something similar to the shuttle Reagan, so 1.3, 1.4. She's really going to go.
Discovery, go at throttle up.
Lucifer. What's this button do? I really hope that wasn't the self-destruct button. Wait, was that a Tommy Boy reference? Some Drum Bum, it's literally my favorite song. My favorite movie. I was AFK, did I miss it? It's not funny! It's not funny. Dad, welcome to Mission Control. You go at throttle up. Thank you. I didn't catch the delay. They're going to eat into the launch window a little bit, Adam, but we do have a 2-hour launch window. Launch window opens up in about 30 minutes. And then 30 minutes from now, it'll go for 2 hours after that. Guys, the range is going to get their stuff figured out. I have a feeling. They're going to get their stuff figured out, and we will see this thing yeetus up into space, hopefully. There's nobody aboard on this flight, guys. This is the first test flight of this rocket here. This is the first flight. So if you just by chance came in the stream or you're coming from IRI, you're in for a treat, dude. This is the first test flight of that rocket. It's gonna get gnarly. A lot of fire, hopefully coming out of the bottom of the vehicle. There's that thing about rockets. You want the explosion to come out the bottom. You don't want it to come out of all sides. That's bad. Yeah, that's not, unless that was intended. I don't think that's intended with this rocket though. So, I mean, it's gonna light up the sky. It's gonna be great. How long will it be in orbit? Orion will go out to the moon and park in a distant retrograde orbit around the moon for about a week, and then it'll come back. Whole duration of the mission is going to take about 2 weeks, give or take. It is a long-term mission, and it's going to be awesome. We're going to get live 4K views from the capsule. It's really, really good. Yeah, there you go, OG. Yep. She planned to light herself on fire before flight. No, that's what the Rofies are for. Well, they're not Rofies, they're the Sparkers. Just noticed that you're having some manly competition here on Twitch today. Hey, should have freaking collabed with Scott if he's out and about streaming. There's definitely something on board. Anthropomorphic test dummies. Tiny Victory fell asleep. Yeah. Give the little ones a nap, dude. With the delays for 1, any idea when 3 is set for? Could be late 2024, could be into 2025. In fact, I would guess probably into 2025 at this rate, Pi Power. You guys, dude, you got to remember, we're eating into Artemis 2. Artemis 2's launch campaign has already started, guys. Meaning the campaign, like, you know, starting with nothing and going to building a rocket, going to this point. Artemis 1's campaign began well over a year and a half ago, easily, when they started putting the rocket together. So it is going to take some time, you know, but hopefully we get Artemis 2 in about 16 months. That should be about right. And then Artemis 3 should be another 16 after that. Now, why the low frequency of missions? You got to be careful, and you got to kind of, it takes some time. You have to make sure that this test flight is good to go. And then after that, you're going to put people on this. You want to make sure the rocket is as good as it possibly can do. So basically a lot of number crunching. That's why there's a huge gap between the missions. A lot of number crunching. NASA does it. They do this old school. Crunch the numbers, do the math out, improve the analysis on the vehicle, and correlate that to flight data. Basically, you do some math, and then you frick around and you find out, and what you found out hopefully correlates to your original assumption. That's what these test flights are for. They're very important to get right. That's why you see a big gap between them. Just time warp already. No. Where's this launch site? This is Launch Pad 39B at Kennedy Space Center in Florida, Cape Canaveral. It's just east of Titusville, Florida, across the Banana River. The more you frick around, the more you find out. That's right. But in the case of rockets, guys, you're not trying to learn something new. With these test flights, you're not trying to learn anything new. You're trying to corroborate your analysis. That's very important. That's how rocket science testing goes. All right. You think it's going to do this, and hopefully when you frick around and find out, you don't learn anything new. That means the rocket did what you expected, which means it's good. This is how rocket science works. It's not Kerbal. You don't just hit the launch button and go. You do learn a lot from that, but with the way NASA's doing it, you ideally don't want to learn anything from the test flight. But don't get me wrong, they still will learn something, because this is a brand new vehicle launching a brand new capsule going out to the moon. Never used this vehicle before. This is the first flight, so you're going to learn something. Hopefully you don't learn too much, you know what I mean? It's not rocket surgery after all. What's going on right now? Dude, you wouldn't believe me if I told you, Zeldacraft. The range lost telemetry lock on one of their antennas. The telemetry lock on the range radar system is for the flight termination system. They lost telemetry lock because of a bad Ethernet switch. Not making that up. They are swapping the Ethernet switch out right now and verifying that it works. That's what we're waiting for. Meanwhile, the core stage has gone into LH2 LOX replenishment on the core stage, and they're just finishing filling up the upper stage. I'm dead serious. We are all waiting on an Ethernet switch. Yeah, that's not an exaggeration. That's not hyperbole. That is what we are waiting on. E-Love! Welcome to Mission Control. You go at throttle up. Thank you very much. I don't know, Chuba Fett. I have no idea. They didn't say what type of switch it was. Artemis at home. Artemis at home. Yeah, right. It's ridiculous. Ethernet. Yeah, that's right. Yeah, I guess so, caveman. Dude, I can't say it with a straight face, but that is exactly what's going on, man. Oh my goodness. It's just, I'm not making this up. It's kind of cursed, Cab. Yeah, but hey, you know what? To be 100% honest, all this weird stuff that's happening with the rocket is just giving you more data points to prove your analytical model. Seriously. What? Hopefully other launch campaigns go smoother than this, gray screen. What happened to the Ethernet switch? They're swapping it out right now. Hello? When will then be now? Don't do that again. Stop it. Stop it. Dude. Okay. Yes. Crowd shots. Can you just like turn this and just look at the rocket, please? That's not the rocket at all. They're turning towards the rocket. There you go. And she come into frame now. Hey, baby. Let's see you have boosters. Shuttle had boosters too. That gave me a little bit of motion sickness. The focusing in and out and then panic. I'm like, God, why? Zoom in. Zoom. Come on. Clap on, clap off. The clapper. No? All right. Enhance. Hey, all right. Just print the damn thing. Yeah. Does it still go for launch? You know, we're waiting on a new T0 time, Cody, but I still think we're 90% good to go from the weather. So we're literally waiting on that Ethernet switch. Stormy, how are you? I don't know, Tessa. I sent him that picture. He thought it was funny. Dude, it's weird. How did they get a model of him? I don't understand. It literally looks exactly like him. That's bizarre, man. There you go, Story. It's time for you to shine, IT guy. What are you preparing? We're always preparing. Just go. Just go. Sir, you better buckle up. Someone run out there with their personal hotspot. Awesome. Yeah, I don't think we should do that. Hey, Awesome, you want to see something cool? Ready? Ready? You think that's just a picture? Oh, yeah, you like that? You like that? We could go back and forth. That's pretty neat. It's only a model. Shh. Shh. That'd be ridiculous, MGB. It's not a green screen. Shh. Yes, Brand, that's exactly.
T-minus 10 minutes and holding.
Hold on.
Got an update from the range to the NASA test director that their work on the bad Ethernet switch is complete and they are ready for open loop tests. This tests the range ability to send a destruct signal to the rocket in the case it were to go off course and endanger the public.
Don't make sure you have the test.
This is a mandatory test that needs to be completed. Again, the range finishing the work on the replacement of their Ethernet switch that was rendered
sure you have it in
their
test
radar
mode,
acquisition and sending of the flight termination signal to the SLS rocket repaired. And
Make
so
sure it's in
now
debug.
they need to run an open loop test to confirm that they have good signal going into the rocket in case they need to send a flight termination signal. For the upper stage of the rocket, we are, well, let's talk about the whole rocket. Core stage and upper stage. We have
there you
the
go.
core stage in stable replenish,
test.
both hydrogen and oxygen. And in the upper stage, we're stable on the liquid oxygen side. We briefly paused fast fill on the upper stage, which is currently at 80% filled, in order to do a test of the vent valve on that liquid hydrogen tank.
Yeah, right.
Fast fill has resumed, and currently
they did hit revert.
Currently, we are in topping.
They rolled back
on
from
the upper
hurricane.
stage.
They did hit revert to VAB.
A liquid hydrogen.
Already done that.
So that is just in. We are into topping on the upper stage of the liquid hydrogen tank.
Good. Topping. Very good. That means she's
and we are
fully
waiting
fueled.
the range testing their flight termination system with the launch team. This is Artemis Launch Control.
Toppings. The Orion capsule is just the cherry on top. That's what he meant, right?
We are currently in a T-minus 10 hold. This is a pre-planned hold that has 11 minutes left. The pre-planned hold goes for a half hour. The T0 is set for 1:04 a.m. Eastern Time, but currently the launch team is working to catch up to what appears to be a slip into the launch window, which is currently 2 hours and goes until 3:04 a.m. Eastern Time.
We were working on the truck.
Now we'll get a solid T0.
That was like
once
13 hours ago.
Once the launch team is able to determine how much work is left.
Where are you getting your feed? I can roll up the link for you guys.
But again, it's based on the math and where we are, it looks like we are slipping into the window.
What math?
But again, that's not official. We don't have a new T0 as of right now. This is Artemis Launch Control.
I know, man. We're a bunch of cheaters. Dirty alpaca cheaters. The launch is at 1:54. I really don't want that to happen, Gaw. But yeah, Gwen, the red and white truck that you saw is a manual. It's a 5-speed. 5-speed F250. Yeah, pretty cool. The 59 on the other side, the dark red truck that you saw, is an automatic. It's got a C4 automatic in it. We were, like I said, we were working on it at the beginning of the stream. That's how I started the stream today. Putting the new gauge cluster in.
Discovery,
no problem, Leahy. Thank you for your enthusiasm for your coverage. I think this is the most excellent medium to connect and inspire an audience. Well, hopefully I got more big things coming in the pipe, Leahy. Hopefully. You know. Jeb willing. Oh, hello, Gee. Yeah, I know, Mitro. Remember to roll ads before the launch. Yeah, guys, I'm going to do that. If we get within a couple minutes of the launch, I will run an ad for all the people that aren't subbed, so it doesn't play an ad during the damn launch. Is everybody cool with that? So it disables those damn pre-roll ads and just ads in general for a little while. Right up until the launch. But, guys, full disclosure, I freaking hate ads, but what would be worse is an ad running during the dang launch. I can't do anything about that. Yeah, because I don't want someone to pop in this stream when there's like T-minus 10 seconds left at T-minus 10, 9. Hey, buy this razor. No. I'm not having that happen. I'm gonna make sure pre-roll ads and just ads are off during the launch. No. What do you mean no? 5-speed is stick. Do you start in first or second? Awesome. She's got a crawler gear in first. 5-to-1 in first gear. So yeah, you started in second. Catherop, 5-month resub. And then Thurchis. Hey, thanks for that tier 1, buddy. Much appreciated. Yeah, I got you. Yeah. That would just ads drive me up the wall, frankly. Guys, I'm just gonna go ahead and say it. I don't give a frick if it makes me money. It drives me up the wall. As a person that watches a lot of streams and a person that watches a lot of videos, like YouTube videos, like it pisses me off. I hate them. They're distracting and it's really hard just I don't like it. So I'm not doing it to make money, I swear. I am doing it so we don't have to watch freaking ads. But I will, full disclosure, that does make a good bit of change, but that's not why I do it.
Discovery, go at throttle up.
Yeah, Zelter, I hear you. Yeah, I know, Skater. It's ridiculous. No, screw that, geek. Screw that. I'd rather keep my dignity than run ads like that. My 2018 Honda Fit has a 3.4 to 1 ratio. It's a low boy. It's 5 to 1 for first gear in the truck. Any primers in chat? Oh, jeez. I watch all your ads, baby. Oh, damn. You have dignity since when? Well, you try to constantly ruin it. Hey, Leahy, gifted out 5. Thanks. I appreciate it. But yeah, that's what we will do if the launch comes around. You get more Hearst-powers. Play ads for me during the launch all day. Support you forever. Damn. Yeah, Brain Freeze, you got a couple hours. No, well, yeah, you got about an hour. Go take a shower. Just do it quick. Be fast. Everything is terrible. I don't think everything is too terrible, but I do appreciate those 5 subs. So yeah, sell me your product. Sell me your product harder. Yeah, dude, it's ridiculous. I hate it.
Discovery, go at throttle up.
Oh, Wolf Pepper, that's sick, dude. Sweet. That's awesome. You avoid ads. I search them up on YouTube and watch them. Jeez, Ian, do you like headbutting walls? Like brick walls at the same time or something? Roger Tranquility, we copy on the ground. Can I buy that razor or are you just hawking? It was the stealth razor. It's for sale for $5. There you go. Here, I gave it to you. Eagle, I don't know how it's my 32-month thing because I don't sub. Do I just have that many gifted subs that it keeps on going forever? Yes. Yes, that's what's happening. I think. I don't know. What is the ETA on this launch? The original T0 time magnetic was originally in about 15 minutes. One of the tracking antennas, Ethernet switches broke, so they had to replace it. I'm not even making that up. Hey, Shaw, thanks, buddy. Seriously, the range, so they're like the air traffic control for the launch site. They're the ATC, so to speak. They're called the range with rockets. Their Ethernet switch broke and they replaced it. So that's going to eat away into the count a little bit, but we should get a new T0 time here from Daryl, who just queued his mic. I swear, if he calls me Megan, I'm going to be a little annoyed. Daryl, what's going on? Daryl? Okay, I guess he's not talking. I'm serious. Stop calling me Megan. They replaced the switch, Aviator. There hasn't been a new launch time announced just yet. Sounds like Daryl only wants to talk to Megan. All right,
go at throttle up.
Daryl? Who is Megan? That's Megan Cruz. She's the PAO that's hosting the webcast right now. Shut up, Meg. Meg. My big body, we're getting there. Eagle, tier 2 6 months, tier 2 sub 6 months in advance for 32 months. Eagle, I'm beginning to think what you said in your previous sub message wasn't very true. Yeah, of course I would. So how are we doing this fine night, morning, dobry vai? Yeah, I'm doing all right, man.
Discovery, go at throttle up.
Blue Adder, 17 months, and then Team and N. Welcome to Mission Control. Your go at throttle up. Thanks, buddy. Thanks for the Prime sub.
Discovery, go at throttle
up. Max, the range tracking antenna that's designed to track the rocket up and trigger the flight termination system lost telemetry lock about an hour before the T0 time, and the range narrowed it down to a bad Ethernet switch. One of the switches croaked, and they swapped out the switch, and it's working. They're just coordinating a new T0 time. I'm not even making that up. A switch broke. Yeah, Eagle, I hear you. Not gonna lie, man. I don't know what kind of voodoo magic has been going on. It's all right. Yeah, I don't blame you, dude. Just IT things. They literally had a bad switch. Dude. I don't know. There was something, actually, Max, before that.
Go at throttle up.
Boone, Mr. Pingman, gifted a sub to Blackbird. There were some problems with the core stage hydrogen fueling systems, not in the same spots where they had problems in the past. There was a fueling valve that the bolts came undone because when you flow hydrogen through it, through the bolted up valves, the bolts do, the whole pipe contracts and the bolt can actually loosen. That does happen. NASA literally sent some dudes out there to the pad called the Red Team, and they literally just torqued the thing back down and then drove away, and it fixed it. Daryl?
Discovery, go at throttle up.
That's the causeway. There is a lot of people out there. That's a lot of people on the causeway. Damn, dude. Tommy, give this up to Switches.
Discovery,
Mythbusters,
go at throttle up.
58-month resub. Yeah. Packing nuts. They repacked the nuts. I'm not even kidding. That's what they're called. Oh, yeah, Danger? Is it nuts? Did Eagle just gift 44 subs? That's just silly. That's just silly. You know, you absolutely did. Mythbusters had a 58-month sub before that. Thanks, man. Holy crap, you're making it rain, dude. Make it rain. Thanks, man. Dodged. Easy. Yeah, Joe, there's a lot of people out on that bridge, dude. It looks like the range... So, like, it's important for the range guys to keep a route into the pad in case emergency responders have to go. So it looks like they have one lane open, and then the other side of the bridge is just... How far do spectators need to be from the rocket? The closest people, One Eye, are the Red Team. The Red Team are... Daryl said that they're operating out of a place that's 4 miles out, but they're the closest. The Red Team is actually the guys that stay the closest. Them and the range guys, there are range safety officers that are within 2.5 miles. That's the closest. I would not want to be closer to this thing when it goes off. The only time I'd want to be closer to this thing when it goes off is if I was on the top. Crazy Fool! Thanks for the sub, dude. I appreciate it. What did the blue team do? I don't know. They're just over there in the box canyon. Whoop-de-frickin' do. 2.5 miles is close for how loud this thing is. You guys, trust me, if they show a shot like this when it launches, it will look like it's daytime out. These SRBs
Yeah, that's right,
burn
Megan. So
real
we
bright.
are clearly in a
Megan?
delay now. The NASA test director, who's basically flying the ship for the launch countdown tonight, has said that we are extending the hold that we were currently in at T-minus 10 minutes and counting. And so that puts us off the 1:04 a.m. Eastern Time launch. We're now slipping indefinitely into the hold. NASA test director Carlos
right
Monge saying that we are currently estimating
Carlos,
how much work needs to be done before resuming the polling that is supposed to take place 15 minutes before launch. It then goes to terminal count at T-minus 10 minutes. Now we've got an update on the tanking of the upper stage liquid hydrogen tank. Currently 95% filled. We're in topping on that tank. It is the last of 4 tanks in the Space Launch System that needed to be completely fueled up before we launch. Of course, cryogenic tanking, a complex operation that has seen some delays tonight. We had a roughly hour delay after a replenish valve on the core stage liquid hydrogen side required hands-on work by a red crew team that went out to the launch pad and tightened down some bolts on the valve and got it fixed before leaving the launch pad, and then launch team verifying that that work was complete. Now currently we're awaiting some work with the range. The 45th Space Wing, which oversees the range here and makes sure that the airspace and the ocean out over the flight path is clear, and also has the responsibility to destruct the rocket should it go off track. They have been working on some issues with their equipment and sending a flight termination signal to the rocket. There is testing that must happen with the flight termination system that was delayed by a bad Ethernet switch. Switch has been changed out, and now the range is looking to start testing their connectivity to the rocket in order to preserve that safety function that they are responsible for.
That's cool, Bandit.
So again, we are slipping now indefinitely into the launch window. We're awaiting the launch team to evaluate just how much time is required to complete the work to get this rocket ready to launch.
Front page, dude. That's
of course,
cool.
we have a new T0 for you. We'll report that out right away. Megan, back to you.
How long is the window? 2-hour window, Yarg. You can't stay up anymore? Yes, you can. 2020. Look, guys, you know how often I'm like, dude, don't be an idiot. Make sure you wake up for work. Showing up is like 50% of the battle. Being there on time, being punctual. You know, I talk all about that crap. With that being said, you don't want to miss this if it goes. I'm telling you, you don't want to miss this. This is the first Artemis mission. You do not want to miss this. This is very important. So, I gotta work tomorrow. I wouldn't miss this, dude. I would call in sick tomorrow. I'm not even kidding. And, dude, you know how important it has to be for me to say that? I don't believe in that stuff, dude. The only time I skip work is if I literally can't get out of bed. I agree. You don't want to miss this when it goes. Man, this thing is going to go big. It's going to be awesome. Yeah, Alex, yeah, historical event, indeed. Very much so. Sleep is for the weak. You should get sleep. But, Cookie, that sleep is going to go into the time when you should be at work. I mean, it's true. Oh my God! Sorry, just joined. What is the estimated launch time? They're coordinating a new T0 time, Troopa. They had problem with the range tracking antennas, so one of the tracking dishes Because of a bad Ethernet switch. Yeah, they swapped out an Ethernet switch. There was literally a bad switch. They swapped the switch out and it's working, and now they're coordinating a new T0 time. What if I'm my own boss? Do I have to yell at myself for missing work? Yes. Josh! 29 months for a historical event in progress. Fingers crossed. Yep. What is the takeoff mass of that rocket? Like 3,000 tons? Kel, it's up there.
Go at throttle up.
Up there. Ursi, 90-month resub. Hoping for all the bugs to be worked out. SLS is working perfectly, guys. I want to just say that. SLS is working just fine. I know, Faruda. Dude, I couldn't make that. When they said that, I'm like, is this a joke? General, yeah, SLS, she's a little thick down the bottom. That's okay. That's fine. Just more boosters for the pushing. I think that's how that phrase goes. I think. No, Reagan, they really don't. I need a note to miss class then. Okay. Well said. Yeah. I think a famous poet or something said that. Maybe Emily Dickinson or something. Yeah. More booster for the pushing. She didn't say that. Chad, is 80% go for launch? Right. Okay. All right.
Discovery,
She didn't
go at throttle
say
up.
that, silly EJ. So an Ethernet cable stopped the launch. Ethernet switch, Matt. But yes, yeah, that's what's delayed. That's what delayed us right now. But it is working. It is working right now. Now, Launch Director Charlie Blackwell Thompson is coordinating with the other launch controllers to figure out a new T0 time. We do have a 2-minute launch window here. All systems are working on SLS as far as I can tell. Yeah, and I'm going to ignore it, demo. Yeah, I think so, nearly. Yes, I think you're right. Did I say 2 minute? 2-hour launch window. I'm sorry. It's a 2-minute launch window. You gotta go now. No, it's a 2-hour launch window, guys. Sorry. I'm starting to get excited, dude. When I get really excited about things, I start going full misspeak. Brain works too fast for mouth to keep up. Is this the latest launch coverage you've done? No, not even close, Mitro. How do words good better? Ozzy, what's up, man? Excited is an understatement. Yep. Yeah, my fiance activated channel points without asking me, and I'm too dumb to go and figure out how to shut them off, so we're kind of stuck with them. Your brain works? How do I get mine to do that? Coffee. How many all-nighters have you done? Because of rockets entropy? I've lost count. Guys, you understand that I've covered over 70 launches this year. Like, I'm here for majority of these launches. Coffee is the devil's bean. Yeah, whatever. Why don't you like channel points? Because they're distracting and I go on tangents enough. I don't need channel points making it worse, but it's all right. I guess we're stuck with them now. Yeah, I guess, RJ. They're on the front page of Twitch, and there's 24.5 thousand viewers on NASA's Twitch stream, which is fantastic. What was the least enjoyable successful rocket launch this year? I don't know. Maybe one where they expended the Falcon 9 core the other day. There you go, Omega. Anybody got stock for this guy I could short? I'm honored, man, but no. Damn, man. AP, what's up, buddy? Hey, all right. That's a pretty good prediction in favor of SLS. I'm pretty hype about that. Yeah, Jaeger, bingo. Double that, Aqualex, I think. Yeah, nearly. That's pretty cool. What do you think SLS smells like right now? I don't know. You know that smell when you go outside and it's just freshly snowed? That like kind of really cold oxygen-y smell? I would suspect it's like that because SLS is really cold.
Discovery, go at throttle up.
Anders. You could smell snow? That's different. That's different. No. Yes? No? Smells dangerous. Yeah. You smell something, Rabbit? Fear. I realized what I said after I said it, man. I'm like, you know what? All right. I've already sent that out there. Might as well just keep going with it. You know what I'm saying? Might as well just keep going with it. No, don't. That's forbidden. That's the forbidden snow cone. The yellow snow is the forbidden snow cone, man. Arandelario, we are not. They've missed the original launch window. It was supposed to go right now. They had some trouble with one of the tracking antennas because an Ethernet switch that was connected to was broken and they needed to switch the switch. And now they're coordinating a new T0 time. We should be getting an update from Daryl here momentarily. Think these rockets carry ads? Yes. The snow tastes like hydrogen. What? Why are the spacesuits orange? Quinkai, the spacesuits are orange so in case the crew has to bail out into the ocean, they can see them. That's why they make them look like traffic cones. True story. They are derived from the space shuttle suits, and if the space shuttle had a real big problem and had to go down into the ocean, they would be able to see the crew in the water because they're bright orange. That is why they're called pumpkin suits, and that's why. Well, that's not why they're called pumpkin suits. That's the slang term for it. But yeah, it's called an Aces 2 spacesuit. And it's orange for visibility. Is the uptime really 13 plus hours? What did you do? I was working on the truck, Adam. I replaced the gauge cluster in the F-250 today. Faruda, 5 months. Thanks, buddy. Yeah, sure, Voon. Yeah. EJ, if you were offered an opportunity to ride this rocket, would you go? I would not ride this rocket, Mammon. It has no life support systems on board. The next one, though? Yeah, sure. So what does that say about the Boeing suits, then? About 350. Did you have a bad gauge? No, Naroku, it's the PCB on the back. That was the problem, dude. Did you get the cluster to work? The cluster does work, dudes. Yep. Weak is for the sleep. Or something like that. I don't know, Hellfish. Will you buy an electric car? I don't have enough money to even buy another gasoline car, Genesis. What makes Delta 4 light itself on fire? Open cycle hydrolox engines do that, Hokey. Yeah. Remember, Delta 4 has the RS-68. It's open cycle, meaning there's a dump of hydrogen oxygen gas coming out of the bottom of the vehicle at ignition. Shuttle, you don't have that because the shuttle's closed cycle. The shuttle takes the hydrogen and puts it through the nozzle and then puts it back into the power pack. It's fuel-rich stage combustion. RS-68 is an open cycle gas generator, meaning that there's a gas generator using hydrogen and oxygen on each turbo pump, and that dumps out of the little side nozzles. And that is very explosive, and that's what creates a big fireball. What is burning off to the right? It's a hydrogen purge system, Noble 7. Okay, Jensen. Will do. This is a hydrogen sensor. Guys, the reason why Delta 4 Heavy lights itself on fire when it launches is because of the hydrogen gas that's coming out of the gas generators on their rocket engine. What are gas generators? Jet engines. What do the jet engines do on the rocket engine? They spin a fuel pump. That's what they're designed to do. They spin a fuel pump. And those fuel pumps pump the fuel into the rocket motor. Now, on an RS-68, so on Delta 4, you have that fuel pump exhaust is open cycle, meaning it just gets dumped overboard. Falcon 9 does the same thing, but Falcon 9 is using kerosene. Falcon 9 is an open cycle RP1 and liquid oxygen. So Keralox is what that's called. Kerosene liquid oxygen, because RP1 is basically kerosene. It uses an open cycle, and that's why when Falcon 9 comes back down and lands, it's covered in soot, because Falcon 9 rolls coal. Rocket engines run really fuel rich, like
T-minus
like
10
those
minutes
trucks,
of holding.
And it cakes the booster in carbon soot.
I have
now
an
with
update
this,
on a new issue that the launch team was studying, and that's the
hang on,
the possible liberation, as they say, of some RTV, room temperature vulcanization, essentially caulk that is around the Orion, between Orion and panels that come off to reveal the solar panels for the Orion and European service module. The problem is essentially this: the caulk has a sensor in it, and it through camera inspections of the rocket, they have been able to determine that it is loose and could potentially come off. This is the same issue that was brought before a mission management team, which evaluates additional risks to the rocket, just a day ago. This happened after Hurricane Nicole passed through and delaminated some of the caulk around the bottom of Orion that connects to those panels. The team has determined that this caulk that encompasses this sensor on Orion is likely to come off after launch. And so the engineering team went and did a full analysis on what that debris trajectory could be once it comes off, and they evaluated that it falls within the same amount of risk that was evaluated by the mission management team a day ago. And so with no additional risk, that constraint has been removed. The engineers going on further to say that the RTV, as was discussed a day ago, is a loose and pliable material that is unlikely to cause a higher risk due to damage. They say it's likely to hit the LVSA, which is the adapter, the cone-shaped adapter that meets Orion and comes down, and the ICPS, and then comes down to the core stage. It is a rigid structure that would be able to withstand the impact of that RTV. So that constraint was just removed after discussion between engineers and the NASA test director, launch director, and mission management chair Mike Serafin. And so now we continue on. We are slipping into the launch window.
They caught me slipping.
Currently 9 minutes into the launch window, which ends at 3:04 a.m. Eastern Time. The team is currently evaluating the work they have left to do and how much time it will take them to complete it before they can start polling for go. That would normally happen 15 minutes before launch, and we are not ready to resume that polling at this moment.
Cutting it close. They're going to have time for one attempt, I think, guys.
And so we are going into the window. The question is, how deep are we going into the window? A rough calculation of the work, and this is a rough calculation, just for the benefit of those who are watching and those who are here to watch the launch, is no earlier than 1:45 a.m. That again is a rough estimation. This work has to be evaluated, calculated, and a new T0 given, and currently at this moment we don't have that.
SpaceX's rocket
just want to be
ain't
real
even close to launching.
clear
Their
about
moon
that.
rocket is not even close. It's going to take another month to launch that thing. And their SpaceX rocket is way more complicated than this. I don't think they'd be any. I don't think they'd be of any help.
The
to be
issue
honest
with the
with
range and their radar asset that has been fixed. and we are awaiting verification of their testing.
About 30 minutes, guys, until we get
which is part of the flight termination system, a critical safety system that allows the 45th Space Wing to send a destruct signal to the rocket should it go in the wrong direction. That test has not happened, and although the rocket is fully tanked, both core stage and upper stage, there's still some work to do to get it completely configured and ready to go. That's the latest.
Takes
this is
a couple of days
Artemis
to cycle
launch control.
Freaking A, man. Just call it RTV. Why does he keep calling it that? Just call it RTV. Oh my God. Just call it RTV. Why do you keep calling it that? Astro, I'm linking the channel. I'm watching in chat. Jesus. Why you won't stop it? You know what you're doing. So the short and sweet version. They're configuring the rocket to get ready for launch, and it's going to take some time because they had some hydrogen leaks a little bit earlier. But the range kind of screwed them, Drummer, because they had a bad Ethernet switch to one of their telemetry tracking antennas. The telemetry tracking antenna for the flight termination system had a bad switch. And now Daryl was just saying that some of the RTV, the room temperature vulcanization cream, that you could kind of see the stripes of it right there. See these highlighted parts? They put RTV in there to basically seal it when it's down here on the pad. That RTV will end up getting blown out when the vehicle goes up into space because of aerodynamics, and it will go bounce off of the vehicle staging adapter. They kind of saw that some of the RTV is popping out just a little bit. The RTV coming off originally was because of Hurricane Nicole, the excess rain. But they've confirmed that the RTV is going to pop out anyway. One of the sensors is telling them that it's coming out a little bit earlier than expected. It should be, when the rocket's like flying. But they said that it's kind of inconsequential based off of the data. They said, it can do that now. It's not a big deal. It's not going to affect stuff too much. Yeah, it's called RTV, okay? Room temperature vulcanization. Yeah, it's just sealant. I have RTV, and you know what? I'm not finishing that sentence. I know, Kill. We're all nerds. We all nerds would find that funny. I'm not finishing. Yup, I'm not finishing that sentence. Yep. You know what? Another word for it is Permatex. Permatex is the company that makes it. We'll just call it Permatex. It's Permatex. Form a gasket. Yep. No, Alex, stop. Stop it. Stop it. I will hit you over the head with a baguette. Yeah, I know, man. Dude, it's seriously. I'm like, why do you keep saying it? Stop calling it that. No, I did not do this, man. I did not do this. Daryl did this. This is not my fault. I had nothing to do with it, man. Oh, lady, I'm glad you guys get a laugh, man. Whatever you say, Megan. That's not my name. Your reaction encouraged it. No, your reaction encouraged it, man. Shut up, Meg. What's going on with the rocket now? Quack, they are getting the rocket configured for go, no go polling. That is going to take a second. It's going to take a second to get everything configured because, yeah, they were following the timeline and then they hit the pause button. And when you hit the pause button, you don't just hit the resume button on your T0 counter. You kind of just hit a recycling point and make sure that all the systems are up to snuff, because if you pause it, you're going to boil off some fuel. You got to make sure that all the systems on the rocket are configured and ready to go, because they paused it and they took them out of configuration for a second because of the range antenna and the hydrogen leak. So right now, The launch director and the launch controllers are reconfiguring the rocket to get it back to the point where they can do a go-no poll to initiate the final count. Guys, I think if they do decide to go for an attempt, we're going to get one shot tonight. I think. I don't think there's enough time in the window for 2 shots. Do I hear rain? Yeah, we're getting the remains of the hurricane up here. They would have to poll in 10 minutes to launch at 1:45. I did not. No shot. Mitro, you need to find the RTV again. Room temperature vulcanization. How many orbits around Earth until they do TLI? A half of an orbit airborne. This is not going into a parking orbit. It is a MEO insertion, direct. The SLS core stage with the Orion and the ICPS will... Actually, it's not a half orbit. It's 1.5 orbits, excuse me. The ICPS and Orion will get put into a 1,000 nautical mile by 20 nautical mile orbit at main engine cutoff. So at about T plus 8 minutes, that's when we should be getting that after liftoff. If you don't know nautical miles, that's about 1,100 miles by about 21 miles. And if you want kilometers, that's 1,700 kilometer. No, it's actually closer to 1,800. 1,800 kilometers by, I don't know, 35 kilometer insertion. It's going into medium Earth orbit. And then once it gets up there, it will, at T plus 45 minutes, they'll circularize up at 1,000 nautical mile by 1,000. So 1,700 by 1,700 kilometer. And then once it goes around one more time again, that's when they'll do the translunar injection burn, TLI, at 1 hour 30 minutes into the launch, if they do go. Woody, a 5-month resub. Thank you. You missed a sub. I'm sorry. There's a lot of people in here. If I touch the rocket, would you get freezer burn? It would hurt. Yep. I'm just imagining NASA slapping RTV on Artemis like a backyard mechanic who misplaced a head gasket on his 350. Hex, that's literally what they did after the hurricane came through. They sent a guy out there on a wire basket with the crew access arm and a harness, and he literally like rappelled out and resealed it. Yeah, has crew. Oh yeah, that's it. That is quite literally what happened. Guys, like I said, there's nothing inherently on this thing that is really, really complicated. It's a bunch of simple things all being put together into a complicated system. You'd be surprised how often it's an Ethernet switch that fails, or your RTV is popping off, or a spark plug isn't working right. Yes, they have igniters on the SRBs. You'd be surprised how often it's something super simple. It's very easy to not get caught up in the minutia with rockets, I suppose. It's easy to not get caught up. You can overlook small things, and that's what makes this so difficult. I'm not answering that, Eddie. Stop it. Why does it make me laugh? Oh, don't do this to me, man. Shut up. Stop it. Oh, really, Eagle? Oh, my goodness. They have to do the freaking walk of shame. Eddie, don't do this to me, man. I'm supposed to be a professional streamer over here. All right, tweets. Going to bed, shoot me a text if they pull the trick. A text? Huh? What happens if one booster lights and the other one doesn't? That's not happening, Cerebral. You could get thermal curtain failure. Am I right? Professional. Loose nuts, room temperature vulcanization cream. I don't know what's going on anymore. What's the uptime? I don't know what's happening. Harass. That is not the problem that is constricting NASA right now. It's just out of family. And it concluded that the RTV slipping a little bit and popping out of its seam is okay. That is an okay thing to launch. It's just something to take note of. You got the coffee pot in your garage yet? Yeah, dude, of course. Demo, it exists. Oh, I hate it so much. I hate it. I hate that exists. I hate it so much. 1 month later, we're back. How's everything going? Going okay, Tony. The team, the rocket slipped into the launch window a little bit. The first attempt wasn't go because because the range had to replace an Ethernet switch. I'm not even kidding. One of the tracking antennas, the network switch that the tracking antenna was plugged into was broken, and that's what delayed us. Right now, NASA Launch Director Charlie Blackwell Thompson is meeting with the launch control team to get the rocket into a good configuration for a go, no-go poll. I'm not even making that up. An Ethernet switch is what's holding us back, or what held us back a little bit. Where they fixed it, it works. But it's ridiculous. More pain. I hate it so much, Demo. Please don't keep showing me these. I really need to watch Space Camp again. Even launch control reminds me of it. Yeah. Thermal curtain failure. At least they had a backup. Yep. It's orange. Awesome. Jeez. Can we even count the points of failure? What do you mean, Crouton? Oh, dude, this rocket could fail in millions of different ways. NASA's making sure that that doesn't happen. Yeah, Bandit, I didn't hear. That was off the page before I could even click on it. Nice try, though. I didn't even get to finish reading what you said. I assume it was check this link for later. 72% of 361,000 points predicted SLS will launch today. Nice. I watched Space Camp recently. That's a good movie, Syrian, you know?
Discovery, go at throttle.
You still got your old car? What, that one? Or the one behind it? Like Wonka Vision, man. Yes, I do. What happens if NASA hits the kill command? NASA's not in charge of the kill switch. Corn, believe it or not, that's the range. The air traffic control for the launch sites. Wait, gifted 5. Thanks, man. Move the jack next time. Nah, I'm good. I know I'm late to the party, but thoughts on Ross Chastain's wall ride? Hilarious.
Go at throttle up.
Hilarious, dude. Hey. Hey, dude, it worked. I mean, his car was destroyed, but it worked. You got Shinar in there? Nice. All right, right on. Oh, update. Daryl, talk to me, and don't call me Shirley.
Yeah, Megan, thank you. And a clearer picture is starting to emerge as the launch team now reports out that they only have a few minutes left of work to do before they're ready to pick up polling. And we're also hearing that some of that polling, which kicks off with the mission management team, is also now just about 3.5 minutes away.
Surely you can't be serious.
Now, we are currently still in that hold.
Let's go.
But the launch team, NASA's test director, is continuing to move the team forward. We've wrapped up work on the upper stage and the lower stage. You're looking now live inside firing room 1.
Whatever. I don't care.
Where launch director Charlie Blackwell Thompson is overseeing her launch team.
She's running the show right there.
We've had a number of delays that have put us off the T0. But we are starting to track to a T0 close to around a quarter till, top of the hour. But we do need to have some polling that takes place. I'm pausing now because I'm listening in to the teams as they communicate.
Captain Ripoff, thank you for the raid.
In this launch window, which we're
don't get too rowdy
currently
in here, okay?
26 minutes into, and it's 2 hours long. It runs until 3:04 a.m. Eastern Time. We have what's called 40 cutouts. And in those cutouts, they range from about a second to about a minute. These are times where they can't launch. These cutouts must be accounted for when determining a new T0.
That's okay, Gabe.
The upper stage of
there you go,
the rocket,
Sharkmelon, right on.
which was the last to get ready and configured. Just recently, the team cycled the liquid hydrogen valves, which is required. And they are currently working on the LO2 valves, liquid oxygen valves in the upper stage. That work is almost done.
Okay. No, the cutouts are there, I think, because of orbital mechanics, but I could be wrong on that one.
We are now a minute and a half away from the pole of the mission management team, which is several minutes before T-minus 15 minutes.
Time, Duber, is what T stands for.
When that pole starts, we'll get a clearer picture of our T0.
Certain ones do, Dak. This has a very complicated trajectory. Going to the moon is difficult. There are cutouts.
NASA's test director has informed the launch team to all switch to a common communication channel. It's called 232.
They're on the big loop.
And what this means is,
Dak, but I'm not sure. Listen,
that the entire launch team is now on one channel, and all future communication will happen there. Whereas there are many channels. Now they reduce it down to one. Just heard from NASA Test Director Carlos Monge. I'm sorry, Jeff Spaulding. Jeff Spaulding's on. They swapped out. There are currently no constraints to launch. Great news. Again, no constraints to launch.
It's happening.
And they're getting ready to pick up with a poll to determine readiness for launch.
Holy crap, we're here. We're gonna try to shoot for the moon, baby. Text the tweet, boy, please. I don't know what that means.
Go at throttle up.
Joe Simba, thank you very much. It's not going to land on the moon, Dizzle. This one is going to go around the moon like the early Apollo missions did. But this one is going to go with no people on board. We have sophisticated enough systems nowadays where we can go and test that capsule remote control. We don't need to put people on it. That's for the next.
NASA
that's for the next.
Test Director Jeff Spaulding getting ready to conduct the readiness poll. So we are getting close.
Nikes.
We're going to pull up the audio now.
This is better, Trojan.
So that you can listen in.
Go, no-go pull is when they go around the horn to make sure that all systems directors of every individual system on the vehicle is ready to go. Range operations coordinators go.
And Launch Director NTD, our launch team is ready to proceed at this time.
I copy all NTD. At this time, I will proceed with my poll.
That's her talking. That's Charlie talking on the left.
And attention on 232, this is the launch director performing the final poll for launch. Verify no constraints and go for launch. EGS, Program Chief Engineer.
EGS Program Chief Engineer verifies that the EGS, SLS, and Orion Program Chief Engineers have no constraints and are go for launch.
Exploration.
Copy, Greg. Thank you. EGS Chief Safety Officer.
The EGS CSO verifies the SLS Orion and EGS CSOs have no constraints and are go for launch.
Oh, can you believe
Copy,
this?
John. Thank you. Range weather.
There's those valves
Weather
that they
has
were
no
messing with.
constraints, and weather is go for launch.
Okay.
Copy LWO.
The weather guy says
and
it's
mission
good.
manager.
No, Core. We're keeping this. We're staying here.
And mission manager, launch director.
Launch director, mission manager on 232. The mission management team has been pulled. You have a go to proceed with terminal count and launch of Artemis 1.
Oh my goodness. We're here.
I copy
Oh
all.
my
Thank
goodness.
you. And into the
Oh my
launch
goodness.
director.
Go ahead, launch director.
After
Yes,
the go,
sir.
no-go poll, Bree. Do it.
On behalf of all the men and women across our great nation who have worked to bring this hardware together to make this day possible, and for the Artemis generation, this is for you. At this time, I give you a go to resume count and launch Artemis 1.
Copy, launch director, and thank you. All right, we do have a couple of steps to configure, and then we will be ready to resume the clock. CVSE, NTD. CVSE here. Initiate recording of Orion cameras at this time. In work. R, NTD. RSR here. Perform the booster ignition SNA arm rotation enable.
Discovery, go at throttle up.
NDT, RSR, booster ignition SNA arm and rotation enable is complete.
And I copy. Thank you.
Okay, so there you heard the poll from launch
All right,
director.
and all personnel, we are going to resume the clock here momentarily.
Oh my goodness. We're going. Holy crap. At least we're going to try.
Getting ready to get that new
Oh.
T0 time.
Discovery,
Temperature,
go at
liquid
throttle up.
hydrogen going.
The poll that you heard was the NASA test director's poll, and
All right, and we have verified no cutouts at this time.
There are
And all
no
personnel,
cutouts,
we are
no
going to resume the clock.
constraints.
Go at throttle up.
GLS, you can resume the clock on your mark.
GLS copies. Countdown clock will resume on my mark.
GLS is the ground launch
3,
sequencer.
2, 1, mark.
Here we go.
GLS mainline has been initiated.
Okay.
Ground launch
T-minus 10 minutes
sequencer
and counting.
mainline
we are
is
T-minus
online.
10 minutes away from liftoff of Artemis 1.
Run it,
As
Bree.
you can see, the clock is now moving.
Run
Let's
it.
put that up.
Run it, dudes.
T-minus 9 minutes and 47 seconds.
We're going to roll the ads.
The
so
L-minus
no
15
pre-roll ads.
poll
Flight
complete.
show
It went
0647.
I got it.
44 is the new liftoff time.
Affirm.
44 past the hour, guys. There you go, Celtic. Pre-roll ads are disabled for 21 minutes.
0147.44.
We're good.
1:47 a.m. Eastern Time and 44 seconds.
Discovery, go at throttle up.
We
What do
went
I do?
straight into terminal
I don't know what
count.
to do. I don't know what to do. We're going to go. Oh my goodness. Oh my goodness. All right, all right.
Go at throttle up.
Keep it cool. Keep it cool. Keep it cool.
Liftoff now 9 minutes away. So terminal count. Control has been given over to the GLS, the ground launch sequencer,
That's the
a computer and software that is doing
Simba.
all of the commanding
Thanks, man.
and monitoring of the Space Launch System.
The reason why they call it a sequencer, guys, is because a sequence of
We'll hear
events to get the
call-outs
rocket
from
ready to go
the
needs to be
GLS
done
operator,
in a very fast order.
Alex
so
Pandalos.
They leave it to a computer, the GLS. The GLS will begin a handover to the auto sequencer
As well as
or the
NASA
AS
Test Director Jeff Spaulding.
when GLS is finished sequencing events.
GLS is pre-tensioning the umbilicals at this very moment.
Yep.
You can see them as they run down the rocket.
I already did.
That's
Ford.
getting them ready to detach.
Discovery, go at throttle up.
At liftoff, those arms will swing away. We'll let go of the rocket in a clockwise direction.
Discovery, go at throttle
Yeah.
up.
We'll have GLS hand over to the
T-minus
auto
8 minutes and
sequencer,
counting.
and that's when onboard computers have primary control of all critical
The
functions.
GLS is performing up to
Thanks for the
100
subs, dude.
commands per second, including configuring ground systems for power transfer to the rocket.
No, Celtic, it's not bad at all.
GLS is turning on cameras, recording video inside
Ads are already
and
done,
outside the
fellas.
crew module to collect data for engineers.
Thanks Thanks for all the subs, dudes.
Purging the aft skirt booster with high flow nitrogen.
Yep, they're purging.
Clear out any hydrogen gas that may be there.
They're doing a has gas purge of the main propulsion system. That's the engine section, the white section that looks like R2-D2 down at the bottom of the vehicle. The ad should have rolled already, dudes.
You can see the crew access arm is already retracted. When there is crew during Artemis 2,
ground launch sequencer is
it would happen at T-minus 6 minutes. But out of abundance of caution, they went ahead and retracted the arm well ahead of liftoff.
Did you turn off the notifier?
I want to point your attention to the base of the mobile launcher. If something wasn't done to reduce the power from the pressure caused by the rocket's ignition and thunderous sound, it could damage the rocket. So the ignition overpressure and sound suppression system.
All right, we're going to fast forward. He's talking about the sound suppressor. They're going to spray the pad with a crazy amount of water that's up in that water tower here. Okay, we're caught up, dudes.
Sequencer will start bringing the high energy systems online, starting with core stage pressurization.
They're going to spray this pad with a lot of water really quick. It helps quench the sound. Water absorbs sound very well. That's why sonar works really well in submarines. Water carries the sound, it absorbs
Firing Room 1 is completely silent as they listen for the next call.
GLS is go for core stage tank pressurization.
No problem, Diesel. Okay.
The core stage tank is now pressurizing to flight levels. The replenish valve to the liquid hydrogen tank now closing.
We're on the highest for the media stream.
The liquid oxygen tank will come a little later. Now we're arming the Orion ascent pyros and transfer to internal power. The launch abort system, or LAS jettison motor, is now armed. On this flight, the abort motor is inactive because there is no crew on board. Up next is the flight termination system, or FTS, which gives the Space Force the ability to destruct the rocket if it goes in the wrong direction. Let's listen in for that.
Already random iron. 3 rollouts are disabled.
GLS is go for FTS arm.
Ground launch sequence.
The flight termination system is now armed. Yes. Coming up at 4 minutes and 40 seconds, a big moment. This is where the RS-25 engines and their bleed go to high flow. It's been a little tricky to dial in.
GLS is go for LH2 high flow bleed check.
Okay, LH2 high flow bleed. They're going to start flowing a lot more hydrogen into the RS-25s to get them to cool down to the nominal.
Good work. We've passed that. The cryo team got the LH2 engine bleed pressure loop dialed in. They are now at the right temperature for launch. Countdown continues. T-minus 4 minutes, 15 seconds. Up next, GLS fires up the KPUs. Those are high-speed turbines which provide pressure to hydraulic pumps that steer the RS-25s. Stands for Core Stage Auxiliary Power Unit start.
GLS is go for Core Stage APU start.
Oh my goodness.
That now leads to the thrust vector control test at T-minus 2 minutes and 30 seconds. That can proceed now, and we will see the engines gimbal at the bottom of the core stage. At T-minus 3 minutes and 10 seconds, you will hear the go for purge sequence 4. That's a helium purge of the 4 core stage engines downstream of the propellant valve, getting the air and moisture out.
I know that noise. Oh my goodness, it even sounds like a shuttle.
GLS go for purge sequence 4.
And in just a few seconds, GLS will close the core stage LOX vent, liquid oxygen. The white vapor cloud caused from the super cold gaseous oxygen condensing the water in the atmosphere will disappear. You see it coming out there now. And there it goes, it's closed. LOX vent closed, pressure rising in the core stage LOX tank to flight levels.
Core stage is pressing for flight. High flow
coming up
is working.
In 15 seconds, look for that thrust vector control actuator test.
See the wiggle test here. Watch
Engines will
these
gimbal.
Things right here. They'll go over here. then the center, then they'll go back, and then the center, and then they'll go forward and center, and then they'll go back.
And there they go.
There they go.
The 4 core stage RS-25 engines gimbaling around, testing the ability to steer the rocket into space.
Oh, that's cool.
They will operate at 109% performance. Each RS-25 throwing down 500,000 pounds of thrust. All 4, 2 million pounds. Altogether with the boosters, 8.8 million pounds of thrust.
GLS is go for upper stage to internal power.
Now the upper stage has gone to internal power.
Whoa.
So power is removed from the rocket's upper stage, the ICPS, and it's been switched to battery power.
Okay.
The same milestone is coming up for the core stage at T-minus 1 minute and 30 seconds.
All right, I'm shutting notifiers off. Mods, you can let the chat ride. I'm serious, just let it ride. Enjoy the launch.
GLS is go for core stage to internal power.
Core stage is about
the rocket's core stage, which
from the
houses the 3 flight computers, is now on battery power. So there is no more hold time available because there's no more margin on the batteries. So if we have a hold, we'd have to recycle back to T-minus 10 minutes and recharge those batteries. The count continues. A note now, shortly after liftoff.
1 minute.
Shortly after liftoff, Mission Control Houston will take control of the rocket, and my colleague, Leah Cheshire, will take over commentary. T-minus 50 seconds and counting. Coming up at T-minus 33 seconds, the GLS will hand off control to the ALS. This is the autonomous launch sequencer. On board the rocket, it will take over command and control of the rocket.
But
the ALS will check, make sure there's no holds coming from the ground up until T-minus 2 seconds.
GLS, go for ALS.
And we are go for ALS. The Space Launch System is now counting down to liftoff of Orion on its maiden voyage to the moon. Launch team can no longer recycle the count. Sound suppressor water now flowing
15.
under the ML. And here we go.
Trophy ignition.
10.
Hydrogen burn-off igniters initiated. 7, 6, 5. Core stage engines start.
Engines are online.
3, 2, 1. Boosters in.
There she goes. We're going back to the
liftoff
moon.
of Artemis 1. We rise together back to the moon and beyond.
Engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour. Hearing good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis 1. First milestone will be for the vehicle to pass through max Q at about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket.
That noise
SLS
so
now traveling
much.
607 miles per hour.
It's been too long. Fly, baby, fly. Listen to the thunder.
8.8 million pounds of maximum thrust. Quiet here in the loops in Mission Control. The 4 core stage engines are throttling down ahead of passing through max Q. Now 1 minute, 21 seconds into the flight, traveling at 1,420 miles per hour. The 4 core stage engines are back at maximum thrust.
We are out of the throttle bucket for maximum dynamic pressure.
The next major milestone will be for the solid rocket boosters to cut off and jettison at about 2 minutes and 11 seconds into the flight, so about 30 seconds from now.
30 seconds.
Again, quiet here in Mission Control Houston as teams continue monitoring the flight of Artemis 1. We're now 16 miles downrange from the launch pad at Kennedy Space Center, traveling over 2,800 miles per hour.
Stand by for BECO.
Standing by for solid rocket booster jettison, and shortly thereafter.
Right there, you can see the thrust tail off. Standing by for separation. There we go. Looks to be a clean stage right there. Nominal separation.
Confirmation that the solid rocket boosters have separated. These 177-foot boosters Now the core stage continues to power the flight of Orion, all 4 RS-25 engines firing, traveling over 3,400 miles per hour, 46 miles downrange. 2 minutes and 36 seconds into the flight. Hearing nominal calls here in Mission Control Houston. We've still got 4 good engines on the core stage. Next up, we'll be looking for the service module fairing to separate. This is 3 15 by 15 foot fairing panels, providing structural support, protecting the service module. Those will separate at about 3 minutes and 11 seconds into flight, and very shortly thereafter will be followed by the launch abort system separation. Just over 3 minutes into the flight of Artemis 1, now traveling over 4,060 miles per hour, 83 miles downrange. We just had confirmation that the service module fairing has separated. And that the launch abort system pyros have fired, separating those from Orion as well. For future crew members, we just heard the call for 3 engine press, meaning if SLS were to lose an engine at this point in the mission, we could still achieve a nominal mission. We would just have an extended main engine cutoff time. However, we still have 4 good engines, all at maximum thrust right now, powering the first flight of Artemis at 5,200 miles per hour, 148 miles downrange.
I think the stream farted. The Ethernet attack. There was an onboard camera, but we didn't seem to get a good view from it, Red Fox, but everything seems to be going well.
We're 4 minutes and 16 seconds into the flight of Artemis 1. So far, we've had a clean ascent. We saw those solid rocket boosters jettison about 2 minutes and 11 seconds after liftoff. Shortly after, we had the service module panels fairings separate, as well as the launch abort system. The launch abort system was inert for this flight, except to perform this separation. Those 4 core stage engines will continue to fire and power the flight of Artemis 1, now traveling over 6,800 miles per hour, 229 miles downrange. Booster flight controller reports that the engines are looking good.
How long is that thrust plume behind the rocket? 600 feet.
Our core stage main engine cutoff time is about 8 minutes and 3 seconds. We are now at 5 minutes and 11 seconds into the flight, 7,656 miles per hour.
4 RS-25s.
Again, 4 good core stage engines, those 4 RS-25 engines. The last time those core stage engines flew, they were taking space shuttles to orbit, and now with upgraded capabilities, they're launching the future of human spaceflight.
Can you believe it, S?
5 minutes and 42 seconds into the mission. We are now traveling 8,800 miles per hour, 345 miles downrange from the launch pad at Kennedy Space Center. Again, we are anticipating core stage main engine cutoff at about 8 minutes and 3 seconds. And about 10 seconds later, we'll see core stage separation, at which point Orion and the interim cryogenic propulsion stage will be flying free. Now traveling over 10,000 miles per hour, 6 minutes and 15 seconds into the flight of Artemis 1, 427 miles downrange. Quiet here on the loops in Mission Control Houston. Teams continue to monitor this first flight.
They did airborne, yeah. A lot of these engines have flown before. Can you believe how long this burn is? It's power hydrogen, Novus. Everybody gives hydrogen a bad rap. Look at
about a minute and a half now until that core stage main engine cutoff time. Our 4 core stage engines continue to fire at maximum thrust.
Those engines flew on the space shuttles, guys. Oh, yeah. How long will it take to get to the moon? Take a couple of days, Clayton. Translunar injection is in about an hour and 20 minutes.
Coming up on 7 minutes since launch today, now traveling over 12,800 miles per hour, 563 miles downrange. Again, still quiet here in Mission Control Houston. As we prepare for main engine cutoff, the 4 RS-25 engines are beginning to throttle down.
It is. Adventum. It's going to take a little bit of time to get out to the moon. It's a long way away.
30 seconds now until core stage main engine cutoff. All 4 engines continue to throttle down.
Sorry, I was AFK, Brimo. I missed your comment. No.
Now 7 minutes 45 seconds into the flight, traveling
like
over 16,000 miles per hour.
Almost there. For TLI, you're
continuing to hear good calls here in Mission Control Houston. We're standing by for core stage main engine cutoff.
I told Jens that I would text him. Give me 1 second.
And we have confirmation of core stage main engine cutoff. Orion is now in Earth's orbit. The flight dynamics officer reports that we have a nominal main engine cutoff. And we just heard the call for core stage separation. That means Orion and the interim cryogenic propulsion stage are now flying free from the core stage of the Space Launch System. The next milestone will be solar array deploy approximately 18 minutes after liftoff. But before Orion stretches its wings, let's check back in with our friends at Kennedy Space Center and hear all about what it was like to hear the rocket roar off the launch pad. Megan and Kayla, I've got to hear all about it.
We're not going to hear from them. I really wish we got an onboard here. Can you explain the upper stage to you? It's a Hydrolox upper stage with an RL-10B2 attached to the bottom. The interim cryogenic propulsion stage, ICPS for short. It is basically the 3rd stage for SLS, and attached to the front of it, Ponzister, is the Orion capsule with the European service module. Core stage goes to orbit. The insertion orbit for this particular mission is 1,000 nautical miles by 20. Right now, Orion and the ICPS are coasting to apogee here at about 1,000. It's going to take about 45 minutes to get out there. Once they do, they'll initiate the PRM burn for circularization. And that will prepare NASA for the TLI burn, which will be done after circularization, 45 minutes after, T plus 1 hour and 30 minutes into the flight. Once you get TLI burn, that will send Orion, the translunar injection burn will send Orion on a trajectory that intersects with the moon. Why no ion propulsion yet? Because my desk fan has more thrust, Jaeger. Solar array. Go, Prince. Solar away. Solar away. Nice. Solar array open. Yeah, but yeah. Solar SLS can absolutely 1.5 stage to orbit in Orion. Absolutely. Sure. Yes. Kind of a waste, but yes, of course it could. How long do we have to wait for live views of the vehicle? I was told there would be live views now, Sadie, so I'll get back to you on that. Kind of worried about no onboard. It seems very quiet. This seems to be an interpolation of live telemetry here because the vehicle is doing a slight roll, but I don't know. We're staying live for the whole mission, right? I'm going till this timeline gets over here. Nice guy, all. What if they sent Orion to the ISS without a 2nd stage? I don't know why they would do that, S-Master. That seems like a waste of an SLS. Great prick from Trevor. Nice. How fast is it going right now? No problem, General. All good, man. Right now, with an insertion trajectory where it is, it's probably going about 17,000 miles an hour. The circularization burn for the PRM burn and PRM cutoff it'll accelerate the vehicle, but the orbital speed and orbital period up at 1,000 by 1,000 is actually quite low. It's actually slowing down as it coasts up to apogee right now. No problem, Indy. Nightmare, 29-month resub. Thank you very much. This should be largely live telemetry. Yeah, we didn't get a lot of onboards, Rocket Guy, but yeah, it made it to Miko. That's how quick a shuttle launch used to happen, guys. It launched, and then before you knew what was going on, she's up there. I'm sorry, when the booster separated, I haven't seen that in such a long time. It's been a good while. Never thought I'd see it again after the shuttle, to be honest with you. Well, they're hugging each other in launch control, so... Yeah, demo. Mm-hmm. Yeah, that's... that noise, dude. I know that noise. That's the APUs. The shuttle made the same noise back in the day, man. Oh... Yeah, Silent, it did. You can hear her on the stream. I have the other stream open, dude. Yeah, Payne, I'm with you, man. It brought back some feelings, dude. It brought back some feelings. I miss that thing so freaking much. I'm gone, dude. We're not stopping here. We ain't stopping at all. I'm not stopping. Screw that. Basil. Hey, long time no talk. Yeah, I can I'll turn the notifier back on, dudes. We're not getting audio from Charlie. That's Charlie Blackwell Thompson, the launch director for this mission. I'm at an LOS for words.
Discovery, go at throttle up.
And with that, NASA can launch things again. I think that's what hit me the most. Yep. Can we get an instant replay of the launch? Yeah, Midget. I'm feeling pretty good, man. Feeling pretty good. Is your stream muted? No. We'll I'll bring up the audio for from the other stream.
And we have worked hard as a team. You guys have worked hard as a team for this moment. This is your moment.
Hey, Jack.
It is not by chance that you are here today. So I want you to look around at this team and know that you have earned it. You have earned your place in the room. You have earned this moment. You have earned your place in history. You were part of a first.
Cool, A-Tran.
Doesn't come along very often. Once in a career, maybe. But we are all part of something incredibly special, the first launch of Artemis.
You're pretty damn proud of that.
The first step in returning our country to the moon and on to Mars. What you have done today will inspire generations to come. So thank you. Thank you for your resilience. You know, I said at the pre-test briefing, the harder the climb, the better the view. We showed the Space Coast tonight. Right. What a beautiful view it is. So congratulations. So we got a couple of traditions here in launch control.
Nice. Pain.
And the first one is when you're in the position for the first time, you get a tie cutting.
Oh.
And so I have my launch director scissors. And I'm going to get my tie cut by a couple of legends that are here. And then anyone who wants their tie cut will be making the rounds in the firing room. You got your console chiefs. If they want to do it, that's fine. If you want me to do it, you might have to wait a little while, but I'll stay all night if I have to. It'll be my pleasure to cut ties. So I'm going to take care of mine, and then I have one other presentation that I want to make this evening.
No way.
35:45 now.
Discovery, go at throttle up.
No. Don't screw the audio up here. Don't screw the audio up. Oh, no.
Discovery, go at throttle up.
Kill the audio, you dicks.
This is Charlie Blackwell Thompson, Artemis 1 launch director. She just got her tie cut. That is a tradition here at NASA.
Thanks, Megan. And yes, we're here in Mission Control Houston, still monitoring.
What really stuck out to me that she said is that they've really earned their place in history.
That was me.
We're coming up on solar array deploy. Let's go on to Leah.
Eastern time, all the way through. Thanks, Megan. And yes, we're here in Mission Control Houston, still monitoring the Artemis 1 mission and the first flight of Orion atop the Space Launch System. So far, we saw successful liftoff at 1:47 a.m. Eastern time, all the way through separation from the core stage. We now have Orion and the interim cryogenic propulsion stage flying free. And we've just heard that we have initiated solar array deploy. So we are turning our focus to that. The spacecraft was running on battery power, but stretching these wings will allow it to stop relying on those batteries and significantly extend the time it can stay in space.
Thank everyone for
so solar array deploy takes about 12 minutes. We have 4 solar arrays that we need to deploy and latch. These will provide power to the spacecraft on its journey to distant retrograde orbit and all the way back to Earth. Once these are properly configured, again, Orion will no longer need to rely solely on battery power. And we expect this to be done about 30 minutes after liftoff. Right now, we're 19 minutes since liftoff today. Orion is now traveling 17,175 miles per hour.
Special Dukas.
We're continuing to hear good calls here in Mission Control Houston from the flight controllers monitoring the mission. A little bit about these solar arrays as we wait. Again, we heard the call that the deploy has been initiated. We'll hear a little bit more about that once they start to unfold. These 4 solar arrays generate 11 kilowatts of power, which is enough electricity to power 2 3-bedroom houses, and they have a wingspan of 63 feet. Just one of these 6.5 by 6.5 foot panels has 1,250 solar cells. So you're looking at a total of 15,000 solar cells. Now, we just heard the call that all 4 solar arrays have been released. So we initially heard the call.
That was on board, man.
Now those
solar panel cam
are released. Again, this is about a 12-minute process. The solar arrays will deploy straight, and you're getting a live view right now. This is really exciting. They'll eventually be swept back against the vehicle prior to translunar injection burn to prevent any loads from breaking or damaging the arrays. And on the end of each solar array is a camera that will capture imagery for us throughout the mission, along with a few other cameras placed outside and inside the spacecraft to help us monitor and perform various other inspections.
Oh my goodness.
Of course, if you recall the Apollo capsule design, there were no solar arrays.
Yo, let's go! Let's go!
Gives us the opportunity to stay in orbit longer, since we practically have no limit to the energy available for use from the sun.
Stop cutting the camera, damn it! Dude, there's a look at the third stage.
21 minutes since liftoff.
Oh my goodness!
Orion is attached to the interim cryogenic propulsion stage. You can see those 4 solar arrays.
The DSN is tracking Orion.
And again, Artemis 1 is a flight test. It's paving the way for a sustainable presence at the moon.
Holy crap!
Looking forward to the future. Gateway will be our space station in lunar orbit. And we have some similarities and differences in the solar arrays unfolding right now on Orion and those that'll be on Gateway. So like we're seeing now, these are deploying autonomously. The Gateway solar arrays will as well.
And so that's the adapter to the liquid oxygen stage. You should be able to see the rocket engine over there.
Solar arrays, or ROSAs, on Gateway will generate 60 kilowatts of power. That ROSA design is currently being tested aboard the space station. We have 2 new ones installed and a spacewalk conducted earlier today, preparing for another set.
Oh, that is awesome. Look at that. Look at those solar panels. That's freaking cool,
Coming up on 22 minutes since liftoff today, Orion and the interim cryogenic propulsion stage traveling over 16,800 miles per hour.
Yep, she's 16,800.
The solar arrays deploying now are part of the European Service Module. It's comprised of 20,000 parts and components. The service module was developed as part of an agreement between NASA and the European Space Agency, or ESA. This is the first time NASA is using a European-built system as a critical element to power an American spacecraft.
Get good simulation rates, Brent, don't you think? Where's it flying over right now? The Atlantic Ocean. Yeah, about the Atlantic Ocean. It's approaching Africa right now. I know, New Century. Isn't that crazy, dudes? Look at oh my. Even a shot like this. These are shots you see with Starlink missions all the time, guys. Hits home a little different, doesn't it? It hits home a little different. Only 3 out of 4 deployed. Uh-oh. Okay, hold on. Alright, let me take a look. So, there's a shot of mission control here. Yep. Telemetry definitely indicates that graphic looks like they only have 3 out of 4. What is venting? I'm not sure. Yep. This actually looks a lot like, you know what? I'm not saying that right now. It's got a nav ball. Yeah, she's got a nav ball. There's a shot of, that's the upper stage hydrogen tank with the American flag on it. We got a shot here inside of Mission Control. That's in Houston.
Coming up now in 24 minutes into the flight of Artemis 1. Spacecraft now traveling at 16,500 miles
they got
per
4
hour
panels out
around the Earth. We are in solar array deploy, and we have confirmation all 4 arrays are deployed.
Okay. So you got a shot of Mission Control on the left, or on the right, and then on the left you have an onboard view of Orion. The signal is a little bit splotchy right now, but
coming up in a little less than 30 minutes is the perigee raise maneuver.
PRM. That right there is their attitude control system. Right there. See that thing firing up there? It's the ACS. It's RCS on the second stage. That's all. Iceman, thanks for the raid, buddy. Please explain the tie cutting. Throfty, it's a tradition. Tradition in launch control to cut the tie on a test flight. It dates back to the Apollo program, if I'm remembering correctly. They need Starlink. Zoot, they're above Starlink. They're way above Starlink. This thing flew above Starlink before the SLS core stage was shut off. This thing, it's a very different trajectory needed to get to the moon with this type of upper stage. They are way above Starlink. Probably double the height of Starlink right now. And they're going to, maybe not double the height. They're a little ways over it. Starlinks are in about a 400 kilometer orbit, 400 kilometer circular. This thing is trying to get to 1,700 kilometer circular. They're way above Starlinks right now, dude.
And with our
Just
launch
past
at
620 miles.
1:41 Eastern Time this morning, we are looking for a perigee raise maneuver about 53 minutes into today's flight. Again, we are now 25 minutes and 47 seconds into the flight, and we have a complete deployment of all 4 solar arrays. Orion's journey to the moon continues as planned. Again, looking forward to that perigee raise maneuver. That'll be coming up again at about 53 minutes into the mission, so about 27 minutes from now.
Thank you.
During the perigee raise maneuver, the interim cryogenic propulsion stage will use its RL-10 engine to lift the lowest point of Orion in Earth's orbit. The current orbit is more of an oval shape than a perfect circle, and this burn will raise that point closest to Earth and make the orbit more circular. This will also include a checkout of Orion's systems and any adjustments to the solar arrays. It'll be a short burn, less than 30 seconds long, but critical to keep us on track, and it also prepares us for the next engine burn to send Orion to the moon. That's the translunar injection burn. That'll come up a little later, which is a longer burn, another firing of the RL-10 engine on the interim cryogenic propulsion stage.
Get a good look, but I thought they were launch directors from other missions. If I'm remembering right, I forget their names, Crash, but they cut the audio, so I wasn't sure. Does this use TDRS? It could use, yeah, they're using TDRS, but they are...
We caught a glimpse there of those solar arrays,
and
with
they're
all
locked
4
onto it
solar
with the
arrays
DSN.
properly deployed,
NASA's
Orion's
using
journey
their
to
big
the moon
70-meter
continues,
antennas to
and we've
track
got
this
more
thing.
operational
When
updates
is
coming up
TLI?
shortly, but for now, I'm going to toss it back to Megan and Kayla at Kennedy.
About an hour and 15 minutes,
Leah,
guys.
thank you so much. Our return to the moon will be different than the last time. We plan to explore more of the lunar surface and learn how to live and work there. With more on our destination, let's bring back NASA's Dan Hewitt with our new moon board.
Hey, thanks, Megan. I got to be honest, we ran outside to catch it. I'm still shaking a little bit. That never gets old. That is always one of the coolest things you'll ever see in your entire life. And that rocket was massive and loud and just so cool. All right.
Dan can't even speak straight.
This is why we call it the moon board. But the moon, you know, since the dawn of time, humans have looked at the sky and shouted at our neighbor, "I'm going to walk in your face." And in the 60s, we actually did it. 6 times, starting with Neil Armstrong, Buzz Aldrin, Apollo 11, 1969, followed by 5 more successive landings, each time delivering 2 human beings to the surface of the moon.
14.
Our last one was Apollo 17,
15,
and that was in 1972, 16. Gene Cernan and Harrison Smith stepping off for the last time. Now, we have not sent humans back since then, but they accomplished a lot under Apollo. Lots of technological advancements, deployed science instruments.
It's Alex. Thanks for the raid, man. How was RimWorld?
Regolith teaching us about the moon and also about our place in the solar
RimWorld. He was playing
the moon
RimWorld
is
today.
Fascinating because it doesn't have a lot of the geological processes we have.
I did not tell them what raid message to write.
Erosion,
you know what, dude? I believe you. My chat just does the opposite of what I want,
plate
man.
tectonics that are constantly recycling the crust, and so everything out there is really old.
I believe
you. One of the rocks brought back on Apollo 15
How was RimWorld, man?
Thank
you very much for the raid,
is dated
guys.
to be 4 billion years
You guys want a good old school variety
primordial
streamer? That tells your guy.
Of our solar system. But as Kayla said a little bit earlier, those missions were measured in days, their spacewalks in just hours.
I don't think it's
with Artemis. We're looking to go and we're looking to stay.
We got to stick together.
And we're not looking around the equator like under Apollo. We're looking at the lunar south pole.
When I'm
now,
Eastern time.
Why? So we haven't sent people since the 70s to the moon, but we haven't stopped studying it. We've had orbiters like the Lunar Reconnaissance Orbiter, which has literally just been flying loops around the moon, taking high-resolution images of the surface. So high-resolution that you can look them up. They have images of all the different Apollo landing sites, and you can actually see the footprints, the paths they left in the lunar regolith of those sites. We had a mission called L-Cross, which slammed a probe into a crater on the moon, sending out material, some of which potentially hadn't seen direct sunlight for billions of years, and then analyzing what shot out.
See that launch,
and through missions like that and others, we've been able to find that there is water ice trapped in those permanently shadowed areas on the moon, and a lot of them center around that South Pole. We have already identified 13 potential landing sites for the Artemis 3 mission.
Explosion, huh,
and these are where we're going to send our astronauts around the lunar South Pole to access that water ice. Now, why water? Why are we caring about water? Well, it serves a lot of purposes. Obviously, for humans, you need that to breathe. You can split water apart, get oxygen for breathing gas for an atmosphere. If you have a lunar base, you can split it into oxygen and hydrogen. That's rocket fuel. We just launched the most powerful rocket in history using those constituent parts.
I'm pretty sure, but I could be wrong.
And so you can start to live off the land. We can use that something called in situ resource utilization.
1 hour and 30 minutes after
and really, the whole point of that is to use the moon as this proving ground. We're trying to get to Mars. We're trying to learn to live on other planets where there is gravity, where we're going to have to use resources there on the ground because we won't be able to bring everything with us. And by going to the lunar South Pole, by going to stay under Artemis, we're going to be able to start practicing that. We're going to perfect those systems, perfect those techniques and operations we need to do that so we can use the moon as that jumping off point to Mars and beyond. So that's why the moon. We're going to see Orion fly around it for the very first time in just a couple of days. That launch was spectacular. I'm still way too excited, but can't wait to see some shots of the moon from up close from Orion. So I'll send it back over to you, Megan.
All right, guys. We will get a replay here. You guys are saying check out NSF, so we'll go see what our buddies over at NASA Spaceflight have in store. Rhubarb, thank you for the raid. And anyway, Etal, thanks for the raid, dude. You guys, old school variety streamer. Alex is really, really good, really funny guy, and just overall, just a good dude. His chat's kind of weird, though. Yeah, that's right, I said it. Hey, I gotta stick up for my boy, man. He just raided me, I have to. Anyway, I'll see if we can get a replay here in a moment. My fiance is part of that chat, Flash. So that's why. Just, I have to. Kind of, I have to. I'm obligated, you know what I'm saying? Very stinky. Variety's being generous these days, but thanks. I mean, okay. So, what is it? That's Vicky 3, RimWorld, and what's the Marvel game? Dude, I watch a lot of your stream vicariously, man. He's addicted, okay? Whoa! All right. Hey, let's see if we can get a launch here. Let's see if we can get a replay of the launch. I can't believe this. I can't believe this thing went. It's ridiculous. Red Team is on the NASA broadcast. Oh, that's cool. Oh, that doesn't suck. Oh my goodness.
5 engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour.
Whoa!
Hearing good control on the roll from teams in Mission Control Houston. All good calls so far. We're now 30 seconds into the flight of Artemis 1. First milestone will be for the vehicle to pass through max Q in about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket.
That's nice.
SLS now traveling 607 miles per hour.
That was a replay from about a half hour ago, guys. Oh my goodness.
You're looking at 8.8 million pounds of maximum thrust. Quiet here.
What a beast!
In the loops in Mission Control.
Freaking monster! I love it.
4 core stage engines are throttling down ahead of passing through max Q.
Dude, look at that thing. 8.8 million pounds of thrust. That is nuts, dude. That is nuts. Hang on, we got the Red Team over on NASA TV. Give me a moment. These are the guys that went out and fixed the rocket.
All the other companies did a great job, and we're glad to be part of it.
One thing I always like to say is spaceflight is a team sport, and I think you guys perfectly demonstrated that today.
Those are the dudes
right?
that went out on the
None
pad.
of us
That's
could accomplish
cool,
this
man.
on their own. It takes a really complex team. Nobody can be an expert in all of the systems, all the technology,
right,
all of the
Alex.
workarounds
Yep.
we might have to do to get a rocket off the pad. So thank
That's
you
the
for
red
the role
team,
you played in
dude.
that team today. It's awesome.
Thank you.
Yeah, thank you so much, guys. I appreciate you coming by to talk with us. All right, it's now been about 35
You know what?
minutes
Screw
since
that.
liftoff of
Screw that.
Artemis 1.
I want to see.
Orion-
I want to see that interview.
So right now we're actually joined by hydrogen by members of the Red Crew. You'll remember from watching the launch coverage that the Red Crew was sent out by the launch team when the launch team identified a small leak on a hydrogen valve inside of the mobile launcher. Well,
These guys look like they haven't
now
slept
here they
in, like,
are. This is
a
Trent
week.
Annis. Trent, can you just introduce everybody else here on your team?
Yeah, so this is Chad. He's our safety guy, and behind me is Billy, and he's the experienced hydrogen tech out here.
And the three of you guys really, I would say, saved the day today. I mean, really, you guys had to go in there to what's called the blast danger zone. You guys are specially trained to be able to do operations on the pad while cryo is loading. Talk to us about getting that call, being told, hey, you guys need to go in there.
You know
and
that
it was
guy,
the first
Rev.
time for all three of you.
Tell him, kick
Yeah,
butt
all I can
job,
say
dude.
is we were very excited. I was ready to get up there and go.
Really?
My
How
guy,
are you guys
man.
feeling?
My guy. I love these guys.
Very comfortable, very confident in the test team and the procedures and our training. We did a great job.
Walk us. Oh, sorry. Go ahead.
How gratifying it must be for you guys, because you train for this eventuality, but don't always get to do it. Billy was saying that he's been a Red Crew team member for 37 years,
cool,
and this is the first time he's been called to go into the blast danger zone. So I know for us, when we're training for all of these eventualities, whether it's a spacewalk or robotics operations, you really want to put that training into practice. How do you guys feel like it went today?
Amazing. I still can't believe it. It's surreal to me. It's just insane.
Yeah,
awesome,
kind of walk
man.
us through what you were
metal,
thinking.
dude.
So you get there, and what is it? Just like game time, and you're really focused, or how are you feeling?
Yeah, I'd say we were very focused on what was happening up there, just making sure we knew what was happening. Because the rocket's, it's alive, it's creaking, it's making venting noises. It's pretty scary. So on zero deck, my heart was pumping, my nerves were going, but. Yeah, we showed up today. I think as soon as we walked up the stairs, we were ready to rock and roll.
Dude.
And they were telling us a bit about it while you were working on it. You guys were actually just torquing down the valve to prevent or reduce the leak rate or stop the leak. Is that right?
That's right. Just the packing gland. It was a little loose, so went up there and tightened her up.
You're probably still like in this oh my gosh moment, like all of us
awesome,
are.
Dude. I want to do that.
Actually hit
Rev,
you,
can
like,
I do
the
that?
role you played today in making Artemis 1 launch?
That's so sick, dude.
I still can't believe it. It's like I said, it's surreal and just amazing. I don't know about you guys, but
they're nodding along behind you.
Yeah,
for sure.
yeah, I know. Yeah, Rev, he's
say to the launch team again. This is a big day for the launch team, for you guys, NASA,
exactly,
but really the whole world. I mean, this is a historic launch that I think we'll all remember.
I red team it. Absolutely.
We'll all remember, really.
We had a lot of people here helping us out. A lot of teams, firing room. I'm sure that was hectic, and NASA, Boeing. All the other companies did a great job, and we're glad to be part of it.
One thing I always like to say is spaceflight is a team sport, and I think you guys perfectly demonstrated that today, right? Like, none of us could accomplish this on our own. It takes a really complex team. Nobody can be an expert in all of the systems, all the technology, all the workarounds we might have to do to get a rocket off the pad. So thank you for the role you played in that team today. It's awesome.
Thank you.
Yeah, thank you so much, guys. I appreciate you coming by to talk with us. All right, it's now been about 35 minutes since liftoff of Artemis 1. Orion and ICPS are now free.
Thank you.
I know this game. Trenton's the youngest guy, so Chad and Billy made Trenton the guy that's talking, because they were like, we want you up on the cast, and Chad and Billy said, you do it. You do it. We ain't doing that. You know that's what's going on. They made him go up there. They're like, you go up there, man. We ain't talking to it. You do it. You're the new guy. That's what happened. I don't even know these dudes, and I know what's going on there. You're the young guy. You go talk. You feel that he wanted to do it too? I mean, yeah, he's there, dude. That's awesome. It's so funny. I love it. Oh, dude, that's great. That's great, man. They did not want to do that interview. Yeah. The red team, they're just like, yeah, I want to send it. I just want to go up there and tighten the bolt down and let her rip. Dude, I gotta see NSF's launch again. Can we see that one more time? Can we just back it up here and just appreciate that thing? Dude, that thing freaking went. Oh, it's freaking sweet, dude. Hold on, one more time. I'm turning the VOD audio up. Oh, that's freaking sweet, dude. That's freaking sweet. Oh my god. Yes. That's amazing.
5 engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour.
Oh my goodness.
Hearing good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis 1. First milestone will be for the vehicle to pass through max Q in about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket. SLS now traveling 607 miles per hour.
That's freaking sweet.
You're looking at 8.8 million pounds of maximum thrust. Quiet here in the loops in Mission Control.
Let's go back over to the main loop here. Give me 1 second. They should be doing the perigee raising maneuver. I'm going to bring the live stream back up. Oh, man, that thing is cool. Thank you for not adding us to death. I tried to make sure that no ads would show up, Limey. The only reason I even ran one is so pre-rolls would be disabled during the launch. Yeah, Phil, I got him. Oh, dude, that noise gives me a rush, man. I'm not even kidding. And you could say that's weird, and you'd be 100% right. It just fires me up. Yeah, that's right, S. Yeah. I see what you did there. Yeah, my pleasure, guys. Oh, solar panels are moving. The perigee raise maneuver is going. See the solar panels moving? I think this camera is looking up at Orion, but the solar panels are moving, indicating that the PRM burn may have just stopped. We may have had PRM cutoff. T plus 5256. Let me go over back to the track here. Those solar panels are moving around. I don't think we're far enough out for that PRM burn. It should be in about 10 minutes. Hey, Jade, 10 subs. Thanks, buddy. Hit us with more ads? All right. There you go. I can't believe that. Jade, I can't believe it. I can't believe it. I can't believe it. It's just in space. Can you believe that? I know, Sleepy. Do they use the upper stage for PRM, or is the RCS enough? No, the ICPS. They're using the ICPS. They're going to use the Delta 4 stage. You got to look at this. I've seen them. They've been linked like 4 or 5 times now, dude. They're great pictures. The RS-25s are... No, they still got some time, actually. That core stage is... Yeah, they got a little bit of time. Look at the solar panels. So the solar panels are supposed to move around like that, guys. They're actually on hinges, and the hinges are kind of spring-loaded. So when the rocket fires its second stage, the solar panels actually go back a little bit. Solar panels are moving back in preparation for the perigee raise maneuver. We're looking down from the... Oh, okay. So right here is the Orion stage adapter. Orion, yeah, so the OSA is right there, and this is the top of the stage. The solar panels are moving into the backwards position. 44-ish minutes until TLI. I'm with you guys for the ride, dude. Mike Lineback was the one who cut the tie, the launch of Charlie's tie. Mike Lineback was a launch director for NASA, if I'm remembering correctly, Bandit. I know that name. Interesting, Donald. They absolutely are. They better have the audio queued in. He's the launch director for the shuttle. Cool. Core stage in frame. I'm not sure. I don't think so. Let me fast forward us a little bit, make sure we're caught up. Take a look at my text when you get a chance. All right, Judge. See you, buddy. No way. Hydrogen burn off and just engine start. Look at the subtitle. freaking awesome. Go! Oh, that's freaking sweet, man. I love this. It's so good. It's so good seeing NASA launch stuff again, man. You have no idea how happy this makes me. Oh, Trud. You know what? I'm showing you again. I'm showing you again. You're going to like it. Dude, it was magnificent. Watch this. This is a replay, guys.
GLS is go for core stage engine start.
Watch. This is freaking beautiful. Flood! Go! Oh my goodness. Oh, it's so
cool. 5 engines on the core stage.
PRM burn is going. All right, we'll switch back over. Okay. We have the perigee raise maneuver burn going right now. This is the live shot. That was a replay there. Oh my goodness. I just freaking believable. I see it, Bruce. Thank you. Okay, perigee raise maneuver is circularizing the Orion and the ICPS up at 1,000. TLI at perigee. You got to warn headphone users so we can turn it up. Yeah, man. Oh, jeez. So right now the RL-10B2 on the interim cryogenic propulsion stage here is pushing that Orion capsule into a circularized orbit. Kind of similar to what they did during the Apollo program, except this is because SLS has much more, is packing much more of a punch. They're doing this at a much higher orbit. Much higher orbit than the Saturn V. Saturn V circularized into about a 200 mile by 200 mile orbit. That's 320 by 320 kilometers, give or take. We do have a live onboard shot here from the solar panel looking at the hydrogen tank on the ICPS, and this is the Orion stage adapter, the OSA for short. That's the service module right there. See this? If you see that band, that's your decoupler. Which we will see decouple, hopefully, in probably about 45 minutes from now. Cyborg's last. I'm busy. Nice. We did. Oh, Force core stage was there. Do you know why they deployed the solar panels before the burn? I would think you'd want to be stable before doing the panels. The panels actually have shock absorbers and springs on them, Brimo. So you see how it's kind of swept back like Orion is Naruto running in space. That's on purpose. They have shock absorbers that are designed to do that. Yeah, in terms of why they deploy them now, you got to be sure. Oh my goodness. I can't believe that. Nice shot by Coop. That's fantastic, Jazos. If I could see your last, please. Okie dokie. If you look through, you can see the shockwave propagate through the smoke and the low frequency waveform shaping in the exhaust clouds. Pretty gnarly, right? You replay your reaction. I yelled at the camera a little bit, but the mic cut out. Yeah, but the easy solve is to just wait to deploy them. I think
Thanks,
the batteries
Megan. And
might
you're
run
right.
out.
We are coming up on perigee raise maneuver about 2 minutes from now. We are now 51 minutes into the flight of Artemis 1 after lifting off at 1:47 a.m. Eastern Time from Kennedy Space Center. The vehicle now traveling over 14,600 miles per hour. So during Orion's orbit of Earth, it reaches an apogee and a perigee. The apogee is the highest point above Earth's surface, and the perigee is the lowest. Therefore, this perigee raise maneuver maneuver is a firing of the ICPS RL-10 engine, and it's going to raise the lowest point of Orion's orbit over Earth. This also included a checkout of Orion's systems and any adjustments to the solar arrays. All 4 of those solar arrays, as you can see, are swept back. That's going to keep them from having any loads imparted that might damage them for use later in the mission. This also, the perigee raise maneuver, will put us in the proper position for the translunar injection burn. That's that really big and long burn that we need to send us to the moon. We're about 1 minute away from the perigee raise maneuver. This is a shorter burn. It's less than 30 seconds.
Yeah, but not a lot of them are going to go to the moon, Lucky Fire. Thank you for the commentary in the stream. Love dropping into you on launch days. Yeah, my pleasure, Alpo. Thank you for thinking of me. How can there be any loads in the back here?
About 45 seconds until the perigee raise maneuver.
Load is force applied. That is not circumstantial to pressure. But like the pressure doesn't matter. This thing is still accelerating hot gases out the back. The hot gas is your reaction mass, and that's what's propelling you. That's like saying if you blow up a balloon.
Coming up on 53 minutes into today's mission, and we are standing by for the start of the perigee raise maneuver. Again, this is a firing of the RL-10 engine on the interim cryogenic propulsion stage.
Either that or this graphic is supposed to be a chill down and thermal conditioning on the RL-10B. It could be that. I'm not sure. So we should be getting into the perigee raise maneuver here per what the NASA PAO is saying. Oh, yep, there we go. Yep, nope, she's definitely firing. Solar panels are moving.
And we have confirmation of perigee raise maneuver ignition and full thrust. This is a live view from the spacecraft. Again, a really short burn. We're standing by for the cutoff.
Yeah, see what I mean? They're on shock absorbers. That's why you get the back and forth motion. They have to deploy them. Now that I'm really thinking about it, they have to deploy those things or else Orion's going to run out of batteries.
And we have confirmation of perigee raise maneuver cutoff.
Okay.
Flight Dynamics Officer reporting on the loops here at Mission Control Houston that it was a good burn. We are now 54 minutes into the flight, Orion traveling 14,700 miles per hour, and that was the perigee raise maneuver, lifting the lowest part of Orion's orbit around the Earth and putting us right where we want to be for the translunar injection burn. We're looking for that translunar injection burn to happen about 1 hour and 26 minutes after launch, so about 30 minutes from now. That'll be that long burn that helps us break free from the pull of Earth's gravity and commits the spacecraft to a lunar trajectory. So with successful completion of the perigee raise maneuver, I'm going to toss it back to Megan at KSC.
No, keep it.
I really wish we could listen to this flight loop, man. So if you're just tuning in now, guys.
Now 55 minutes into the flight of Artemis 1. Again, we had liftoff at 1:47 a.m. Eastern Time from Kennedy Space Center in Florida. Teams here in Mission Control Houston will continue monitoring the mission around the clock all the way until splashdown of the Orion capsule.
When's TLI? About 30 minutes, Cody. When you move your head, it's over the timeline. You're not missing much. It's just, it's not even like this is close to making PRM cut off, TLI burn. But TLI burn. You suck. You really like to make this harder for me, don't you? Thanks. Shut up. Shut up, punk. Celix, we have onboard cameras. They're showing them, just not very often. I really wish that we'd get some telemetry here or something, but yeah. Okay, actually going to bed now, Chutch. You should stay until TLI, man. You're not gonna regret that. Got to go about 20 miles away to see it. Incredible. It's pretty lit up the sky, Cody. It's like it was daytime, wasn't it? That's shuttle launches, man. Hopefully If you guys saw that, you see why I love the shuttle so much. It was very emotional seeing those things. It was very emotional seeing that happen again. T-6, engine start, booster ignition. Oh, it brought me back, man. I miss that shuttle so much, but this is, if I can't see the shuttle again, this is fine too. Something like that, Zero, yep. It looked like sunrise. Yep. Isn't it cool? Wasn't that special? I'm telling you, NASA launches cut different, man. They cut different. I don't care what anybody says. I love SpaceX and I love everything that they do. NASA launches cut different. This is cool. This is real cool stuff. They just cut different, man. NASA just showed a launch view from the tower. Yeah. It just cuts different, man. Oh, it's so cool. Oh, looks like Bill is about to talk here.
I'm telling you, you definitely knew that there was some energy being expended over there.
You're damn right, boy.
What does it mean to you to be the leader of our organization for a historic launch like this? We've been talking about the team it takes to get this done. How does it feel to be at the helm of that ship?
Well, I got to talk to the Launch Control Center team, and I said to them, you all are a part of a great legacy that has been many, many years coming, a lot of sweat and tears, and this legacy NASA, is now taking us as we explore the heavens. And it didn't end with Apollo 17, but this time we're going back, and we're going to learn a lot of what we have to, and then we're going to Mars with humans.
Why is it such a priority for the agency to land the first woman and first person of color on the moon through this Artemis program?
Well, I think it's reflective of us. It's reflective of America. We are people, our Latin emblem is E pluribus unum. In the chamber of the United States Senate, over that main door is E pluribus unum, out of many, one. And so our astronaut corps reflects that. And it's going to be the first boots back on the moon are going to be the first woman and the next man.
Yeah. And another goal of the Artemis program is to spur economic development. Can you talk to us about how this program has been able to do that for the country?
Now you got to hear about one-time speed.
If you put it in NASA's economic report terms, it's billions of dollars affecting the economy, almost 400,000 jobs, but that's just direct. Think of all the indirect expenditures that are causing the economy to rise and more jobs. For example, what you guys are doing on the station, a lot of your research. Take, for example, the pharmaceutical research. You're helping already one drug that's being manufactured on Earth better because of what you learned in space, and that drug is attacking cancer. Now, what's the value of that? That's just additional value that is added. I remind everybody,
my favorite space show.
Everybody's pocket, they've got a cell phone, and that's got a camera.
Sky count?
And that's a camera on a chip that came out of the NASA space program.
That's right.
Absolutely. In addition to those innovative new technologies and the economic impact, I think for me seeing this launch today is so palpable, just that human desire to explore. What do you think about what we're doing to inspire the Artemis and the generations to follow us?
Well, I think all you have to do is walk into a classroom of kids and look how their eyes get big when you start talking about space. And that is going to multiply itself manyfold as we go back to the moon and then on to Mars.
Dude. I can't get enough of it.
It's also going to bring about a new generation of engineers and mathematicians and technologists and scientists, and all the benefits of that additional activity and education coming out of the Artemis generation.
At this altitude.
Look what that's going to do for our country and our economy, as well as for our international partners.
Alex, what's Tomas saying?
And
we're going. Hell yeah,
it's a great day.
Couldn't have said it better myself. Administrator, thank you so much for joining us for this momentous occasion. As you said, this is the beginning of a new age in space exploration. Thank you so much.
Thank you, ma'am.
And Kayla, that's going to do it for us here at the host desk. Launch was just the first step in a nearly 26-day mission. Our colleagues in Houston will now continue the broadcast to bring you the next big milestone to the moon. From Kayla and me, have a great day, and go Artemis 1.
Go Artemis.
Trent, Chad, and Billy. Just goes to show, need something fixed, just call your redneck
And we had a great ride to orbit today. We are now 1 hour and 2 minutes since we launched the Artemis 1 mission. Orion is traveling with the 2 minutes since we launched the Artemis 1 mission. Orion is traveling with the interim cryogenic propulsion stage, now almost 15,000 miles per hour. We recently saw the perigee raise maneuver. That's where we lifted the lowest point of Orion's orbit around the Earth, and it puts us in the perfect position to prepare us for translunar injection burn coming up in about 25 minutes. So again, we are looking forward to that translunar injection burn. That's what it's going to commit us to our journey to the moon. And to tell us a little bit more about the translunar injection burn, we've got Dan Hewitt standing by to show us on the moon board how it's all going to go down.
This stream won't cut to Dan here. ICPS, interim cryogenic propulsion stage. It's a Delta IV derived upper stage that they're using on SLS Block 1. This will only be used for 3 to 4 flights, maybe. And then when they introduce SLS Block 1B, they'll introduce the EUS, the Exploration Upper Stage, which is basically a much bigger version of this. Instead of the Orion Stage Adapter on the Block 1B SLSs, with the EUS having an 8.4 meter diameter, instead of this, the Orion Stage Adapter, they're going to have what's called the Universal Stage Adapter, which is basically a payload fairing that Orion rides on top of. Similar to Direct, actually. Do you point at the moon and go when it comes over the horizon, Genesis? Sure. I know, Dragon. That's how you know it was good.
Discovery, go at throttle up.
Easy. Awesome launch, awesome coverage. My pleasure. Thank you for sharing it with me, guys. It's a privilege. It's a privilege what I do here. I don't expect anything from you guys, but I do appreciate you coming in here and giving me your time. It means a lot. What's its track? Will I see this on the horizon? No, I don't think so. Do you know where it's going to be for TLI? I don't. Yeah, Noswell, thanks, man. I gotta go. This was epic. Thanks for the coverage. My pleasure. I'm sorry, Naroku. My pleasure, everybody. My pleasure. We're waiting for TLI, dudes. We're waiting for TLA. TLA. We're waiting for TLI. Dude, I can't even talk straight. I cannot believe what just happened. My brain's having trouble putting it together. I've been waiting for this for better part of a decade, guys. More than that. It's been 11 years. It's been 11 years and 6 months since the last shuttle launch. Or actually, well, 10 years, 6 months, I should say. Close enough. Actually, no. It has been 11 years. It's 11 and a half years. I did that right. It's been 11 and a half years since the last shuttle launch, and I didn't think I'd ever see that again.
Discovery, go at throttle up.
No problem, Dicer. Yep, I found your next 3D printing project. When TLI? It should be in about 20 minutes. I have that open, Kalani. I'll check that out in a second. Merci beaucoup pour l'estrom. My pleasure. They better have the MCC control up for go for TLI burn. Yeah, yep. Let's lift a beverage. Might as well wait until the TLI burn. I got something planned.
Thanks, Dan. We are 1 hour, 6 minutes, and 30 seconds into the flight of Artemis 1, now traveling over 15,200 miles per hour. Again, we've recently had the perigee raise maneuver, and in less than 20 minutes now, we'll be looking for the translunar injection burn that Dan just showcased that's going to send us to the moon. But our mission started off with an epic show from the Space Launch System.
Space beer? Oh, it's not the space beer. I said we'd open up the space beer when people land on the moon. I got something else planned, don't worry. 1 hour 30 is TLI burn and 150 is TLI burn end. I thought it was 8 minutes. I thought it was, okay, it's more than that. Jeez. 20 minute burn from the ICPS.
Again, the Space Launch System is what carried us into orbit today, launching off at 1:47 a.m. Eastern Time. And we've got a couple of special guests from Marshall Space Flight Center. We have Bruce Tiller, the solid rocket booster manager, and Johnny Heflin, the RS-25 engine manager, to tell us more about the maiden voyage of the rocket. Now, they both got to watch it live at Kennedy Space Center. So a big hi to you, Bruce and Johnny. Thank you so much for joining us today.
All right, we're going to give a double here.
Thank you so much for joining us today.
Thank you. Thank you for having me.
Yes, pleasure to be here.
And can you tell me a little bit about SLS performance today? Did it perform as you expected?
Go ahead, Bruce.
You want me to start?
Go ahead.
Sure. So I managed the booster part of the rocket, and the boosters were fantastic. They performed just as we expected. We got to see some of the data. Obviously, the team hadn't plotted it all, but the pressures looked great. You know, it burned for just the right amount of time, and it separated great. We could see that as well. So very pleased. We were confident it would work well, and it did. Very happy.
Similar story for RS-25. Nominal, what we call nominal performance. The engines performed exactly as predicted. Based on the quick look data. Like the booster, we've got a lot of data to look at, but so far the data looks really good. These historic RS-25s that have 25 flights between them on coming off the shuttle program. So really looking forward to getting a look at the data. It looks really good so far.
That's fantastic, and we agree. It was amazing to monitor here, and the loops were very quiet in Mission Control Houston. That was a good sign. You knew that things were going well. So we know that the launch abort system was inactive for this mission, but it will be active for when we have crew on board for Artemis 2. Are there any other differences we can expect to see in the rocket for Artemis 2?
So for the boosters, by and large, no. If I talk about the boosters from top to bottom, we are going to make one change though, because of the crew is on it. We're going to have a delay timer in there, so that if for some reason they need to abort,
right around the TLI
we have
a
few seconds there before, after they abort, before the termination system destroys the rocket. So we will add that, but other than that, nope. These boosters will be the same. Second flight is the first.
Same story for RS-25. It will be the next set of 4 heritage engines from the shuttle program. Configuration-wise, they'll be the same as what we flew today.
Then I'm glad it all went so well. And so after you get that data back from today, what's next for your team?
Well, for my team, we've still got a ton of work to do. We're not only, we're working on at least 3 flight sets at the same time, and so we've got 2 and 3 and 4 to work on. We also are working on a new booster that's a composite case design that will replace this steel case version that we're flying today. So we're excited about that, and there's a lot of work going on there as well. So
I'll trade it for
we've got
the
a
moon.
lot to do,
That's
and
fine.
we'll just keep doing it.
So RS-25, super busy as well. We have the Artemis 2 engines have already been delivered to MAF, and they're on schedule to be installed in the Artemis 2 core stage in mid-January. We're also about to start the certification test series for the new RS-25 engines that we're building. We have heritage engines for the first 4 flights. Beyond that, coming in on Artemis 5, we will fly what we call the RS-25 restart engines that have been redesigned to reduce cost and reestablish manufacturing for future flights. So we're really excited to get into that certification test series really soon as well.
That's the only thing I would trade
All right. Well, thank you both so much again for joining us. I'm glad that you got to watch the launch, and a major congratulations to you and your teams for all of the effort that you've poured into this. Go Artemis.
Great day.
Great day.
Thank
Fantastic.
you so much.
Good. Good. It's a great day.
All right, and we are now 1 hour and 12 minutes into the flight of Artemis 1. We are traveling at orbital velocity. Again, Orion is currently attached to the interim cryogenic propulsion stage, which recently performed the perigee raise maneuver. And we are standing by for translunar injection burn, now less than 15 minutes away. It's going to be about an 18-minute burn that will commit us to the moon. Part of the Artemis program's goal is to inspire the next generation of dreamers and explorers. So we want to show you what students are doing right now to bring the Artemis missions to life.
You have no idea what you're watching. You're watching the Orion capsule up here and the service module with the upper stage here as part of a larger launch vehicle called the Space Launch System. You're seeing a telemetry interpolated view of them orbiting around Earth. What this is basically the first time NASA has sent a human-rated spacecraft out beyond low Earth orbit. What you're going to witness here in a second when we get to the TLI burn right here, which is the next step in the flight, should be at about 15 minutes. The first time that NASA sent a human-rated spacecraft outside of low Earth orbit since December of 1972 on the Apollo 17 mission. It is a red-letter day. NASA is testing their capsule design for going out to the moon. This one doesn't have people on board, but the next one will, which is pretty amazing. It's not fuzzy, guys. It's raining. It's pouring outside, and it's the rain noise off the roof. Did you see the Track Artemis page has a little telemetry? Yes. So right now, the Orion capsule, the ICPS here, and the European Service Module are 802 miles in altitude, traveling at 15,900 miles an hour. You guys want to hear it? You guys want to hear how good the noise filter is? Look at this. That's how good the noise filter is. It's pretty loud. Are you outside? No, Benno, my garage has a steel roof. MGB, you saw the very first shuttle launch on TV when you were 11. Watching SLS really took me back. Thanks for a great show. It was fun watching the rocket fly. My pleasure, dude. My pleasure. You asmering me? Yes. Yeah, that's what I mean, Zelix. The noise filter is doing us wonders right now. That's why you hear static when I was talking. What is that? That's water falling from the sky and hitting my metal roof. Yeah, Cherokee, I'm with you on that one. Hey, remember when I said that could be a problem? No, all I hear is peace and quiet. Nah, floating wouldn't be right. Space ASMR. Well, I gotta go dinner cooking, so I'm gonna keep the NASA stream up on the Lounge TV. No problem, Hawks. Yeah, that's right, Zelix. When will the supply missions start to launch, and how are supplies getting to the moon? With a big rocket, and they should start happening. Gateway assembly missions should be about 18 months from now. Take that filter off again so I can go to bed. Okay. The ETA on TLI Sky Seas is about 10 minutes. I'm working on it. That's coming out. Yeah, that is a pretty cozy noise, isn't it? What's wrong with your voice? Nothing, Cody. You're just hearing things. What is water from the sky? Yeah. Check out NASA's stream. NASA's stream is on the screen right now.
Tell us all about our spacecraft.
Oh, yeah. Are we done receiving actual footage from the capsule? We better not be, man. Okay. They're beginning to chill down here. I'd assume that's what that graphic is, because that is not the right direction at all for the TLI burn. I know, Eddie. Can you believe that? They're gonna slam the upper stage into the moon. No, it's a heliocentric disposal orbit, goalie. It's gonna orbit around the sun. Nah, Hibbit, it's the rain filter. I'm fine, guys. I'm wide awake. I'm wide awake. I knew I was gonna be wide awake for this, dude. Yeah, this graphic, this infographic is a little bit behind or ahead of schedule here. Right now, the Orion is at 691 miles, and it's actually accelerating at a speed of 16,220 miles an hour. It's accelerating to perigee, and it will burn at perigee utilizing the Oberth effect. We got an 18-minute burn from the interim cryogenic propulsion stage here. But right now, the vehicle is starting to orient to posigrade velocity, or posigrade vector, I should say. All right, Wolf. Tonight was amazing. Thanks for the coverage. I remember taking a school trip for STS 107 in 2003 to watch it go up. Wow. Yeah, dude, it makes me happy. It makes me happy seeing that thing launch again. It's like seeing an old friend. Where do you see the telemetry? NASA.gov/special/track Artemis. What's the specific impulse on that engine? RL-10B2s make 460-second specific impulse, City Robo. Why are they not sending me telemetry? Question. Yeah, they didn't have KRPC hooked up from it. You missed the launch. Penta. I'll show it again. I'll show it again for you. Watch this. You're in for a freaking treat.
20.
It's about as good as you can get, Sky Seas.
15.
There's a reason why they use that stage.
10.
GLS is go for core stage engine start.
Oh, mama. Dude! Dude! Oh my god! Dude, it's so good! It's so good!
5 engines on the core stage.
Oh, that's fucking awesome!
128 miles per hour. 7 minutes from now. Again, that's one of a long run for us, about 18 minutes long.
Oh my gosh.
But before we get to that milestone, I have a friend of mine here. It's Stu McClung, the Program Planning and Control Office Chief of Staff for the Orion program. Stu, I am so glad that you could join us today.
Thank you. Good morning. Good to be here.
So how is the spacecraft performing so far, and what's
what
next?
A beast.
So far so well. Good. We were clean.
You were right. All the haters are in love with SLS now. It's because they don't know, man. I told you, everyone's gonna be the biggest cheerleader. Do you see how freaking metal that thing is? Oh, it's so cool. I want more. I want more of them. Launch another one tomorrow, please. Launch more. Oh, freaking called it, man. Called that from a mile away. Oh, all those critics, they look real stupid now, don't they? Damn, son.
First DTOs that we'll take and evaluate how they react.
It's better than a cup of coffee, man.
Designated test objective. What are what's another one of those that we'll be looking at over the next 26 days?
Oh, we have probably a good 100 of them. They culminate from everything from like the modal survey to how the cooling system behaves, contract system. On entry day,
I want another one now.
One of our
Rev,
major test objectives.
We need to get core stage 2 there, like now.
How it handles entry heating.
So how does it feel to be here today and see the future of human space exploration unfold?
It's great. I was doing my
rockets are
shift in the mirror earlier today. Haven't slept. The emotion and the adrenaline's got me going. It's great to be a part of this.
Okay, man.
It's great watching, watching the KSE team execute.
Raining, yes.
And now this is day one for us. We've got 26 days for our team to execute now. And
Angel, it's a really big problem.
Our job and
I need help.
Set the stage for future.
Not right now.
Exploration.
And we're excited. We're going to be here along the way for all those major milestones, burns, all the other exciting events that we are looking forward to. So thank you so much for joining us here.
Gotta keep an eye on
we
TLI.
Are really excited. A big congrats to you and your team.
Thanks. Let's go ahead.
Artemis 2 might make the end of actually, Artemis 2 is going to be in the beginning of 2024. It might be the end of 2023 if we're lucky. If everything goes right. Remember, guys, Artemis 2, how fast Artemis 2 happens really kind of depends on how good this flight goes. That's really important to understand. With that being said, I want another one. Dude, these need to go every quarter, every 3 months. These need to go. It has to be that way. I'm sorry. That was too awesome. I'm sorry. It was too awesome. It was too freaking awesome. Did you see that? It was amazing. It was amazing. Oh, it's so cool. We're going back to the moon again. This is dreams, man. It's freaking dreams. I've been dreaming about this day for a long time.
You hear of the White Flight Control Room in Mission Control Houston. This is where all of the teams will be monitoring the mission over the next 26 days. Teams monitored launch tonight. There are, of course, several different shifts that'll be working here.
I'll take 4 a year. 4 a year is just fine. Chief, I don't want to talk about that.
All right, we are coming up
You
now
like it,
about
P-Dub?
3 minutes until the translunar injection
Kind
burn.
of blew the mic out. My bad. All right.
Again, it's
almost
about
a
an
TLI.
18-minute long burn. Firing of the RL-10 engine on the interim cryogenic propulsion stage commits us to lunar trajectory. It helps us break free from the gravitational pull of Earth.
I'm with you, Zanku. And I think depending on how well this all goes, we're going to see more.
In case
SLS.
you missed it, in June of this year, we launched Capstone, a small satellite launched from New Zealand, designated
Calling
to
it now. They'll ramp up to 4 a year.
I'm
pretty sure.
unique lunar orbit for our future space station around the moon called Gateway. And just 2 days ago, Capstone arrived at its intended orbit around the moon. So we're very excited for that milestone. It really helps pave the way for our future Artemis missions.
You don't need to download anything. You can just go play it, but it's really, really difficult. And there's a lot of paid DLC. Capstone did make it, guys. Yep. I wouldn't be surprised if funding doesn't increase. I'm telling you, Core, a lot is riding on this mission. NASA seems to have a thing that they want to open up the SLS to commercial customers. And they wouldn't do that unless there was a commercial customer. That's why I think SLS is going to fly more than twice a year.
Coming up on 25 minutes since liftoff from Kennedy Space Center today at 1:47 a.m. Eastern Time. We had a really smooth ride to orbit. We saw solid rocket booster jettison, as well as launch abort system jettison. Eventually, we had core stage separation, which put us in the configuration that we have now, with Orion connected to the interim cryogenic propulsion stage and flying free. The solar arrays deployed and have been swept back in preparation for the translunar injection burn. Earlier, we had the perigee raise maneuver, which lifted the lowest part of Orion's orbit around the Earth, put us in this perfect positioning ahead of translunar injection burn. A good shot here of our 2 flight controllers. On the left, you saw Judd Freeling. He is the ascent flight controller. He's been with his team here for the last several hours. And to his right is Rick LeBrode. He's the lead flight controller for a majority of the rest of the mission.
Onboard cameras
take
hit
over
differently
again
than NASA
once we
mission,
get back into the re-entry portion. We're now less than a minute away from translunar injection burn.
There it is. TLI burn.
And this is a live view from
49
the spacecraft.
years, 11 months since the last time this happened. 49 years, 11 months. You're witnessing it for the first time. in about 50 years. This burn should go for about 18 minutes.
You can see from this view we have all 4 of those solar array wings swept back. Orion now traveling off the northwest coast of Australia towards the Pacific Ocean. This translunar injection burn will begin to take it away from the Earth, breaking it free from the pull of gravity. We're standing by for confirmation that the burn has started.
Uh-oh. Hold on.
We have confirmation from the booster officer
that was a little bit of a shift right there. Hold on.
Burn has begun.
404. Welcome to Mission Control.
Again, this is a long burn, about 18 minutes.
That was weird, dude. It must have picked up on closed loop.
It commits us to a lunar trajectory.
It did
this
that.
ICPS firing now is an RL-10 engine. It's a design that's been around since the 1960s, and it's a proven, reliable engine. This
it may have been
engine
outgassing,
has 25,000 pounds of thrust. We've already seen the ICPS in action today as it powered the Perigee raise maneuver just about an hour ago.
How fast can they accelerate? Pretty fast. That RL-10 is actually pretty low energy. It's 18-minute burn.
Sunset of the Earth. This is the closest Orion will be to the Earth until it begins its return home. Right now, we're about 382 miles above the Earth's surface, and to put it into perspective, we are approximately 252,670 miles away from the moon. I'm going to keep reporting that number, and by the end of the translunar injection burn, you will see that start to decrease. We are going to continue to grow closer to the moon and further away from Earth. This really helps us break free from gravity. Now traveling at 17,743 miles per hour. We're about
total
a minute
delta
and a
V
half
on this
into
is about,
the burn.
what is it, guys? 14, 15 kilometers a second?
And although this is the last burn for the interim cryogenic propulsion stage, there are other burns that will take place throughout the mission to direct Orion exactly where we want it to be.
What's the speed
Those
after
include
TLI?
the outbound trajectory correction
23,000
burns,
miles
the
an
first
hour.
of which will happen later today. We also have the outbound powered flyby, the return powered flyby, and others. Burns after the ICPS separates will be conducted by using the single main engine on the service module, 8 auxiliary thrusters on the base of the service module, or 24 smaller thrusters.
Pretty cool. Going to the moon. I told you guys this hits different, dude. I don't mean to keep being that guy that's saying, oh, I told you so. But it hits different, man. It's just, this is wild. Isn't it crazy? We're going to the moon. This thing's going to the moon.
Coming up on 2.5 minutes into the translunar injection
Deep
burn.
Space Network has AOS now.
We're now traveling over 18,000 miles per hour.
I know.
That speed is going to increase
dude.
as well.
Space makes me nutty, dude. I'm not even kidding. I don't go crazy eyes a lot, man. I'm going mad crazy eyes right now. I got the Smpaku eyes going right now. It's so good.
We have 10 CubeSats along for the ride
with
us today.
It makes me crazy.
These will be deployed after this translunar injection burn and ICPS separation. These are located inside the Orion stage adapter, and they include the Lunar Ice Cube, developed by Morehead State University in Kentucky. This is searched for all forms of water with an infrared spectrometer. LunaMap from Arizona State University will create higher fidelity maps of near-surface hydrogen in craters and other permanently shadowed regions of the lunar south pole with neutron spectrometers. Almatanashi is from the Japanese Aerospace Exploration Agency, which is also known as JAXA. They are developing the world's smallest lunar lander to study the lunar environment. And Lunar by Lockheed Martin in Colorado will perform advanced infrared imaging of the lunar surface.
So on the left,
now 3.5 minutes into the translunar injection burn. Again, it's about an 18-minute burn, traveling 18,560 miles per hour.
I'll be right back 1 second, dudes.
Quiet on the loops here in Mission Control as the RL-10 engine continues doing its job on the interim cryogenic propulsion stage. We talked about a few of our CubeSats. We also have one preparing to study an asteroid. The Near-Earth Asteroid Scout, or NEA Scout, by Marshall Space Flight Center in Alabama will travel by solar sail to a near-Earth asteroid to take pictures of and make other characterizations of its surface. There's a CubeSat on board studying Earth called Equuleus by the University of Tokyo, along with JAXA in Japan. Equuleus stands for Equilibrium Lunar Earth Point 6U spacecraft and will travel to Lagrange Point 2, imaging Earth's plasmasphere for a better understanding of our planet's radiation environment.
I agree, Donald. Yep. There's a lot of secondary missions here that Lee is talking about.
We're now coming up on 4 minutes and 45 seconds into the translunar injection burn. Orion traveling at 18,982 miles per hour. Our distance from the moon continues to decrease, now 251,900 miles away.
It should be about a week and a half.
To highlight some more of our CubeSats on board, we also have BioSentinel, developed by Ames Research Center in California, and we'll use a single yeast cell to detect, measure, and compare the impact of deep space radiation on living organisms over an extended period of time.
Cool. This is looking down from the Orion capsule at the ESM and the
and Argotech in Italy. This CubeSat will observe the interim cryogenic propulsion stage, the stage that it's firing right now, with its advanced optics and software imaging system. And our last CubeSat through the Centennial Challenge is Team Miles from Florida, who developed a CubeSat that will demonstrate propulsion using plasma thrusters and will compete in NASA's Deep Space Derby. These CubeSats pack a ton of tech and science in a tiny package, so they don't all have redundant systems. And if any of the CubeSats missions don't go as planned, it does not affect our primary objectives of Orion's mission. This rideshare opportunity is a rare chance to send CubeSats beyond low Earth orbit, and we're looking forward to seeing what we learn. We're now 6 minutes into the translunar injection burn. Orion traveling at 19,500 miles per hour, being propelled by the interim cryogenic propulsion stage.
Integration is set for mid-January.
Still quiet here on the Loops and Mission Control Houston. Teams are tracking no issues during the translunar injection burn.
6 months out.
Again, this is about an 18-minute burn, so we have approximately 11.5 minutes left.
I mean, guys, if you think about it, Artemis 2 with people on board is not that far away, guys. I'm thinking we are in the launch campaign for Artemis 2 already. Artemis 2 is set to go the beginning of 2024. That's 12 months. 12, 13, 14 months, 16 at the very latest. That's not far away for the next one. And then it's only gonna ramp up in frequency from there. We are not that far out. It's gonna get there a lot faster. And depending on how well this flight goes, they might go even faster than that. If they can really put foot to tail, and I believe in these guys, I really do. I always have. I've never cast a shade of doubt ever. I think they can get it done. They can once again prove that they can do the job. Where is it right now? It's off the coast of Australia. So I think we might see it faster if depending on how well this flight goes. Broccoli, I wasn't alive for Apollo, but I watched first Columbia launch. I can't describe this feeling. It's so good. Favorite vehicle technology, doing moon things. I'm with you. Nice, Forlung. It's a great song. How about Artemis 3 and 4? Artemis 3 is scheduled for the end of 2024 into 2025, and then 4 should be 2025, 2026. Would crew still be in the orange flight suits? Yes. Phil Sloss said on NSF a couple of days ago that Lockheed is going to try and reduce the time it takes to integrate the A1 avionics into A2. Won't know till it's back at the factory. Like I said, it depends on how well this flight goes. Starship is landing for Artemis 3, that's correct.
Artemis Accords, which will establish a common set of principles to govern the civil exploration and use of outer space.
This one has it, admitted.
The Artemis Accords will create a safe, transparent environment that facilitates exploration, science, and commercial activities for all of humanity. This cooperation not only furthers space exploration, but also enhances peaceful relationships between countries on Earth.
Artemis 3 and 4 already have long lead items, guys. These missions are going to start coming at you pretty hot and heavy. And in the meantime, we got Starship and Falcon 9 and all these other great vehicles that are flying. And then New Glenn's still in the pipe. Vulcan should be coming soon.
We're now over 9 minutes into the translunar injection burn, an 18-minute burn. So we have about 9 minutes left. We're about halfway through. The RL-10 engine continues to fire at maximum thrust.
It's already been linked to you, man. Bandit and Jazzy.
Orion traveling attached to the interim cryogenic propulsion stage now over 20,600 miles per hour.
How will the Lunar Space Station works and when it will be built? 2023 into 2024? 95? It'll be built before the first first lunar landing. The first components for Gateway are going to be launched on a Falcon Heavy. The two primary components are the PPE, Power and Propulsion Element, and the HALO, Habitation and Logistics Outpost. They are originally supposed to be two modules that were going to launch on SLS. They combined them together, and they're putting it in Falcon Heavy's extended fairing that the Department of Defense has commissioned, and they're going to shoot that thing off to the moon in 2023, probably 2024. Somewhere around there. That too is not that far off. Big PPE energy, indeed.
It's been 1 hour and 37 minutes since we launched today. Again, that was 1:47 a.m. Eastern Time from Kennedy Space Center. Orion is still attached to the interim cryogenic propulsion stage. This is the last burn for the interim cryogenic propulsion stage while attached to Orion. It will also have a disposal burn later on.
We wanted our space mission to be some wusses. We would have named him Dr. Quinn and Medicine Woman. Walker, Texas Ranger, boy.
Orion will separate from the interim cryogenic propulsion stage itself, and the capsule will be flying free, still attached to the European service module. We've got about 7 minutes left in the translunar injection burn. Orion traveling now at over 21,000 miles per hour.
This is good. This is good, man. Very nice. At what point are we committed? Can they throw the e-brake on it right now if something happens? No. No. The e-brake? No. We're going all the way. I'm telling you, Blinga, there's a reason why Delta 4 holds a special place in my heart, because that tech is very, very good stuff. That's why I'm bumming seeing our 68As not being made anymore.
The RL-10 engine continues to fire on the interim cryogenic propulsion stage, powering the translunar injection burn. This is the second firing of the ICPS today. The first we saw was the perigee raise maneuver, which lifted the lowest point of Orion's orbit around the Earth and put it in the proper positioning for this burn. This is the burn that commits us to the moon. We're now over 12 minutes into this burn. Again, it's about an 18-minute burn, so less than 6 minutes left, and 1 hour 39 minutes since we launched. Orion and the ICPS now traveling at over 21,400 miles per hour. And as I promised, we continue to grow closer to the moon, now 249,000 miles away.
Yeah, Rain, it's pretty good stuff. Can you press M for orbital view? I can't, actually. No, I don't have the controls for a human space program. You might want to see. I might want to see this thing that's been linked. Trevor's picture that's been linked 3 or 4 times. Yeah, I know, man. EPF snake, so Space Nut got a really, really good picture of that, too. Yeah, that's pretty rad, man. Can't believe it. So glad you convinced us to stay up to watch this. I've told you back, you don't want to miss this. This is magic, man. It's magic.
Now over 13 minutes into the translunar injection burn, putting us less than 5 minutes away from cutoff. We have had a nominal burn so far. That RL-10 engine continues to fire at maximum thrust, 25,000 pounds of thrust. We're now traveling over 21,730 miles per hour.
Good, my dude. There's some people that are fast as frick in this chat, linking the links hot and heavy, Spoon. They're fast as frick, boy! Was this just as good as a space shuttle launch? It was close. Yeah, it was close. It was very close.
And we've just heard the call for priority 1, meaning we have reached the point at which we could return at lunar return or similar speeds, testing the heat shield as required ahead of flight for Artemis 2.
There's your abort contingency, goalie. Nice, Zay. Please rate.
Now over 14 minutes into the translunar injection burn, less than 4 minutes until cutoff, traveling now at over 21,900 miles per hour.
Does an RL-10 have an alternator? I'm not sure about the B2 variant. I do not think that it does. No, shuttle launches were better than this particular one. This was still good, and it didn't give me a lot of really, really thick nostalgia. But shuttle launches are better because you knew people were on board. That is the coolest thing. I don't think it can be matched. Maybe Starship will get close. I really do. I really hope it does. But yeah, Artemis 2 might rival this. I'm telling you, just seeing the people step into the capsule, that Artemis 2 will probably be just as good. But that's what shuttle launches
now
were
less
like.
than 3 minutes away from cutoff of the interim cryogenic propulsion stage, and coming up on 1 hour and 42 minutes into the Artemis 1 mission. The RL-10 engine on the interim cryogenic propulsion stage continues to fire as planned at maximum thrust. Again, this is about an 18-minute burn. That's about twice as long as the ride to orbit today, so that just shows how much power we need to break free from the pull of Earth and take us to the moon.
Yeah, Zonku. That's Bush League compared to this, bro. I know you're kidding, but still. It's going to take some time for people to be cool with riding on Starship, especially with the propulsive landing, dudes. You believe it,
16
Thomas?
minutes now into the translunar injection burn. Orion traveling at over 22,276 miles per hour.
Yeah, it's not a lot of GZVX. That's RL-10B2s make 460-second specific impulse, but they only make about 100 kilonewtons of thrust. It's not very much. But 460-second specific impulse is a very low energy stage, the ICPS. Weirdly, my favorite part of this launch was all the lessons they got from wet dress rehearsal.
About a minute and a half now until cutoff of the interim cryogenic propulsion stage. Again, this being an 18-minute burn. We are now 248,280 miles away from the moon and continuing to grow closer, 605 miles away from Earth, and continuing to increase that distance. Less than a minute now until cutoff of the ICPS and the end of the translunar injection burn. We've had a good burn all the way through so far. And 1 hour 44 minutes since launch today.
Got to work. Anything interesting happened in the last hour? Only translunar injection over. Oh, it's over Baja California. Guys, you up till I cut off. No, this is limited. Who's it, Manta Ray? He's that guy that's in your group of friends, Sparks. That's a jerk, but he's still around. But he's a jerk. You know, he's a good dude, but he's also a jerk.
And we have cutoff of the interim cryogenic propulsion stage, which has committed Orion to the translunar conjunction. The spacecraft is moon-bound.
I really wish we could get an onboard view here.
Orion is now traveling at 22,500 miles per hour, 247,450 miles away from Earth. Now that the interim cryogenic propulsion stage has completed its translunar injection burn, it is no longer needed to propel us to the moon. It's done its job and it will separate from Orion. After it separates, those 10 CubeSats we discussed will be deployed from the Orion stage adapter, which is below the service module and above the ICPS. Each payload will be ejected with a spring mechanism from dispensers installed on the Orion stage adapter. And again, these will help us study the moon and space weather, test innovative propulsion technologies, analyze the effects of radiation on organisms, and provide high-resolution imagery of the Earth and moon. The CubeSat deploys will start just short of about 4 hours after launch. Once those CubeSats are deployed, the ICPS will be on track for disposal in a heliocentric orbit, meaning it will closely circle the sun until destroyed.
Yep. Hey, Rockets, we did it. So many emotions. You know, people are thinking my voice is going. My voice isn't going. I'm just really happy. It's flying over Mexico right now. How long until ICPS separation? Should be.
The next change we'll see is for the ICPS to separate from Orion and the service module. Those will continue flying free on their journey toward the moon.
I told you guys this would hit different. It's not a Starlink launch, man. It's just not. It's not, dude. It hits different. This is amazing. I really hope we get an onboard video here. This is special, man. It's really something. When NASA launches stuff, you guys see why I want more NASA launches? When they launch stuff, people listen and people pay attention. Nothing's better for outreach.
It's now been an hour, 47 minutes, and 30 seconds into the first flight of the Artemis program. Orion now traveling 21,860 miles per hour. 1,129 miles away from Earth.
It's damn good to see us do this stuff again, Cherokee. You have no idea how happy.
That stage separation from the interim cryogenic propulsion stage, again, should be about 10 minutes after the translunar injection burn is complete, so approximately 7 minutes from now. Shortly after ICPS separation, Orion's service module will fire its auxiliary thrusters to move the spacecraft a safe distance away from the expended stage. Orion continues on an outbound path to the moon, and the Orion stage adapter attached to the interim cryogenic propulsion stage will deliver several small payloads over several deployments.
Now, I know that our European friends helped out with the service module, dude, but seeing all this makes me damn proud to have that on my sleeve. Makes me damn proud. Goldstone has a downlink. DSN is tracking the Artemis 1 mission. Yeah, Zelix, yeah, I know. Just makes me damn proud to wear this shirt. I'm so incredibly proud to be associated with this. It is a privilege. Feels real good, man. TLI burn is complete for anybody that is wondering. We should be seeing a spacecraft separation here momentarily. Night, Rhino. Cherokee makes me damn proud to know we can still do this. It's... All right, Donald. Final RL-10B2 has done its job. That's your house down there. Just think of the B-roll in a few days. I will be watching that footage for a long time, Mutter. Did you ever tie cut? I didn't have my tie cut, guys, but I wanted to wait until the spacecraft separates, but I suppose we can do it now. You know what? Actually, I'll wait. I'll wait until spacecraft separation. I got some of the good stuff here. When will Artemis enter lunar orbit? Near Tiger, it's going to take about 3 days. 3 days to get out there. Yeah, it takes a little while. It's 250,000 miles. Okay, solar panels are moving into the perpendicular position. They're moving into the radial in preparation for spacecraft separation here. If you notice, solar panels are moving forward. Artemis 2 will be Block 2? No, Artemis 2 is going to be the same as this Vasia, but with people on board. So environmental control systems and souls on board. Artemis 3 will also be the same exact variant of Orion with people on board. And then Artemis 4 is going to be the one that has the bigger upper stage.
We're now over 1 hour, 51 minutes since launch today from the Kennedy Space Center in Florida.
1972.
Orion is traveling attached to the interim cryogenic propulsion stage, but not for much longer. We look for that separation to happen in about 5 minutes. At that point, Orion will still be flying attached to the service module, and in this animation, you can see the service module directly below the capsule. Those solar array wings are deployed. The spacecraft now traveling over 20,570 miles per hour, continuing to increase its distance from Earth, now over 1,780 miles away, continuing to decrease its distance from the Moon, 245,150 miles away.
This is a interpolation of telemetry, Hans. So what you see the animation doing is what the spacecraft is doing. I thought they were deciding on whether or not to move the EUS up to Artemis 3. As far as I know, they're not, Cody. But yeah, I really hope we get at least a little bit of an onboard here.
Discovery, go at throttle up.
I can't tell you what a tribute this is to the American working man, and the American working woman too. You can't imagine the kind of people that came together to overcome this obstacle. From all walks of life, all capabilities and limitations. It's all due to their individual efforts. They proved that they could do the job. They proved it for the world to see. And I'm mighty proud to be associated with folks like that. For the people that are saying, oh, Europeans too, it's a quote from John Young, guys. It's a quote from John Young. Relax. Yeah, RTR. Crazy, huh? Could you remind me how many days? It'll be up there for a week. Semana. Uno semana. Stayed up all night in the EU. I'm not just going to go do some groceries real quick and then sleep. I'm just going to go do some groceries real quick. All right, guys.
Hearing confirmation from teams here in Mission Control Houston that the solar arrays are in their proper configuration for interim cryogenic propulsion stage separation. Again, we just saw the translunar injection burn, a successful approximately 18-minute burn that has helped Orion break free from the pull of Earth's gravity and sending us toward the Moon. We're now standing by for separation from that stage now that it has done its job for Orion. However, it still has a job to do. It will help eject some CubeSats that will help us study the Moon, Earth, and the space environment.
If you want to fly our flag today, Civics, I mean, now would be the day.
Orion now traveling at 19,700 miles per hour, 2,270 miles away from Earth.
I got to figure it out.
We're expecting that stage separation to happen in about a minute.
Okay. There we go. The animation is a little bit ahead. There's our onboard view from the solar panel. Oh my goodness, the animation isn't ahead. There's the onboard I've been waiting for, baby!
We have confirmation of the cryogenic propulsion stage from Orion.
No, come back! What the frick? You can't just show that and leave!
With the Earth in the background and the Moon is our destination, Artemis generation, we are going.
How can you not be super hype about this, Leah? Come on! Yep, we are going. Dude! Alright. We're doing it now. Give me the creek. We're going down to the creek. Going down to the creek, baby. You know what I'm saying? We're going down to the creek. Oh. Oh, hell yeah. Cheers, everybody. You just saw some history, man. Damn, that's good. Salute, Squall. Salute. All right, Chetzy. Night, my brother. I didn't get any cigars, Lone Wolf. So I got the Creek. This is my good stuff. This is my favorite, dude. I don't break out the Creek for no reason. Look at that shot, man. Frost, mein Bruder. Ja, jawohl. Frost. Why no stars? Because there's one star that, and the light from that one star that's a lot closer is drowning out the light from all the others. Kind of hope NASA would land back on the moon back at the original landing site to put the fake moon landing stuff. Bullcrap. Nah, hell.
It's been 1 hour, 57 minutes, and 40 seconds since Orion launched atop the SLS from Kennedy Space Center in Florida at 1:47 a.m. Eastern Time. After a smooth ride to orbit, a perigee raise maneuver, and a translunar injection burn conducted by the interim cryogenic propulsion stage, Orion is now flying free, attached to the European Service Module and on its journey to the moon. That might be the end of today's broadcast, but the Artemis 1 mission has only just begun. We'll continue live coverage from
Shinar, Tovarish, na zdrowie.
It's Artemis All Access. It's a short video product that will provide updates about mission accomplishments with a look at what's to come, as well as inside looks and explainers about the mission.
What a good day.
And if you want to stay updated on mission activities and how to watch Splashdown, you can still register as an online mission participant with NASA's virtual guest program to stay informed as the mission progresses. Virtual mission participants for Artemis 1 will receive curated resource and mission activities straight to their inbox. You can register at go.nasa.gov/virtual Artemis 1. That's a Roman numeral 1 as part of the URL. Don't forget, you can also learn about the mission on NASA and Artemis social media accounts.
That right?
We'll be holding a post-launch news conference at Kennedy Space Center at 5 a.m. Eastern Time, 4 a.m. Central Time, and you can watch live at nasa.gov/live. We'll also be back on the air later today for the first orbital trajectory correction burn at 9 a.m. Eastern Time, and again at 10:45 a.m. Eastern to get a look at the first images coming down from Orion. Thank you for joining us today for our coverage of the Artemis 1 mission. We leave you now with a rendition of our national anthem performed by Josh Groban and jazz pianist Herbie Hancock, followed by a look back on today's historic liftoff as we look toward every milestone in this mission. Artemis generation, we are going.
So proudly we hailed at the twilight's last gleaming, whose broad stripes and bright stars
Discovery, go at throttle up.
Sound suppressor water now flowing
15.
under the ML.
Ooh, they're showing
And
a
here we
replay.
go.
10.
Hydrogen burn-off igniters initiate. 7, 6, 5. 4-stage engine start. 3, 2, 1. Boosters in ignition.
Discovery, go at throttle
And
up.
liftoff of Artemis 1. We rise together back to the moon and beyond.
Discovery, go at throttle up.
All 4 RS-25 engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour. Hearing good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis 1. First milestone will be for the vehicle to pass through max Q at about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket.
"50 years after we last left footprints on the moon, NASA's Artemis 1 is our first bold step towards getting us back there and pushing us farther than we've ever been before."
Landing a man on the moon and returning him to safety to the Earth.
Discovery, go at throttle up.
Tranquility Base here. The Eagle has landed.
Nice shot.
Control of the rocket, but the ALS will check, make sure there's no holds coming from the ground up until T-minus 2
GLS
seconds.
is go for ALS.
And we are go for ALS. The Space Launch System is now counting down to liftoff of Orion on its maiden voyage to the moon.
I can't believe this.
Launch team can no longer recycle the count.
Amazing.
Sound suppressor water now flowing under the ML. And here we go.
10.
Hydrogen burn-off igniters initiate. 7, 6, 5. 4-stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond.
All 4 RS-25 engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour. Hearing good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis 1. First milestone will be for the vehicle to pass through max Q at about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket. SLS now traveling 607 miles per hour. You're looking at 8.8 million pounds of maximum thrust. Quiet here in the loops in Mission Control. The 4 core stage engines are throttling down ahead of passing through max Q. Now 1 minute, 21 seconds into the flight, traveling at 1,420 miles per hour. The 4 core stage engines are back at maximum thrust. The next major milestone will be for the solid rocket boosters to cut off and jettison at about 2 minutes and 11 seconds into the flight, so about 30 seconds from now. Again, quiet here in Mission Control Houston as teams continue monitoring the flight of Artemis 1. We're now 16 miles downrange from the launch pad at Kennedy Space Center, traveling over 2,800 miles per hour. Standing by for solid rocket booster jettison and shortly thereafter. Confirmation that the solid rocket boosters have separated, these 177-foot boosters. Now the core stage continues to power the flight of Orion, all four RS-25 engines firing, traveling over 3,400 miles per hour, 46 miles downrange. 2 minutes and 36 seconds into the flight. Hearing nominal calls here in Mission Control Houston. We've still got 4 good engines on the core stage. Next up, we'll be looking for the service module fairing to separate. This is 3 15 by 15 foot fairing panels, providing structural support, protecting the service module. Those will separate at about 3 minutes and 11 seconds into flight, and very shortly thereafter will be followed by the launch abort system separation. Just over 3 minutes into the flight of Artemis 1, now traveling over 4,060 miles per hour, 83 miles downrange. We just had confirmation that the service module fairing has separated. And that the launch abort system pyros have fired, separating those from Orion as well. For future crew members.
Yeah, that's when the mic went out. It's alright, I'm just taking it all in, you know? That's when the audio.
We just heard the call for 3-engine press, meaning if SLS were to lose an engine at this point in the mission, we could still achieve a nominal mission. We would just have an extended main engine cutoff time. However, we still have 4 good engines, all at maximum thrust right now, powering the first flight of Artemis at 5,200 miles per hour, 148 miles downrange.
All right, dudes. We saw this already. Well, I hope you guys enjoyed it. It's not every day I bust this stuff out. But man, was that cool. I never saw Saturn to the shuttle. This was something incredible. Apollo, hopefully, like I know I keep saying, you know, oh, I told you so, I told you so. Hopefully you see what I mean when I say that NASA needs to launch more, not less. I spend almost every day, every waking hour, almost every stream, mentioning why they need to do this more. Do you see what I'm talking about now? Does it make sense? This needs to happen more, not less. And like, I can't say it enough. I'll say it till I'm blue in the face. It's so important. You see how that hit different? It hits way different. It's a totally different ball game. You know? It's a totally different ball game. For a lot of people, this like what was just said, I guess it's fun, isn't it? This is their first time seeing those shuttle engines light up and those boosters ignite. Hopefully you understand what I mean when I say that we need to do more of this, you know? But that's where I'm going to leave you guys. To me like nothing else since I was standing on the jetty in July of 2011. Yep. It's pretty cool. It's pretty cool. I'm proud to have shared it with you guys. I'm proud to be a part of it in some way. It really, really makes me happy, and this is just the first mission. But I think that's where I'm going to call it.
Go at throttle up.
Our uptime. Hey, ARJ gifted a sub to Pythos. Thank you. You guys gifted a ton of subs today. A lot of bits. I thank you very much. if I could shake everybody's hand in here, I absolutely would. John Young style. So we just hit the 16-hour uptime. I'll see you guys tomorrow. And on the stream, you'll be getting updates throughout the whole mission as much as we can, okay? Here you go, Noble. I'm going to bed, Donald. Thank you, guys. Thank you for doing this. Thank you for watching it with me. I appreciate it. You could have chose a bunch of different people streaming it. You chose coming in here, and that means a lot to me. And I will make it worth your while watching this stream. So, thank you very much for watching. Have a good night. I'll see you tomorrow. Maybe we'll track that oil leak on the truck or something. But that just seems so freaking trivial compared to this, huh? It's freaking dreams, man. Freaking dreams. Thank you. Talk to you guys tomorrow.